just do it, it'll turn out okay. Hey everyone, it's been Unedited here, and I'm back for more podcast goodness of talking with caffeine. I got my two guests here today. One's been here, one's been on them before. Other one's a brand new one. All right, introduce yourselves.
Hi, I'm Brian. My channel is Brainbug, where we talk about arthropods and we talk about science and we learn science via arthropods.
I like the practiced intro. I'll just go ahead. So I'm Walker. I have a reasonably small YouTube channel, Just Walking Fish. It's been pretty inactive for a while, but I like talking about science in general, just biology in general, and also, creationist debunking stuff is another pet passion of mine.
Always good. And welcome to our alternative viewing besides anything else on TV.
Yeah, have to tear away from it for a little bit. Honestly, it's good for a break because it's been too stressful.
Yeah,
way more stressful than it should have been.
Been watching States a little too closely here. So I said that to Dapper Dino earlier, and he's in the live chat there. Thank you for streaming something different tonight. That was much appreciated.
That was nice. I was listening along. I wasn't typing in chat, but I was there.
Yeah, we had PZ Myers on tonight, so that was something different too. So,
what channel?
Mama Atheist. Yeah, she's a climate scientist. Me and her do a lot of collabs together. She's pretty cool.
Nice. Well, a few weeks ago or months ago, however how long it's been, Walker was on my channel here, and we talked about how us as tetrapods got to the land, but unfortunately, we weren't the first ones to make it.
Yeah,
not by a long shot.
And because of that, there's a lot of ecological niches that tetrapods never even had a shot at, especially on the micro scale.
Mm-hmm.
Arthropods beat us by hundreds of millions of years onto land. We have fully terrestrial myriapods from the Ordovician. So, I mean, you're talking a long time, but to kind of get to why we got there and how we got behind and then kind of moved into the larger scale niche, we kind of got to go back to the beginning. I had, let me see, we'll start with that one. There we go. So, Walker, you want to talk us through what we're looking at here?
Oh, well, this is so I'm not a huge Evo Devo guy, but this is just embryonic development, right? So this is the most basal bilateralian split. On the top, you have the protostomes. The bottom, you have the deuterostomes. The deuterostomes, the blastopore opens and it becomes the anus, whereas the blastopore and protostomes opens and it becomes the mouth first, right? And so us and echinoderms would make up pretty much all the deuterostomes. There's also like hemichordates. And then like spiralians and arthropods are the two main groups that are protostomes. Of course, there's other groups though. There's a bunch of other groups that are protostomes.
Protostome is a lot of they're
substantially larger.
And they're very different.
Yeah.
I mean, I know that there's deuterostomes that are very different than tetrapods as well, but
So these are
protostomes, things like they're am I cutting out?
Yeah, you're cutting out a little bit for me.
Yeah.
Okay, sorry. Well, I was advised that with protostomes, you have like chitin, like the basically that's what their exoskeletons composed of, and you find that more so in like funguses. Then you don't really find chitin too much in deuterostomes. I mean, you do find it in fish scales and things like that, but it's really shines up here in protostomia.
So are these two are these every groups of animals except for like sponges and jellyfish, give or take?
Pretty much, yeah. The only ones outside of it that I can think of would be like sponges, jellyfish, and comb jellies, which are called ctenophores. And then also, what is the other one?
Sea anemones?
Sindera, but I think that includes
Cnidarians, but
yeah.
I'm thinking of there's this it's like a very small clade. It's like xenoflagellates or something. It's some weird name.
Yeah.
But there's only like 40 or 50 species. It's a very small taxa.
Primitive too.
Yeah, it's right outside of Nephrozoa, but it's bilateralian.
And this split happened before the Cambrian, right?
Yes. It probably happened in the Ediacaran, maybe earlier. I don't know. What do you know about this one?
Let me see. Well, let me pull that time scale up here. So I would somewhere I would think that that we're looking at least back into the Protozoic era as far as the split between Deuterostomes and Protostomes, but it really doesn't. They split back then, but life was very, very simple at that time. So there wouldn't have been even between these two clades, there wouldn't have been that much diversity, at least not in their earlier life stages. Now, the interesting thing about the Protostomia is the life cycles that you start to see, especially as they trend towards arthropods, where you see different stages of the life being vastly different. Where in Deuterostomes, you mostly see just a enlarging of the adult form looks a lot like the neonatal form, I suppose you'd say. But with Protostomia, you start to see them develop and change anatomically quite differently.
Well, for a long time, weren't Protostomias the top predators? The top predators, like with the.
Oh yeah, all the way up through. Well, in the oceans, up into the. I want to say like the Devonian, when you really started to see placoderms begin to dominate, but before that, especially Eupterids.
It's when we got the jaws.
Yeah.
Well, so late Silurian. So you don't really see true fish until late Ordovician, early Silurian. Before then, most deuterostomes are more or less going to be like worms, cephalochordates, that kind of stuff. Once you get the jaws, that's a really big breakthrough for our lineage.
That's but when we talk about coming onto land, it really took place somewhere early on in the Ordovician, because we had myriapods that had we have fossils of those in Ordovician rock that are fully terrestrial. So this isn't even a coastal animal or something that may have come onto land. This is something that was evolved to live specifically on land. Ordovician, I mean, that's a long time ago. That's prior to that, so a lot of people, when they think of the quintessential first arthropods, they think of scorpions, and a lot of that's to do with Walking with Monsters series. But scorpions. So scorpions didn't really show up on land until the mid-Silurian, and even then, the ones we had were like semi-marine or allegedly semi-marine. It's different.
Yes. Real fast. Speaking of that, one thing, did you guys ever see the series Animal Armageddon?
Animal Armageddon. Is it about extinction events?
Yeah, it's about the 5 extinction events, or 6 of them.
No, I don't. I don't think I have. But would you know when that aired?
A few years ago.
Yeah,
like a six-part series. Talked about the 5 extinction events. Dinosaurs had 2-parters, and they also talked about the eruption 70,000 years ago.
Yeah. Well, I just wanted to say, just a quick, time scale, because for me, at least, deep time is incredibly hard to conceptualize, right? The myriapods and the scorpions would have beat us. They would have beat Tiktaalik by more time than we exist after the dinosaurs, right? So there's about 65 million years between us and dinosaurs.
Well,
and there would have been about 100 million years between Tiktaalik and the earliest land arthropods.
Well, they were Ordovician, and we weren't until Devonian, give or take.
Yeah, late
Yeah,
Devonian, and then there wasn't fully terrestrial tetrapods until like early Carboniferous.
Yeah, that's when the tetrapods really started to challenge uh, land niches and started to kind of push back against that. I think as you saw the oxygen levels drop at the end of the Carboniferous is really where that balance kind of shifted.
Mhm.
But
Speaking of oxygen levels, real fast, were there any plants, some kind of plants or fungus on land by the time the proto got here?
yeah, there was different. They would have been more like I want to say like lichen kind of. I'm not real familiar with the plant life at the time. I'm sorry, but plants always kind of bored me.
Yeah,
But
no, that's fair.
but yeah, there were plants on land. They weren't. I imagine they weren't very developed. But
They're mostly non-vascular at that time.
yeah, that's the word I was looking for.
Yeah,
But
that's what I was guessing.
we were talking before the stream about this image here and how we're kind of anthrocentric by as the closer you get to the current period, the more concisely we start dividing little time periods up, like the Holocene, ridiculously tiny. But these periods down here, these whole sections here would fit into these the red area here, each one of these multiple times. These are ridiculously long periods of time. The image doesn't do it justice. I understand why they do that, but it kind of gives you the impression that the Proterozoic would fit, within the Paleozoic. That's crazy.
Talking about this earlier, I know that K means 1,000. I've done it before, and M's are million, but I never heard of a G meaning a billion before.
I don't quote me on this, but I want to say it has something to do with like German or something like that. It has something to do with like a different language, which is why it's not BA, it's GA.
Okay.
Yeah. But this is okay. So you have in the Ordovician we have the myriapods. Now myriapods still around today. You got your millipedes, you got your centipedes, and then you have the Symphyla. I think I said that right. Symphyla. Okay, it is a myriapod. It's a little bit different. It's than the centipede or the millipede. It has less legs than either of them. It almost looks like a silverfish. So this gives you a kind of an early example of diversification. When you look at the simple body plans of these myriapods, and when they're another interesting factor about them is that when they're when Symphyla, when millipedes are too, but when Symphyla more so than anything, are first hatched, they only have 6 legs. So you see the divergence with hexapods, with insects. From there is almost a example of neoteny within arthropods that led to the entire insect lineage. So having 6 legs is a neonatic feature of myriapods, and since that's the group that insects split off from, we can kind of trace that back, that evolutionary history.
So do we know which branch got the land first?
No, but the myriapods are the earliest that we have definitive fossil evidence. There's some trackways and stuff, but when you get back that old, it's hard to define what creature they're from.
Yeah.
So how many different like independent colonizations of land did arthropods have?
Well,
it's at least 4 or 5, right?
Yeah, because you have so myriapods and crustaceans, insects, which could say that the insects evolved on land. So they didn't. Insects. The insect clade's not a clade that was.
Were hexapods like already terrestrial at the time when insects came about?
Yeah. so the ancestors would have been like silverfish.
Mhm.
I don't know if you've seen silverfish before, but they have kind of a unique body structure, and it's like this symphyla. If you want to say symphyla is actually very similar in structure, and you can kind of see where they diverge from one another. So that's the current standing on that. But technically, if you look at the way that they have Protostomia divided up now, in more recent years, insects actually hexapods fall within crustacea or pancrustacea now. So insects are technically now classified as crustaceans. Yeah,
I like that one.
And you can the only crustaceans that we have, terrestrial crustaceans that we have around here are isopods. But isopods are a very diverse grouping of crustaceans, and they're one of the earlier pioneers too. The isopod group is really, I think I would say as far as crustaceans go, they're the most successful in colonizing the land niche or the terrestrial niche. But myriapods and centipedes, millipedes, they've been here quite a long time. And then we have, so what were we doing? I was listing off the groups. Okay, so you have arachnids with the scorpions. Scorpions and spiders, of course, have diversified from scorpions. But
did arachnids also evolve on land?
No.
Were they so arachnids and like multiple individual lines came up from the water?
Yeah, well, you'll have scorpions. Some of the earliest scorpions that we have in the fossil record are completely marine or aquatic.
So were these like the big
like Eurypterids?
I'm sorry. So were these came to land first? Were these the bigger scorpions, or were these the smaller ones?
The ones that came on land, the earlier pioneers. Well, what do you have? You have Brontoscorpio or Brontoscorpio. Let's see when that. I'm not sure if that was one of the first ones. I know it was one of the largest ones, and it was semi-marine, but I'm not sure if it was the first one to.
Was it a true scorpion or was it a Eurypterid?
Brontoscorpion.
Yeah.
Brontoscorpio. It's not a true scorpion. No, not in scorpions. But let me see here.
But Eurypterids actually nest outside of Arachnida, right?
Yeah, but Brontoscorpion, I don't think it was a Eurypterid. Let me see here.
No, it says it's a true arachnid. I just looked it up.
Yeah.
So that's really cool. So it was semi-aquatic, as you say.
Yeah, it was. And that's the one that I was talking about. Walking with Monsters. That's the one they always had on there. Catching,
the giant dog-sized one.
Yeah, catching the early pioneer fish swimming across the.
It only got eaten by that even bigger scorpion.
Yeah, that got eaten by a. That was a Eurypterid, wasn't it?
Mm-hmm.
That ate it. Yeah, so Eurypterids nest outside of true arachnids, like Walker was saying, but they didn't have too much success on land. I think that some of them did make that step, but I don't think they found too much success. I don't know if it was because the niches that they were moving into were already occupied, maybe.
Well, they already had the legs to get on land.
Well, that was one of the things that made Eurypterids so successful was they had so many diverse legs. They're like Swiss Army knife arthropods. They had legs that could, that would for swimming, legs for digging, legs for catching prey. They had legs, and this is all on one animal. It was they were amazing creatures. It's unfortunate that none of them survived, so we could see them. Their eyes were also fascinating. The way that they saw, they had like eye stalks with clusters on them. Not every species, but Eurypterids. And they filled so many niches in the ocean biomes at the time when there was. So you got to think back that there's no vertebrates. gastropods. Well, you had maybe some. Well, you would have had gastropods and then different diverse families of Eurypterids, and these oceans would have been very different.
And like giant squids, octopus, whatever they were called. I forget they were called.
The giant cephalopods. I forget what they're called. The ones with like the really long cones, though. They were like 10 meters or something. It was insane.
Yeah, and what am I? It starts with an A. I can't think of it because I'm trying to think of it. Give me a minute.
What are you referring to?
The gastropod, or not gastropod, the cephalopod you all are trying to think of. The names escaping.
Oh, like ammonites, or
yeah, there you go.
Yeah,
that's what I was trying to think of. It wasn't going to come to me. But so all these niches that we see now filled by vertebrates, like there was filter feeders. I mean, there was filter feeding Eurypterids. So they had their heyday in the ocean as well. Our arthropods did, but that didn't last nearly as long.
My favorite species, it was like it was essentially the Ordovician whale shark, and it was actually a species of Dinocarid, right? So it was a relative of Anomalocaris, and it began with an H. Herdia, that's what it's called. Yeah, so it was like about 1 meter, 2 meters long. It was one of the biggest organisms that were in the Ordovician seas, and it was also one of the last surviving radiontids, I think is their name. But like the lineage, the panarthropods, they nested right outside of true arthropods that contained Anomalocaris and Opobenia and all those other, extremely weird Cambrian aliens.
Yes, I'd just love to be able to go back and just look in that ocean. When he says biggest, they weren't
huge.
Yeah, like you're talking.
They weren't actual whale sharks, but most organisms in the seas were a bit smaller back in the up until the Silurian.
Well, some of them. So they try to eat us if we went back in time.
Well, you would be the big. If you went back in time and swam in the ocean, you'd be the biggest thing. Well,
you'd be the
biggest thing. There was some Eurypterids that got like crocodile sized.
Echolopterus.
Yeah, mostly like later on and like more towards like the Silurian, but they got pretty big. I still don't think they would have been able to there would have been they would have been macro predators. We'll just put it at that. They wouldn't have eaten things bigger than them. It's because
why would you when you can eat something smaller than you and you don't have to worry about hurting yourself, Right.
And they got pretty big on land too. It was that oxygen thing that we were talking about earlier. Up into the Carboniferous, the arthropods had this great advantage because the oxygen levels made respiration through spiracles a superior breathing function for that time period. And I mean, there really wasn't much competition for it, and they could get huge and be very efficient. And they had what gave them an advantage on land is the softer bodied competition, like gastropods that we talked about earlier, and of course early tetrapods even, is that they were already rigid. Arthropods were already capable of supporting their weight without the additional buoyancy of water because they had these rigid exoskeletons, which is the advantage of the chitin. Now, chitin's interesting. In our lineage, we see more like a keratin being more prominent, and they serve a similar function. Chitin's actually what funguses get their pseudovascular structure from. When you see a fungi that's able to grow tall and grow full and big, and back during these early periods they really did. There were some huge funguses, but they grew with chitin too, which is a really strong polymer based material. Now having that advantage, when they came onto land, they were already able to support their weight naturally. They had armor serving the same purpose, and most importantly, protection from solar radiation, which was also more prevalent environmental hazard at that time.
Yeah, did we have an ozone layer yet by this point?
I think we had so Walker, correct me if I'm wrong here, but I want to say that by the Archaea period, that there was a atmosphere developed.
Yeah, there's definitely an atmosphere by then.
And
the Hadean is when there was like a lot of volcanic activity and stuff, and it was a lot more tumultuous. But I think things had started settling down by the Archean.
Okay,
because that's when we have the earliest what are they called? Like the big lumps of single-celled organisms that are like preserved in Australia.
I know we had the oxygen in the water first and stuff. I know we had the oxygen and the major oxygen in the air yet, enough for support.
So how far back are cyanobacteria? Because I know that's when we really started to see the
Great Oxygenation Event is when cyanobacteria first appeared on the screen or the scene. I don't remember what specific time period that is. I always crap on people for like just lumping all of the Precambrian into one thing, but I sort of mentally do that. So
I still know. I can't talk.
You're good.
Why they don't consider that one of the big 5 or 6 big extinction events, oxidation events? That a lot of creatures died then too, didn't they?
Yeah. Well, I think it just goes back to us being so anthropocentric, right? If they look like us, if they have backbones, or even if they don't have backbones, but we can measure their diversity on a macroscopic level. Then
I guess.
Yeah, then people, if you can't look at something and see, obviously, if you can't look at something and see it, that's a dumb statement. But if you can't macroscopically look at something, a lot of humans just don't really care about it. And I feel like that's probably the case for the Great Oxygenation Event.
Yeah, back when oxygen was evil oxygen.
Yeah,
and everything.
Well, it's the thing. They were so good, they were so successful that they killed themselves. Is what we had happen back then. They the biotic mats that covered everything back then. They were just so successful that they just sapped all the resources and totally changed the environment to propagate their own destruction. When you start having
the first true terraformers.
Mm-hmm. And that's where that's really where we start to see arthropods come into the scene too, tearing through those biomats. I get that too. Wanting to that's like this image perfectly punctuates how little attention this stuff gets. It's because the fossil records kind of like you said, we have that really old rock in the central Australia. It's about the only place I can think that we have a fossil record from that long ago.
Yeah, for some reason Australia is just really good at preserving old rock. Like, also, I'm pretty sure the all the Ediacaran rock that we have comes from Australia. So, I mean, I'm probably wrong about that. I'm not a geology person. There's better people to talk to. But at least the major Ediacaran fossil beds are from Australia. So, I don't know.
So then we have the Silurian as when we had arachnids kind of move into the main scene.
Yeah, you said they got the long time ago that you said they had plenty of time to diverse before we got there.
Yeah, this was during this period right here, as we were saying. I don't know if we said it before the show or not, but we really didn't see tetrapods make it onto land until way up here. So I mean, they had all this time period. We had the diversification, and it was essentially tetrapods never had a chance to occupy a lot of these niches, especially on the micro scale, because the reasons I was going over earlier about why they were so successful on moving on to land. They were also successful in occupying these niches. Of course, things back then, like we're saying with the ocean, things were so much smaller back then. But there were some huge animals. There really were, but for the most part, everything's relatively small. And so these these micro niches that we see occupied by arthropods today, that's when they took those positions. That's when they put their pieces in place and have largely stayed unchallenged, because at that scale, even today with our depleted oxygen levels, there's really no competing with them. Anything that size is just going to get bowled over by the success of arthropods and the years and years and years that they've had to specialize to those environments. The hundreds of millions of years that passed through here while we were still struggling to develop a jaw.
Yeah,
they were there. I mean, most of the clades that we have today were already well established by the time the Carboniferous kicked into gear.
It's funny to think about to me.
Yeah. So, well, you see a lot of creationist talking points when it comes to arthropods found in amber and in fossil records, to say, oh, well, look, it hasn't changed. It's still the same. It's because they took those positions. They spent hundreds of millions of years specializing to them, while tetrapods were still, like I said, squirming
around like a seal. Yeah.
Yeah. And were able to just latch on to those positions and get better and better and better at living in that environment, that they didn't need to change. That by the time that tetrapods, there were niches that, because the oxygen levels dropped, that they were no longer able to occupy the large terrestrial browsers and large terrestrial predators and stuff that were easier. Well, when I shouldn't say easier, but because tetrapods weren't exactly athletic back then. You're talking a lot of amphibians where we have
get from water hole to the next water hole.
Right. Yeah, they weren't, but they were still formidable animals as far as that goes. As far as what competition they had around back then, it wasn't the necessary competition with the tetrapods that led to their decline as much as the oxygen levels depleting. But that opened up those larger animal niches for the tetrapods to move into, because they sure as heck weren't getting into those microcosm niches that insects had really, really specialized in.
That and the little amniote egg.
Yeah, right. And I mean, when you get into the Mesozoic, you really see arthropods take a strong position on the microcosm, because you have Hymenoptera, which is a fascinating line of insect that are eusocial. I mean, they look similar to the ones that we have that we have now, that are most similar to these ones that the earliest Hymenoptera are the sawflies. They're less social and more kind of a primitive biology. But when they took over that position in the environment, they really are able to compete with much larger tetrapods. So an ant colony can hold its own in pretty much any environment. So they're still competing with us, I shouldn't say with us as far as pods go, but they're still competing on kind of our level, even though they're much smaller.
So our first air flyers were in the Triassic and the pterosaur line. When did our Protostome cousins get to the air first?
Well, that would be, I believe, in the Carboniferous. I don't think we have any wings older than that. Let me double check that though, because I know
there's definitely, what's that one like giant? It's not technically a dragonfly, but it nests just outside. It's like Hymenoptera, I believe, is what it's called.
Hymenoptera,
yeah. And what's that specific family that they're in? It's some sort of fly.
Well, it's the same family with or not family. It's the same clade though with dragonflies and damselflies. Let's see. I was looking to see. I didn't want to.
Griffin flies is what I was
speak
thinking.
speak out of turn with Carboniferous. Okay, so we were right. I wanted to double check that. I hate.
Well, wings are pretty basal to the insect clade, right?
Yeah. Even like flightless insects now, like beetles, for instance, the vast majority of them are descended from flying ancestors.
So would the last common ancestor of all insects had wings?
No, because silverfish are the most basal insects that we have now, but most of the major clades have a common ancestor that was winged.
Okay.
Yeah, it's not. I would say it's not fair because we had all three or four of our species, the dinosaur birds, the pterosaurs, and the bats had to modify arms to make wings, but they got extra.
Yeah, it's crazy. So I was doing research about like wing homology and all that kind of stuff. And wings are just so basal to insects that we don't know what that structure is homologous to. Like we just have no idea.
Well, remember that did you look at that paper I sent you with the
Hymenoptera ones?
No, the one about wing development that they looked at the beetle embryo, and that its wings were like modified. I have to pull the paper up. It was really cool though. I think I sent it to you, didn't I?
Potentially. Did you send it to that paper sharing group chat, or did you send it to
this was before that. This was
maybe. It sounds familiar, but I'm not completely sure. Yeah. It's all right. I'll look into it later.
It was something I had pulled up to when we were talking about that meme about wing development. Essentially, yes, I'm saying that, and because it was the papers I shared with that group where that was posted, and I love trolling that group. I just drop in science papers in there and going to bed for the night and getting up and seeing all the
Facebook group.
Yes, it's that Kent Hovind Facebook group. It's so much fun there.
You haven't got banned yet?
No. Well, I don't know if you picked up on this, but I'm like super friendly. I like sometimes obnoxiously so. Author and year. Oh, yeah, Speed probably does have that that paper on hand. I think I send it to him too. Anyway, yeah, but I don't want to get distracted on that. But it was really about why and how wings developed. Well, of course, it's all theoretical or hypothetical. I guess at this point, there's not even a sound theory. I don't remember the authors. Speed. Sorry, I'm kind of scatterbrained tonight. It's been a lot of ups and downs.
Yeah, it just seems like, I mean, that kind of makes sense just because the wing development is so old in insects, and insects kind of suck at preserving because chitin breaks down easier than
right
calcified bone.
It's either going to be an imprint that just happened just perfect, or amber. And with amber, we can only go back so far. We definitely don't get back into the Permian with amber. Yeah. We don't get past the Mesozoic with amber preservation. But we can learn a lot of. I mean, we've learned a lot about, like, for instance, the evolution of spiders from amber fossils, because that's when that happened. Early Triassic is really when you start to see that divergence from scorpion-like ancestors. I say scorpion-like because the arachnid family tree, when you get back that far, is not really concise. They don't have a full understanding of who came from what, where amblypygi fit, for instance, among the olipine, the harvestmen, or true scorpions, with things like the whip-tailed scorpion. They're not sure exactly when they diverge and which line diverged first when you get back. I want to say that we have true scorpions as far back as the Devonian, but I shouldn't say true scorpions. That we have scorpions that fit within the clade that we call scorpions now. But it's a direct line back that far with scorpions. But as far as the rest of the arachnids and when they diversified and who split off first, it's really kind of a crapshoot and depends on which model you want to go with. I think there's a lot of lines back when you get back that far that are like that, where there's different models. I know, for instance, like turtles, their line, how they fit into among the other reptiles, for instance. It's kind of a similar situation.
So was it the Carboniferous or the Devonian where we became less prey and more predator?
The Carboniferous. Well, on land and in the water. Because in the water, in the seas, yeah.
It's like Devonian.
Yeah, Devonian, because you got placoderms. Placoderms, like they exploded. You want to talk about the Cambrian explosion, the placoderm explosion in the Devonian. But that's when we really start to see large fossils being preserved too. It was really a great time to study morphology of tetrapods, at least, or leading towards tetrapods. Because we're all placoderms, right?
Yeah, placoderms were paraphyletic, right? So they included the last common ancestor of us and chondrichthyes as well, right?
Yeah, and it's paraphyletic. Yeah, now for a long time it wasn't considered to be, but as well that's the thing with our classification system as it is. It's really just setting goalposts where we say.
I know before they thought they split off before us and sharks, but now they're our ancestors now.
Yeah.
Well, yeah. So I'm pretty sure what they think is they did split off before us and sharks, but there's some placoderms that are more closely related to us than to other placoderms, right? So Placodermata is like, I think that's their technical name. I don't know, but placoderms are like an evolutionary grade essentially that contains everything that has a jaw that's more derived than whatever, or lungfish are. Why am I forgetting the word?
Why am I
Sarcopterygian. You're good. Like the hagfish, is that what it is? I don't know.
that's what I was
Lampreys and hagfish. Anyway, something like they're more derived than the earliest jawed fish, but they're less derived than osteichthyes and chondrichthyes. I don't know. I need to review my basal fish phylogeny, I guess.
You're right. It was hagfish that I was trying to think of. I don't know why I said lungfish, but they're another milestone though for tetrapod evolution anyway. Lungfish
are cool, yeah.
Are good.
Yeah, don't get me started on lungs. We already did that one.
But speaking of lungs and stuff, the first people ones on land had different breathing than we do, obviously.
Spiracles and arthropods. Our book lungs have actually made some. Book lungs are what tarantulas and megalomorphic spiders actually have that allow them to get a little bit bigger than on average than what you see in most arthropods. As book lungs actually allow them to push more oxygen through their body. Spiracles, excellent. Like when we had high oxygen levels, they could get really big and absorb a lot of oxygen just through those spiracles. Because spiracles is basically like an open pit that lets the air kind of flows through, and they can pump it to get more energy. But even in a dormant stage, they are still able to absorb enough oxygen at a small scale like what we have now. Being still, there's nothing moving, and they're able to respirate. And they can pump,
you probably don't mean like monster movie big.
No, well,
Arthropleura.
Yeah, Arthropleura was so.
It was Carboniferous cow.
3 meters. we have, and they weren't, and that's not 3 meters skinny. They were wide too. They it was the structure of their carap. Where am I at on camera? Here we go. The structure of their carapace was almost like water buffalo horns.
But they were still plant eaters. So
yeah. Deuterovores. Most myriapods are, except for centipedes, which are highly predatory.
Yeah.
There was a time where they.
I'm sorry.
No, you're fine. There was a time where they would try to spin Arthropleura into a giant prehistoric centipede, but it really wasn't.
No.
So something.
I was actually looking into his phylogenetic, well, not phylogenetics, obviously, but his phylogeny recently, and it actually nests as a true millipede, which is interesting.
Yeah, there's ones that they're so tiny they look just like it, and they're so cool. I had one once. They don't live.
Feather millipedes, right?
Yes. How'd you know?
Well, because I was looking this up like 2 days ago, I swear. Yeah, so that's actually what I thought was really funny, because Arthropleura's closest living relatives right now, yeah, they grow like an inch or two. But like back then, you could have ridden this thing to work. Like
yeah. We have most of the trackways are in Scotland. I think there's some in Canada. But most of the trackways that we attribute to Arthropleura are in Scotland. But you can go and see them, and they're huge. You could lay in between its legs. That's how monstrous these myriapods were. But yeah, they're surviving descendants. I've had feathered millipedes before, but they're maybe 5 centimeters long. It was the biggest one I had. So they're tiny, less than 2 inches. They're adorable. I wish they lived longer, but I've had a few.
Can you get them to breed and just get like a population going, or
you probably could. I think it might take some trial and error. I don't know if there's a lot of there might be some breeding information out there, but I know they'd want it moist. In their Deuterovores, and Arthropleura was a Deuterovore too. Ate a lot of waste off of the would you really call them forest in the Carboniferous? They weren't really.
You could probably say forest,
trees,
just because
yeah.
trees aren't a monophyletic grouping.
Yeah, it's a colloquial.
So you could just say like lycopod forests. I think that's a fair.
Yeah, so they definitely weren't the probably weren't the trees we have now, and the pines and the flowering trees.
I like to envision Arthropleura. I don't know how accurate it would be. Is the large grazer of its time period, but large grazers. It makes you speculate on what the large predators that may have been. Now, when I was a kid, there was a like I said, mentioned walking with dinosaurs. There was a misconception about this Eurypterid fossil that they
like Arachnid.
Yeah.
That
they thought it was a spider, a giant spider. So I'm like, oh yeah, there's this huge spiders that lived back then. That's really not true. We had the biggest spider that we know about ever exist right now. It's the Goliath bird eater, Theraphosa blondi. But so there was no fossil record anyway of any giant spiders living in any Triassic or earlier forest. We would expect, if we found something like that, it would probably be in the Carboniferous, but I don't think even spiders were around back then. I don't think there's no fossils of it.
If I remember correctly, in the Carboniferous, they were big, and their amphibian cousins were kind of big, but us as amniotes were still on the small side at this point.
Yeah. Well, so that's a whole thing. It's really funny because the roles were reversed for a short time, as we've been talking about. But that's primarily because of an ecological effect called niche crowding, right? So if an organism is already inhabiting this specific environmental, niche, the thing that they live in, right? Their lifestyle essentially, then another organism isn't going to adapt to fill that niche. right? If you already have a large grazer, you're not going to have a cow evolve because there's nothing for the cows or the intermediates to eat and become more specialized. So it's pretty funny because arthropods are much better at being smaller because their chitinous skeletons are proportionally more strong when they're smaller, right? There's beetle species that can get run over by cars and they just walk it off like they're champs. And our internalized skeletons with our respiratory systems make us much better at getting big. But since we couldn't get big, there was like an ecological barrier preventing us from, becoming the dominant life forms. We eventually broke it in the Permian.
Yeah. So
we didn't break in; they broke down because they
it was the oxygen. But
was it the Carboniferous rainforest collapse that spelled a downfall for the arthropods and insects clades?
Yeah. I mean, there's correlation there. Definitely, I would say that it's pretty well established that was a huge contributing factor to the decline in large terrestrial arthropods.
Correct me if I'm wrong, but also don't arthropods usually require more humidity because of their respiratory systems?
Different groupings do, but to maintain larger sizes, they maintain and reach larger sizes in a more humid environment. Generally speaking, of course, there are exceptions. Certain I don't know, when it comes to scorpions, they're kind of a special case because they've been when it comes to special, I say this as I'm watching my desert scorpion dig a hole up here. It's just scuttling away. I wish I could show it to you guys. He's being all active, but yeah, so that's what gave me pause to say they needed more humidity, because there are some desert arthropods that get pretty sizable, but they're also generally like one of the larger predators in their environment, because tetrapods do very terribly in in desert environments.
Mm-hmm.
So short of snakes, like scorpions and large spiders,
centipedes as well.
Yeah, desert centipedes, but centipedes actually require a lot more moisture than arachnids or insects, because they don't have the waxy surface on their cuticles, which makes it so they dehydrate a lot faster. So that's why I have this centipede preserved this way as opposed to preserved like I do my insects and spiders, because otherwise you wouldn't be able to see how big and massive it was, because
start shrinking.
They shrivel so much. It's ridiculous. It would that would be such a tiny centipede. I mean, insects and arachnids, they shrink too a bit.
Mm-hmm. So after your pets die, do you mount them on the wall?
Yeah. This one was my co-host for the first 8 months of my show.
It's a little morbid, but whatever works.
And now that always will be your co-host forever, right? And ever and ever.
But I don't think about it as like their corpse, I guess. It's more like keeping a lock of someone's hair or something, I guess, to me. Because they would shed that and still that would just be what they like taking off their clothes.
Mm-hmm. I think that reminds me. Can you get DNA from a molted from molt?
Yeah, you can. Should be on the inside of the chitin. You should be able to get a DNA swab off that. Pretty substantial one too. I think that probably the best way to go about it. Most non-invasive anyway. Wish you could get DNA from arthropod preserved in amber, though. That'd be awesome.
Yeah, stupid DNA breaking down out there so long.
Yeah, someone needs to work on that.
Yeah,
but anyhow, so I was talking about centipedes needing more moisture, so that kind of limited, and that I should say that covers other myriapods as well. No, they didn't develop that feature that we see in arachnids and insects. so they have to stay in a moisture environment. Isopods is another group that has to stay in moisture environments for similar reasons. So even like a desert biome, they need some place that they can retreat to. There's desert millipedes too. Actually, I was talking to Walker about that just the other day. We were talking about buying desert millipedes. Do you want to see one of the ones I was talking about? So you can.
I would love to.
How big they are. Yeah, I have it right above me here. So
I don't know why. I just want a thick, meaty log with hundreds of legs.
So just check it out. Check out my shirt.
Oh, I love that. Is that American Nassia or Nassia Americanum or whatever? The American giant? Yeah.
Yeah.
I've been doing a lot of arthropod research recently.
They do like to spend a lot of time curled up. But when this one stretches out, it's, I don't know if I can get it to or not. I don't want to torment it too much because it'll release some goo on me. It's essentially poisonous.
Mm-hmm. Yeah, make sure you don't eat it.
Yeah, but when they get disturbed, come on, straighten out. When they get disturbed, they can do that sometimes.
I'm still alive.
That's so cute.
Isn't he adorable?
Yeah, I don't know. Like, since I've been spending most of my time in my dorm and all my classes are online, I want like a little friend. And all of my friends are arachnophobes. So I can't get any like tarantulas or amplegians. I really want a tailless whip scorpion. Like that's
well, they're not venomous.
I know. They
So
just
is
look
that a
creepy to people.
herbivore
I think they're
or
adorable.
This is a herbivore. I give it like leftover from when we make dinner, the vegetables or whatever, cutting up like squash and stuff. It likes that. Fruits they really like. I also give it beetle jellies and give it some calcium powder on there to keep it.
So have you ever fed any of your friends to your other friends?
Well, that's the thing. People will ask me how many bugs I have, and it's like, well, I have, a dubia colony. I have a mealworm farm. I have these fruit fly cup things that are
Fruit flies. Have you made your own fruit fly? Have you made your own fruit fly speciation event thing?
No, but
is a better question like how many species you have?
Yeah, that would probably be a better question. Which is something like I don't know. It's not too many, like a dozen maybe.
It's pretty good. More than I've had in my house at any given time.
You said how many bugs you have. Are bugs and insects the same thing, or are they different? Are they different?
I use bug as a colloquial term. There is an official term for it, the true bugs, which is a clade. I always want to say
like beetles, right?
No, beetles are not.
Okay.
Hymenoptera. I don't want to say it because when I try to say it, I always end up saying Hymenoptera, which is the wasp clade, wasp bees and ants. But it's not that version of Hema. It's the Hemi like hemisphere. But those are true bugs. But bug as a term, and I've confirmed this with entomologists, so that it's a colloquial term that covers terrestrial arthropods, essentially. So any arthropod that is completely terrestrial could be defined as a bug, which covers crustaceans like isopods. It covers arachnids, insects, and the terrestrial myriapods. Well, there aren't any marine myriapods left, but potentially. And of course it wouldn't cover, that's why it's a colloquial term too, because there's crustaceans that are marine that wouldn't be bugs, but a case could be made for some species of crabs being bugs under that criteria too, like a coconut crab could be considered a bug with that in mind. And then it also forces you to kind of think about the life cycle of certain groups like dragonflies who spend the first part of their life in an aquatic environment. So Yeah.
That reminds me, another thing about there might be insect bug things. At least more insects, I think, than other ones, but some of them have 4 stages. Are 4 stages. Other ones are only 3 stages.
For
Life
bugs?
stages. Yeah, like
Oh.
egg, pupal, larva thing. But
Well, like a praying mantis will have 9. Is a female praying mantis for the most part will have 9 instars, whereas the male will have 7. Things like that are very specific. Can be very specific all the way down to the species level. And also what stages they're in at the time. And that's what I was, when we were talking about Protostomia and Deuterostomes, it's kind of what where I was leading with that, is that arthropods tend to go through life cycles where there's some vast changes in their physiological features. And we see developments the whole speciation events that lead into lineages like I was talking about insects deriving from myriapod-like ancestor that's similar to Symphala based on the anatomy of a silverfish. So that's a neoteny trait of one of the developmental stages of these myriapods with their many legs, the neoteny to retain the 6 legs and move forward from that and kind of develop from that. Then we have insects with stages like beetles, for instance, who all have this larval stage, and they will spend, some beetles, the longhorn beetles especially, have a really long life, but over 90% of it is spent in this larval form. So a wood borer longhorn beetle spends up to 40 years as a larva growing inside the wood, and it matures out as an adult beetle form, and it may only live 18 months in that form. So 40 years as a larva, and then 18 months as an adult.
Like, all right, cool. We're finally adults. Let's go get it on.
Yeah. And that's why the development of wings really directs that, because the most basal flying insects like dragonflies and damselflies, griffinflies, spend the majority of their life in a larval form that's in the water, that's underwater, and the adult form is essentially just a reproduction form. So they spend all their life as predators underwater, and then they mature, go out. The ability to fly is basically so that they can spread. They can move from so that they're not inbreeding in one little pond, so that they can fly somewhere else and diversify genetically.
Oh, real fast. Dragonflies and stuff are really like the quintessential, what I said before, turn the tables, because when they're young, they eat the tadpole. They probably eat the tadpoles, but when they get bigger and frogs get bigger, it's reversed.
Mm-hmm.
Well, but dragonflies are probably the most successful predators in the animal kingdom.
Really?
Yeah, they have like a 90% success rate when they target a flying insect. They're super efficient. It's because they're so
dragonflies.
Yeah, because they're so fast and their eyes are so good.
I just know the dragonfly nymphs are terrifying.
Yeah, with their freaking jaw that comes out. Arthropod jaws in general. Have you ever looked at a scorpion's jaws?
Mm-hmm. Yeah, like the chelicerae.
Yeah,
it just sort of like grinds them up.
Yeah, you get scissors. They got little scissors in there that they cut food and stuff it into their mouths. It's really an interesting development of the chelicera, because generally those functions are served more by the pedipalps, like what like you just seen a spider shoving the food into the mouth.
My scorpions.
What's that?
The amplegians, the tailless whip scorpions, their pedipalps are insane.
Oh yeah, I used to have one that was and they don't have any venom, so what they do is they crush their food to death. Tellus spondyle, regular whip scorpions. They're the same way, just in a different direction. So the amblypygids, they come from the outside, whereas the Delaspondyle, that's such a hard word to say. The whip scorpions, they crush it down like against themselves, but they're harmless to people for the most part. Other than, of course, if you have a bad reaction to the vinegaroon spray, but I've never had any negative effects from that. But when you're a cricket, I would rather be stung by a scorpion or bitten by a tarantula than eaten by a amblypygid, because they start eating you when you're alive. A mantis will do that too because they don't have any venom. That's what the raptorial arms are, a supplement for not having venom. Species with raptorial arms are what you really want to watch out for, because they're going to start to eat you before you're dead. They're not interested in killing you. They just want to restrain you and start eating you. It's pretty vicious.
Like the wasps and hornets that sting you and lay babies in you when you're still alive.
Yeah, like and Nycnomoidea wasp. They're vicious. Have you ever seen a caterpillar that was injected with that when they started to come out? It's pretty wicked looking.
Yeah, there's a lot of aren't velvet ants also like parasitic? Like, don't they inject their larvae into beetles? I think.
Yeah, they sure do.
Seems like it's a pretty common trait in Hymenoptera.
Well, the
sociality and parasitism.
The stinger for a Hymenoptera is a specialized ovipositor. So,
really? Huh.
Yeah, that's what they evolved from. Oh, thanks, Dapper. See you later.
Bye, Dapper.
He's tapping out.
So when did, speaking of eating insects, eating things, when did the bees branch off decide, hey, we're going to start being more pollen and honey thing than meat eaters?
Yeah, so that's the nifty thing about bees, ants too. The Hymenoptera is basically wasp. Everything in it is wasp, and there's some wasps that are closer related to bees than other wasp.
And ants are basically just pointless wasps.
Yeah, and bees are herbivorous wasp. Essentially, is what it comes down to. And they're so we have Hymenoptera going back to the Triassic. Bees is what as we know today, wouldn't have really shown up on the scene until the Cretaceous, though. Maybe the late Jurassic, depending on, because they keep pushing the evolution of flowers back. But that's going to coincide largely. That was actually one of the things that I had to cover on Godless Granny's channel when she asked me to help her debunk some AIG nonsense. They were talking about the evolution of butterflies taking place before the evolution of flowers somehow disproved evolution, because before that, the theory was that butterflies evolved alongside flowers, which when it comes to the reason why, it's because of their proboscis. Anyway, so they have they said, oh well, that evolved to drink nectar from flowers, but there's so many other liquids that they can Lepidoptera that they drink with their proboscis, that there's no indication that it had to be evolved specifically for flowers. They drink. There's actually a species of moth that lives on the tears of birds. It'll
tears of birds.
Yeah, it'll come up on sleeping birds and
I think it's jokes like they drink the blood. No,
yeah, your tears sustain me. Yeah.
Are there any like blood drinking moths or butterflies?
Not I'm familiar with. Nothing in Lepidoptera. There are some assassin bugs that are blood drinkers, and they will actually attack bats.
How the turds are tabled.
Speaking of the blood drinkers, where do the mosquitoes come in this family tree?
Mosquitoes, they would have split off from Diptoptera, probably in the Triassic. there's the fossil, and that's the problem with when we get into more modern groupings. To be specific, especially with the ones that are small like mosquitoes, is that the best fossil record we have of them come from amber finds. Not a lot of fossils dating back before the Mesozoic for flies in general, which is unfortunate because by the time we actually see flies show up on the scene, they're pretty diverse. Whereas those, it can be inferred that there may have been mosquitoes or something similar to a mosquito filling that niche. Oh, there is a blood drinking moth.
Really?
Yeah, Dapper just let us know Calyptra. I'll have to look that up. Awesome. I did not know about that. I wonder if
that seems like their proboscis would translate well to that, if I had to guess. That's why vampire bats are so good at their job, because their elongated tongues that evolved for drinking nectar just translated really well to drinking blood.
Yeah. I'm just glad that mosquitoes. I'm just glad mosquitoes can't. At least as far as I know, they can't transmit COVID.
Oh, I hope not. Yeah, is that moth that he shared is called a vampire moth? That's super cool. I love learning new stuff, learning about new bugs. Thanks, Dapper. Drinking the blood of vertebrates too, so it's not messing around.
Metal moth.
I guess if the butterflies came from that lineage, they're like, like this nectar stuff tastes a lot tastier than that blood does.
Yeah, so the giant centipede, the giant centipedes in the Amazon, Amazonian giant centipede, Scoliopendra gigantea, it actually eats bats. What they'll do is hang from the ceiling, wait for the bats to fly by, and it'll snag them and eat them. It's pretty amazing.
Scoliopendra is the scariest genus of any animal on Earth.
Oh my god, I love them so much.
How big are those giant centipedes? Probably not as big as the ones in the Carboniferous. I'm hoping.
No. Well, in centipedes, we don't have any records of any centipedes. Well, okay, so there was one that how do you pronounce that? Anyway, I'll get back to it. But Amazonian giant centipedes, about a foot long. They are pretty robust. I've never had a gigantea. I've had a Cespinus, and that's the Vietnamese giant centipede, and they get the one I had was about 10 inches. That's what this one is too. This one was slightly smaller. I don't know how well that conveys, but it's about that one's about 8 inches. The one I had before was about 10.
So are those insects are the ones on your wall life-sized or real life-sized? The big ones on your wall?
These ones? No, not at all. Maybe for the Carboniferous, but we haven't found anything that big yet. So, not.
I was just gonna say I like them.
Yeah. Someone got me those as a gift for having the background of my scene here.
Is it just the wasps family clade that are, like, what's the word, working together, or other ones work together too?
Social?
Yeah, social. That's the word.
Well, so termites are social, and termites actually are essentially they're specialized Blattidae cockroaches that have just really moved into that niche, and they're actually a little bit, I would say, they're as eusocial as the most social of Hymenoptera can be. So the most cooperative termites are really on par with them. So that's a completely different family. And they are nested with they're actually within cockroaches And then their closest relatives beyond that is Mantidae, which is the mantises.
Interesting. Yeah, it's weird how old I don't know. To me, that's one of the reasons I've been into like arthropod phylogeny recently, just because it's so different. Like I'm so used to vertebrate phylogeny, so it's like I learn something new every time I hear about it.
Yeah, I'm glad I learned something new today too. I didn't know about the vampire moth, so I'm going to be looking at that. There's a centipede I wanted to, because the information on it is really curious, because I can't find any actual record of it. But it was like, they said it was like the report I read said it was like 18 inches long, and I looked for any kind of peer-reviewed stuff on it, but it had a name and everything. It's going to drive me crazy now. Oh, there it is. Euphoberia. But now that says it's only 12 inches. So that's more on par with what we see today.
Right. Well, I guess you go to the chat now. The chat has any questions or not. Figure that the first question, like Speed Guy says, funny comment. All this crushing and blood drinking being live is somehow more common in the election channels.
Yeah.
Really
so
is.
yeah, there's like releases that say that it was 30 inches long, but I don't know if that's true. That seems like it's maybe some pop science misinformation. I'm gonna explore that, and I'll get back to everybody on that.
You have a question from somebody asking like how you preserve your bugs.
So this is 90% alcohol, probably. Maybe not quite that high. I filled it up to about right there with alcohol, and then topped it off with water. And like I was saying,
drinking alcohol or rubbing alcohol.
Rubbing alcohol. Isopropyl alcohol. Yeah.
Oh, like so you're not drinking, not
ethanol.
No.
It's not just Everclear in a bottle with a centipede in there.
That would probably work though, at least for a while. And then I just have epoxy around the top of it to keep the bacteria out. Not that there's going to be too much bacteria in it. With these, the ones that are dried, I use alcohol, soak them in it for a few days, and then I will paint the cuticle with clear nail polish so that it preserves it. And it does pretty well.
Cool.
That's on all the tarantula. I only do the carapace though. I gotta tell you about this while on the subject. So I had my Pamphobetus macala. Here, I'll pull this down real quick. I had my Pamphobetus macala preserved in this frame, and something happened when the kids were down here. I don't know, but it fell. And the unfortunate thing about spiders, and I covered this on my mummy wasp video. The unfortunate thing about spiders is that once they die, they kind of crumble to dust. It's because I had found a spider wasp that was had died consuming a spider, and the spider wasp itself, the carapace is super dense. Wasps have really robust armor, so it did fine. This giant wolf spider that was eating just crumbled. So when that hit the floor with my Pamphobetus macala, the biggest spider I've ever had, passed away when I moved. It shattered into 1,000 pieces. And I had I think me and you talked about Pamphobetus for when we were talking about giant tarantulas. They're really pretty when they're little. They're like they're orange with a little black Christmas tree on their abdomen. Then when they get big, they're basically purple. So I had this huge purple and pink spider in here, and you kind of see where its legs were on the spot. What's in here now is my aviculera. When it passed away, I put it in here because I didn't want to waste the frame. But you can still see where the larger spider's legs were on there.
Yeah, I gotta say, when your hand was moving before, the shadow in the background on your planetarium, whatever it's called, it made like a giant something really big coming up there of the thing.
The hand coming out of the dirt.
Yeah. Yeah. Oh, but so yeah, with the spiders, I just do the carapace like that. But with more larger and more robust invertebrates, you have to clean them out and stuff cotton inside of them. That other spider I had in there, and this one too, I just kind of slit it and took out what was inside and stuffed a couple cotton balls in there, and then glued it back shut.
See, have you ever tried breeding any of them?
I've bred mantises. Planning on breeding more mantises. I got some Asian giant mantises, and I have some ghost mantises that I'm going to be hopefully breeding. I've bred in the past Chinese mantises. I've bred scorpions, and I've bred I had an unsuccessful attempt at breeding D. diadema, which is amblypygid, like what Walker was talking about earlier.
Got any artificial selection going on in your breeding program?
Any what?
Artificial selection?
No, not well. I mean, as much as I'm artificially selecting by only having a limited testing group. Am I saying that wrong, or I say amblypygid? Is it you said amblypygid?
I have only ever seen the word written. That's how I am with a lot of those famous, like the big fancy Latin names and stuff. And I just do my best and forget the rest.
And it doesn't help when you if you go to the expos, like we were talking about going to. You go to those expos, don't think that they're going to correct you, because they didn't know what the hell I was talking about. I said, I'm looking for an amblypygid. And they're like, oh, what? And I even said,
what do they call them instead? Just
whip spiders. Whip spiders.
Whip spiders. Okay. I'm sharing it super fast. This is what we've been talking about. These dudes right here. They're amazing and terrifying at the same time. Like, look at this.
Did you see? They're non-venomous. They're perfect. This is one of the species that when I did the shows at the elementary schools, the D. diadema was one of the ones that I'd bring to let the kids hold, because you don't ever have to worry about kids getting bit by them, because they can't really do any damage at all
on this dude.
Yeah, there's a.
Really interesting. Some of them have like relatively small pedipalps, and then there's other ones that have like, orangutan arms.
Yeah.
So we let the kids. We let the kids hold the brontoscorpions.
The brontoscorpions. No, I think I'd probably have to say no to that one. But they did like holding the Cuculania hibernalis, the southern black hole spider. Really large true spiders, all velvety. They liked holding some of them liked holding the D. diadema. But what can you say? It's kind of alien and weird looking. I had a vinegar rune that kids would hold, and I had at the time a Chilean rose hair, which are super docile tarantulas from South America. Actually, they're from the desert, so they don't mess around with water at all. I've never had an invertebrate that hated water more than a Chilean rose hair.
So on a personal question, when did you start your love for this or get into this?
Well, to be blunt about it, it's when I was a kid having insect gladiator battles in my backyard, where we would put little insects in a gladiator pit together and make them fight like little hooligans. I wouldn't do that now.
Try to get out.
Most of the time they tried to escape. Sometimes one animal would have a predatory instinct and the other one wouldn't. But it wasn't just insects. We'd have toads and lizards and stuff like that in there too. Mantises never fared well, which sucks because they were always my favorite. But if they engaged all, the mantis usually didn't do too well.
A toad versus a lizard fight wouldn't be too interesting.
Yeah, because neither one of them really. Neither one of them would
leave. Yeah.
Yeah.
I guess it's one's bigger. It's unless it's one's really bigger and one's hungrier.
So when did you start keeping arthropods?
Let's see. I got my. So I had a tarantula when I was a teenager. It was. I don't even know what species it was. I want to speculate, looking back, that it was a some kind of a phonopelma species, probably a Texas brown or something like that, something local. And then when I was a teenager, I had that. And then when I let's see, it was been about, let's say 2009 maybe, that I started collecting them again, or started getting tarantulas again. I had that Chilean rose hair, and then I had a avicularia, and after that, what I get, I had my Arizona blonde. So then I got a phonopelma hensi. And then my daughter wanted me to do a Halloween party for a school and bring the spiders in. And I'm like, you know what? I'm going to go get some more stuff. I'm going to do that. And I ended up getting a vinegaroon and what else did I get? I think it was a giant millipede. I have one of these guys that I just showed you. So I ended up getting a whole bunch, and then I just kept adding to it. And because after I did that first show, everybody's like, "Oh, will you come and do our class? Will you come do our class?" All these teachers were asking me to come do bug shows for them. So I started, bouncing around and doing that. That's and here the last few years. I guess I want to say since I went to school and stuff, I didn't really have time for it, but when we got on lockdown, I was like, you know what? Maybe I could try doing that online. So here I am talking about bugs online and doing bug shows, and
that's how your channel was born.
Yep, that's how my channel. Actually, you know what my channel was born from? My channel was born from murder hornets. It absolutely drove me crazy listening to people talk about.
I guess technically they are. They just murdered bees, not us.
Yeah, right. That's what I don't like the name murder hornet at all. It's misnomer, because they're not. Murder would imply killing their own species. They're not killing their own species, and then people say, "Oh, it's murder," and like it's going to murder a human. That's what most people think, is that they're dangerous to people, or substantially more dangerous to people.
Well, they are if you like honey. I guess they are if you like honey.
Yeah. Well, that's the real danger, is it's agricultural. So they there was a lot of misinformation going out when that first came. Was it last winter or whatever, when they first started reporting them? So here, I wanted to show you guys something real quick, since you were talking about. Let me take this down.
So do you think the fear for all, you think our European or African bees here in America will like able to adapt survive long enough to adapt to be able to fight them back, or to be like
the Japanese bees do with the shivering and heating them up and cooking
them alive?
No, I don't think that would happen, but I don't think that the hornets are going to be prevalent enough to completely wipe out all the bees either. I don't anticipate that happening. People, it's gonna have an impact for sure if they don't get it under control. But they actually, I seen a post on Twitter a couple days ago. Somebody tagged me where they had caught one of the ones up in the Pacific Northwest and put a tracker on it and traced it back to its hive and kind of destroyed the hive. So hopefully they're coming up with some kind of control measure for them. But European honeybees are invasive. People want to make a big fuss about, save the bees. These are an invasive species. There are native species that aren't going to be targeted by the Asian hornets when they
Yes,
invade the area.
yeah, they're carpenter bees. That's why they call them European bees or African bees.
Yeah, yeah, because they're invasive. Most of our native bees are solitary or live in small social groups and are ground bees. So
Carpenter bees
but
are
they're not
good,
the
right?
ones that we brought over. So we only brought them over to make more stuff pollinate for us.
yeah, there are native carpenter bees. Yeah, that's a native species. Well, there are some native species. I think that there's a few invasive species of carpenter bees too. But when it comes to insects and traveling alongside humans, there's not too many niches in North America that haven't been colonized by old world invaders, unfortunately.
Mm-hmm.
You remember when the killer bees were the big thing coming up from the south?
Yeah,
The Africanized bees.
yeah, that was a big scare, and that was kind of the same situation too. Was that it was an agricultural threat that the threat was that they would take over, that they would come in and take over the beehives, and then they wouldn't let the beekeepers come and get honey because they protected their honey because it was their natural defense. So it was an agricultural issue there too. Pop my screen up there real quick. I wanted Walker to see this. Lamont.
Sorry.
Yeah, you're fine. Check out this bathroom this dude built.
Is that a bee bathroom?
No, it's he's got
scorpion bathroom.
Yeah, he's got them. They just, I guess it's free range.
I would be scared to I guess they're like arboreal, so you wouldn't worry about stepping on them.
I'd be more worried about like pinching them in the door or something. But
yeah, that's. I mean, hey, whatever works.
Yeah, when we were looking at it, I showed this to my wife. I'm like, "Can we get a place where we can do this?" And she's like, "No."
But you get your own corner with the bugs.
Yep, that's where I am. That's where I sit.
You're in the bug corner.
Yep, I'm in the bug corner. All right, guys. Well, I'm probably gonna have to wrap this up. I gotta.
One last question before you go. Have you had to use your skills to take down any YECs about bugs and stuff, or bugs even a subject for them?
They never want to talk about arthropod evolution. It's either dinosaurs or primates. No one really wants to engage about it. I did, like I said, with Godless Granny. That's if you don't subscribe to her, check that channel out. She's pretty fun. But
could you just share your screen real quick?
Oh,
yeah.
We're
just trying to get an infinity mirror, and I was.
What am I doing? There we go. Sorry about that.
I don't mean to interrupt, but yeah.
It gives you anxiety.
A little bit.
Anyway, so she had me debunk a few things that they had put out for their homeschool material. So it was pretty elementary kind of stuff, but we talked about lava crickets and what I was saying about the butterfly evolution and stuff like that there was misinformation about. But in the Facebook groups, I'll drop papers in there about invertebrate evolution and kind of ruffle some feathers because they're not prepared for it. They don't really know what I'm talking about when I like the paper I was talking about with Walker earlier about the wing development and in beetles. They aren't prepared for that because all they know is their scripts for responding to claims about human evolution and responding to claims about bird evolution or dinosaurs to birds evolution. That's all they're prepared for.
Do you have to use your skills to debunk anything?
Well, I'm lucky enough that my two areas of interest, like my main area of interest is like the Pleistocene, right? Which obviously comes up a fair amount because that's post-flood rock, according to pretty much all creationists. So, and it's also characteristic megafaunal species that everyone likes talking about. So I usually have plenty of people wanting to argue with me, including tomorrow. I have a debate with Standing for Truth, so that'll be fun.
Oh boy!
So that's your thing up in your channel, so your debate with Standing for Truth, and what about any kind of anything coming up on your channel?
On my channel, so next Saturday I am doing Monsters in the Bible with Jim Majors, where he's going to talk about the undead. So that's as they appear in the Bible. I do like a mythology show where we talk about different mythological creatures and entities from the Abrahamic mythology and kind of explore that. Had Dr. Josh Bowen on a couple weeks ago, and he's brilliant. But that's next Saturday. Later this week, what do I got going on? I'm gonna probably be on the Perspective someday. It's usually on Tuesdays, but I don't know if he moved it because the election. I know he didn't do it tonight, so maybe on there on Sunday. I'm not sure yet, but that's a call-in show that I do with Ethan, your friendly neighborhood atheist.
Cool.
A lot of fun doing that.
Well, either of you need me as a guest for, I don't like to do, but I'm always available. So I'm working.
Keep that in mind for sure. Yeah, sometimes I do those Saturday afternoon streams, and we just like I did with Walker, we look at memes or whatever, just have some fun.
Yeah, nothing of my channel really until it looks like off my butt and start being lazy and start editing some older videos.
Yeah.
Well, you guys have a catchphrase where you guys have a signing off catchphrase?
I currently do not.
I say take care and be kind.
Is it like BEE kind?
Yes, it is.
I like it.
Like as I always say, never stop learning and enjoy the randomness. We'll see you next time. Bye. All right, just do it. Turns out okay. Hopefully it'll be okay because we have audio issues right now with my mic and my headset. With everyone's audio is messed up everywhere except for Brain Bug's audio works fine.
Except RJ says I sound very faint and distant, so there's that.
Oh, it sounds better now.
Okay, good. I'm glad. Yeah. So you can hear me. It looks like we got some folks out here in the live chat already too. Good evening, Eddie. Good evening, Eric, and good evening, Mark. Glad to see you.
Well, you might have to translate for RJ since if I can't hear him, then I don't think the audience can hear him. I might be wrong, but you never know.
Yeah,
just
let
in
us
case.
know.
Yes, you can translate from RJ to human.
Yes, he said I can translate from RJ to human. So.
All right, so it's been a while since Brain Bug. So you've been on the channel. Tell us what you do.
I talk about bugs, I talk about science, and I talk about pseudoscience on my channel. We do a stream on Saturdays where we kind of have some fun. We talk about some cryptozoology, supernatural, paranormal stuff at the beginning of the show, and then we talk about some cool science discoveries, and then we finish out the show by looking at some creationist claims and things like that. So we always have a good time every Saturday morning. Just this morning, if you want to catch portions of that, if you like just the cryptozoology things, I do those on Friday nights as well, and the science and creation busting stuff I do on Monday nights as well. So yeah, I'm always busy here in the hive, always buzzing.
Nice. And I asked RJ what he and RJ, what do you do? You can hear that.
Oh, I'm still working on the second volume of The Rocks Were There. And all that, finishing up the second Phileas Fogg, Paralogs of Fog novel. I keep bigger, even if my Wi-Fi sometimes feels like it's steampunk.
So he said he's working on The Rocks Part 2, which we all know is we've all been waiting and anticipating. And he said that he is working on his is that the final novel in a series, in your series, RJ?
Oh, yeah, I think I'm
RJ?
losing my signal connections in that. You're all breaking up as far as I'm going, so I think I'll have to chat in video. Okay, I'm going to have to say toodles on here. My connection's terrible for you now.
Sorry, I suddenly have a tickle in my nose. Whew. Did you hear that? RJ said his connection was, he couldn't even hear me anymore, so he said his connection was bad and he was going to have to go. but he said he'd help us from the side chat. I should be able to. So flight is what we're talking about, and one of the earliest clades to develop flight was actually the insects, or the earliest clade, as far as we can tell from the fossil record. That's not to say that there weren't things floating around in the air in earlier periods that maybe wouldn't.
So can you still hear me?
I can still hear you. Yep, I got you.
I think it was just I think it might have been RJ's audio, maybe.
Yeah.
Oh, by the way, try out my new pop filter I have today.
Yeah.
So maybe I'll be less poppy.
I got one too. I don't usually use it because I have the sleeve on here, but so far I haven't thought I needed it too much. Maybe I do. Nice. So let me know if you think I need to start using my pop filter.
So is there a lot of I saw a video a few years ago. Is there a lot of like fossil transition things for insect wings, or they just
fossils not so much, but there is there are fossils of early flying insects. We have some Permian fossils of the clade that would go on to be roaches and mantises. We have fossils of that, and they had wings. Of course, we have Odonta is probably the most famous flying insect from the Permian period. Very dragonfly-like in appearance and in form and function, but a completely separate clade that was just fairly closely related to dragonflies and damselflies. And we do have a fairly decent fossil record of that clade. Not necessarily their development though, because the cool thing about arthropods, but also makes it difficult to fossilize their development as they go through different instars of life, where the larval stages look very different than the adult stages. So it does get daunting to try to match up larval and adult phases of different clades. And larval phases are generally pretty soft bodied, so they don't fossilize well. But so we don't really have too deep of a transition fossil record in there. What we do have is evidence in Evo-Devo of the development of wings and how they evolve in different clades, and that's especially prevalent in deposited by a global flood. Was present in Coloptera beetles. Now, I guess, did RJ have some slides or anything that he was going to share? Because we can talk about some of his stuff. Yeah. Maybe he can feed us information in the chat.
RJ, if you can hear if you can do any slides or stuff, you can send them one of our ways. Until then, I think it's something I found. I looked at something on the internet. Here's a picture of something. If that does anything.
Yeah, this is kind of the evolution of insects and where kind of wings originated and what we see both in living clades and in extinct clades. You'll see the ones on the left here. Aptergoda, you got springtails and silverfish, and they are the clades that split off before wings evolved. So all other insects all evolved from winged ancestors, even the ones who do not fly, which I think is pretty interesting. The wings themselves, they look like and there's some that appear like, oh, these had to evolve independently, but and we actually talked about this on Twitter a little bit, that wings evolved one time in insects. They just forked in a whole bunch of different directions once they did. The most basic, the most basal wing layout is like what you see in the Odonta. They have the four wings, all
like
insects.
Dragonflies.
Dragonflies, mayflies. They have four wings. All insects also evolved from four-winged ancestors. Even flies, who now only have one wing or one dominant pair of wings, and vestigial second pair of wings. But yeah, they evolved from four-winged ancestors as well. Some clades have gone on to lose their wings. Some clades of, we see they're next to the dragonfly. You have a roach. Some roaches fly and some roaches don't. Some roaches, the males only fly. Same with mantises. They're very closely related to one another. And the arrangement of the wings in this clade is very specific to the species. Like some will have wings in both the males and females, and will be able to fully capable flight. Some have poor flight abilities. Some have flight abilities that are good in the male and poor in the female. Some females don't have wings at all. It's a lot of, and we can trace these developments and this evolution through the clades and build this nice cladogram of how cockroaches and mantises, when they split off, and where based on their wing development alone.
So where are the hornets, wasps, bees, and ants on this chart?
I think that we have Hymenopterans would be, I think they might be Hymenoptera. I'm not 100% sure on that.
Okay.
Let me see. Yeah, we can look into that. I'm happy to say when I don't know something. In
Nice. So what's
class.
wing folding?
Wing folding?
Yeah.
So that's when. So if you look, when you look at Odonta, when a dragonfly lands, it doesn't fold its wings. Its wings stay flat on the parallel to the ground for the most part. And when wings began to develop where they could fold up and close, or even fold back and close, it did definitely help things along as far as diversification goes. There's another chart with some more.
It's like a zoom in better.
Yeah, with common names on there, so it's easier for us to see which how they relate to each other. And you see the Hymenopterans down there, wasp and bees. They are they're a clade of in and of themselves, and there are several wasp species also where the females don't have wings and the males do. We call them velvet ants commonly, but the males have wings and look just like a wasp, and the female looks like a giant ant, because ants are wasps. You got to keep that in mind. So ants are a wingless subterranean terrestrial wasp. The only ones that generally retain their wings in ant colonies are
the queens.
Queens, and sometimes the males can have wings as well, especially with driver ants.
And bees are just vegetarian wasps.
Yes, that's true. Bees are the just hippie wasp that have a vegetarian diet and are actually on the diet of many other species of wasps. So watch out, honeybees. But yeah,
and they lost the ability to sting more than once.
Right, honeybees. Yeah. Their ability to sting now is even very fragile. It's something that's it's kind of inconsistent in bee populations. So when we look at wing evolution, we can divide it into different phases by the geological period. So obviously, can you pull that one that RJ sent you back up again, the cladogram, or the maybe
RJ sent me? I found it on Twitter.
Oh, do you have that other cladogram, the one you had before that?
Yeah, can you it should be in your Twitter messages.
Oh, okay, yeah. Well, I just didn't want to.
Yeah, I'm trying to get a better picture, because that one I can try this one again. I'm trying to get a better picture, but I couldn't. Won't say
right, it's okay. No, it's fine. So in the Carboniferous, we have four-winged insects, very prominent, and they actually dominated the ecosystem for a little bit there towards the end of the Carboniferous, before that great rainforest collapse, which dropped the oxygen levels down and kind of put a damper on their holiday. But some of these ancient families, like I said, the Odonata and in other what they call them proto-odonata, like Meganura, the giant dragonflies and things like that, were very early on dominating. And then as the Permian kind of came into the forefront, we see some of the more familiar faces are believed to have evolved. The primitive relatives of other winged species, the Colopterans, are what we call in the fossil record Paracolopterans. They were starting to develop that wing shield and kind of diversify and come into their own. Now, who would have guessed that a couple hundred million years down the road that they would start to that some of their descendants would completely lose flight altogether, because there's several clades of beetles that just don't have flight, but they all their shield and everything on their back is all evolved from flying relatives. We saw Mycotera, Radiotera, Neurotera, all these different clades that are, they're pretty dominant today. They find their roots back in here, but it was really in the Triassic that we started to see things started to look familiar. That's when we see early relatives of the Hymenopterans. When we really see Colopterans, where they have fully developed wings and are fully developed Colopterans. That's some of the earliest evidence we have of those. We see true bugs, what are actually considered bugs, appear in the fossil record at this time. That's like cicadas and things like that. We start to see them appear. And then we get into the Jurassic, and the diversification just continues on. What the next big event, though, that really changed things was towards the end of the Jurassics, where in beginning to middle Cretaceous, when we start to see angiosperms dominate the flora, and insect diversification, especially flying insect diversification, kicked it up a notch, just because that whole new feeding environment, the whole new ecosystem that was generated by these changes allowed for us to see a lot of what you would consider pollinators, bees, butterflies, really start to diversify and come into their own.
Yeah. This one is this one. The last slide picture I found.
Yeah, so the top here, we can see. Also, you can look at this and see how the development of Circe has changed. That's the projections from the rear of the animals. You see it. There's very present things like silverfish, which is the Zygentona here we see here, and springtails and things in that clade. Then you get into mayflies and like lacewings and things like that. You get the 4 wings down to 2 wings, and then we have some specialized wings that come into play, like what you see with butterflies, what you see with wasps, what you see with beetles. Watching a beetle fly is kind of, especially large beetles, is kind of adorable to watch, but you can actually hear how fast they beat their wings, because most all insects have very, very rapid wing beats. People get so impressed and enjoy the hummingbirds, but most all insects, besides some butterflies and things like that, do rapid beats of their wings. So it's it's not beating your wings so many times a second is not not the domain of the hummingbird alone. But dragonflies have basically stuck around in their current form since all the way back to the Cambrian, or not the Cambrian, but to the Carboniferous. That's interesting.
Yeah. Now, the Carboniferous, the insects got a little bit. How big were those big insects back in the Carboniferous?
So during the Carboniferous, we had giant dragonflies, giant odontids, like Meganuria. Meganuria. Let me see what the biggest wing length on that sucker was, because they got huge. They were about the size of a red-tailed hawk, is what most people compare them to. But yeah, they were. What we have 65 centimeters. That's about 2 feet. So That's a huge dragonfly. Obviously, they didn't weigh too much, but they
So,
were.
so no dragonflies house sizes.
What's that?
So no dragonflies that are the size of a house.
No dragonflies the size of a house. Not outside of Godzilla movies, anyway. There is what was his name? I can't remember now. It's Mega something.
Mothra?
No, there's I think it's the Millennium series. There's a dragonfly kaiju.
Oh God, this is why we need Dapper on here.
Dapper would know the name. Dapper would, yeah.
But
anyway,
so
yeah.
Now I forget you discussed my memory is going these days, but both the three vertebrate flyers used their arms and fingers to get their wings out, but the insects went a different direction. And
yeah, and there's a few different ideas about that. The most intriguing to me is that they evolved from gill plates. I had this pulled up earlier, but I'm trying to see who the paper was by because I want to reference it. I linked it to RJ the other day in Twitter, but so it might be out there too. Let me see here. Yeah, there we go. This is a Nature document, evolution of an origin of insects' wings from ancestral gills. So they actually think that looking at some of the development and different species and looking at, again, like I said earlier, Evo-Devo of evolution, that's what we think that looks the most promising as far as the fossil record and the ecology and the way that insects develop and mature. That's really what we are looking at. Evolutionary origins of insects, wings from ancestral gills. It's a good paper. I think that I had a copy of that wasn't behind a paywall, but I'm hitting paywalls every source I look at here.
Once we can hack the paywalls and find all these.
Yeah.
Yes, I am a scientist. I want this information for free, please.
Well, there was an apologist. I'm not gonna dox them and say who they were because they were trying to give me this. They call it a golden key to all these different magazines, and I'm like, I'm not using that. I get caught using that because you see the prices on those things to get charged for that. Some of those magazines are like $99 a month and stuff like that. Nature and Science. Yeah, you can find free articles on there as well. So it's a kind of touch and go digging for it. But you guys know what I'm talking about out there. If RJ's still in the live chat, he knows what I'm talking about. Trying to find good source materials. A lot of times you can reach out to these folks that write these papers, and they will provide you a copy for free. But unfortunately, I just didn't have time to do that for this. I would like to get a copy of this paper though, so maybe I should make that happen. All right, so yeah, the other flying organisms that have evolved throughout history are all the rest of them, and there's 3 more clades that evolved flight independently from here moving forward. All of them are vertebrates. All of them are tetrapods. The first one,
2 of them are archosaurs, and one of them is a synapsid.
Right. Yeah, one synapsid.
Oh,
so far we have some synapsids that are working on it.
Oh, here, this might be the thing you're looking for.
Yes, there you go, RJ. Thank you for citing them. That's the one that we were talking about a little bit on Twitter. But archosaurs developed flight. What was that in the
Jurassic?
The Jurassic, yeah.
Well, I think the pterosaurs might have been the Jurassic.
Yeah, maybe towards the end of the Jurassic. Let me see. I wish this is why we needed to have RJ. Because
hopefully he can send some pictures and stuff.
Pterosaurs. I'm gonna go very basic here. Yeah, we appeared mid Jurassic, and were started off all 2 feet like the dimorphodons. You ever see in we see those in the new Jurassic Park movies too. The ones with the giant heads full of sharp teeth and little tiny bodies, the dimorphodons. We have them in all sizes, from very very small almost the size of modern songbirds, all the way up through some that were pretty large and robust. Maybe seagull sized, but yeah, they have the differences that we see from the other clade of archosaurs that develop flight is that these guys retained some fingers, and they hopped around on all fours when they had landed, moving more in a method that's akin to bats, but not necessarily identical to bats, because they have their own unique anatomy as well. And this development is much different from what we see was what happened with the with aves, with modern birds. So yeah.
Before the stream, when I could actually hear RJ, he talked about how the fossil record for early pterosaurs, are a little spotty because they probably didn't have good quality fossil breeding grounds.
Yeah, I think there's a couple of different species that are different clades that are being considered as possible candidates for the last common ancestor with the rest of the archosaurs for pterosaurs. I'm not. Again, I wish I had been able to speak to RJ a little bit before this, so I could pick his brain before he had to crash out, because he'd been providing information for us on the evolution of pterosaurs.
Yeah. We talked about that also. New Patreon goal: get RJ better internet connections.
Right. Let's. Well, I think it's all has to do with his environment too, and where he's located at. But pterosaurs. The ancestors of pterosaurs are believed to have been quadrupedal as well, which also differentiates them from the dinosaurs that would develop flight later from bipedal ancestors. So
yeah, they split off the dinosaurs early on.
Yeah, the pterosaurs did. Yeah, before
after they split off from the crocodiles.
Mm-hmm. I think they went. The crocodiles split off first, and then pterosaurs split off. Yeah, I think that's how it happened in the fossil record, as far as we can tell. The genomics sort of confirm that too. So. Yeah, pterosaurs started off pretty small, like RJ's saying here, about the size of a crow. Dimorphodon, again, another example of what early pterosaurs looked like. They were toothy and had more lizard-like heads, because they came from a basal ancestor. Whether that was so there's been a few proposed species. Tinystrophids and more Archosauriformian ancestors like Eupatoricaria, and so the ancestors of pterosaurs are kind of up in the air which lineage they came from. They didn't have feathers; they had pycnofibers, though, which are pretty analogous with early feathers, with more basal feathers that we see in the fossil record from Dinosauria.
Yeah, but they seem to master the air way before birds came on the ground on the sheen.
Right. With and it was a novel. Flying with your forelimbs was a novel thing at that time. There's been some speculation on whether they started off as, and there's the speculation on the early Dinosauria too, on whether they developed their wings as a gliding mechanism for an arboreal lifestyle, or that they developed them as a running over distance. Now, I think we're definitely leaning more towards the arboreal lifestyle for early ancestors of pterosaurs because of their tendency. There was even early speculation that they didn't fly at all, but glided on air currents, or soared, which they did, potentially do. We think that there's pretty good evidence that they did soar. Soaring is a completely different method of locomotion than than true flight. So that's another thing to consider here when we talk about the evolution of flight in these different clades, is which ones developed the ability to soar, because soaring has taken it to a whole new level. And I think that we leave both the insects, and when we get to the synapsids, we leave those behind as well, because birds and pterosaurs have both evolved the locomotion for soaring. I don't like this pterodactyl wing here because it's very pointed at the tip. And we do believe that pterosaurs had more rounded wings on the more rounded ends with the membrane. But this gives us a good idea where the bones and which bones evolved into wings in these different clades. Though you see some fusion in the bird, the second digit on the bird there. We see the fusion in this is the second and third digit. Correct me if I'm wrong. RJ, if you're out there, but between the second and third digit on the bird, whereas the pterosaurs, it's just the single digit that forms the wing, and of course bats use 4 digits for the wings and have 1 claw. Now, some birds have retained that first digit, at least in the early stages. That is very dinosaurian of them, and you can also see that in fossil birds and in the modern emu as well, which is very interesting.
Yeah, before we came on, we were talking about how when birds came on the scene, that like it says in the chat, smaller birds and smaller pterosaurs disappeared, but like the pterosaurs, I think we're talking about how the pterosaurs had the more niche of the upper sky. Maybe the birds, dinosaurs were lower to the ground.
Yeah, even that soaring niche, at least as far as we can tell, was really starting to shift towards the Maniraptorans there towards the end of the Cretaceous. I know we had some fairly large toothy soaring birds that lived around that time. Some of the largest birds that have ever lived, depending on how you'd want to define that, lived at that time. But they wouldn't have been aves. They would have been, but they would have been birds. It's kind of a weird time and place. And talk about transition, all those late Cretaceous birds with all their weirdness and basal features. Unlike birds, they're unlike birds and bats with living forms, pterosaur metabolism and such has to be inferred after the fact. Right. Yeah. And whether their ability to soar is a lot of it is inference based on the structure of their wings and the blood vessels in their wings. So a lot of research goes into that before they say that that pterosaurs could soar. But I'm glad that they could, because that means that's a form of locomotion that can evolve convergently, kind of like brachiation. Brachiation is one of my favorite modes of locomotion. But no, none of these clades ever act. Well, I don't know. I guess you could consider what bats do brachiation when they're roosting.
Yeah. Well, I think so, but like insects, I guess they what it's only happened one time. Like pterosaurs, birds, and bats.
Yeah, they kind of just. But there you do see some convergence here, of course. There's a right way and a wrong way to build a wing, and
yeah,
and only certain.
So
you have to have,
it's like, what would you say if someone asked you, it's because of a common designer, all these wings?
I would. I have questions about that. If because only one of these wings, can be the most efficient, right? So why are there so many different ways, different layouts of the bones, different structures of the membrane, feathers, pycnofibers, fur? Why all this variety if it's just the same designer? It's convergent evolutions is evidence that that in a specific ecological niche, certain features are dominant, like the long nose on an insectivore, that make it easier for them to live and function within that ecosystem. And as environmental pressures, ecological changes sculpt the genetics of these organisms, we're going to see a tendency towards the same layout of features in order to best survive in those niches. That's what I would say. Another factor. Yeah. Flyers exploit those relentlessly, expanding and speciating. Yeah, and on the islands they can some lose their flight abilities as they become they're not exposed to any pressures, don't have to fly around as much, and are able to stock resources. And there are pterosaurs, I can't remember which species it was, that are perhaps considered that they were had lost their ability to fly. I think it's a species of Azarchoid, but I'm not sure which species it was that they speculate may have lost its ability to fly and was a ground hunter. Yeah, flight is a rare thing to evolve, but once it does, the flyers proliferate. Yeah, flight is and you see that especially with the insects, like we talked about earlier. Once the wing had developed, they just kind of dominated the airways.
Oh yeah, RJ shared a more cladogram picture for us.
Oh, cool. With our different clades of flying organisms and where they fall on in the animal kingdom. Yeah, we got our pterosaurs over there with the archosaurs. We have our birds with the archosaurs as well. So when you see that first fork at the very bottom, what you're seeing there is a split between synapsids and diapsids. Okay, so on the left is our synapsids. That's where we find our bats, and they are. And then the next fork we see here.
Yeah, I think these two are it starts with an L. Lasort.
Laurasian.
Yes.
Yeah.
That's the word.
Laurasiotheres. Yeah. But I think that the split that we have here. The next split in the synapses is between looks like monotremes and metatherians. Not metatherians. Is it metatherians?
Eutheria or Theria.
Eutheria.
Yeah, the giving birth and the egg layers.
Yeah, so we have the marsupials on one side and the platypuses and echidnas on the marsupials and placentals on one side and platypuses and echidnas and those egg layers on the other. And then we don't have a split between marsupials here. It's probably just from lack of space. They didn't want to get too detailed since this is
Cladograms is a big thing.
There is no, but to be clear, there are no flying monotremes. So that's no flying egg layers, egg-laying mammals. There are no flying marsupials, though the sugar glider is working on it. They've been doing their research and practicing. And you see them jumping from tree to tree, and they're adorable as they try to take to the skies. But as of yet, no true flying marsupials. But the placental mammals, the bats did get it sorted out. They did figure out how to take to the sky, and they've been pretty successful at it. They're very niche. They predominantly are nocturnal. Of course, that's most bats are microbats or small bats. Mycochiroptera, whereas the Megachiroptera, the flying foxes, the fruit bats, they are they're more diurnal or even daytime active, but they're again very niche. They almost fill a primate-like role in Oceania and in the Indian and Pacific Ocean area as frugivores, fruit feeders that fill that niche of helping to. They also help pollinate, but helping to spread the seeds of the fruit across the treetops as they fly around and defecate from tree to tree. So, but for a while there, it was thought that megabats and microbats were
Different.
that they evolved flight separately. But
Yeah, and me a few years ago, me, Jackson, and Tony, we were talking about this. How they used to think that the megabats were more closely related to our side of the tree, the primate side. Than they were.
Because the colugos are very you could almost make a cladogram and show a lemur and then a colugo and then a megabat in an order and claim that it's an evolutionary lineage, but it's actually not. And the genetic research shows that both the microbats and the megabats are descendant from a common flying ancestor. Whether and it's largely believed that it was an insectivorous ancestor as well, but that's the cladogram on the synapsid side. Now we move over to the diapsid side. You have this first split with the turtles kind of branching off and doing their own thing, and then we move into
and somewhere on here also, we're not sure where it is the split. That's not showing obviously, but it's a split. It's a split of the lizard snake split somewhere.
Yeah, lepidosaurs, like the marsupials, are absent from this list. No lepidosaurs have developed flight, but there are two clades that are currently working on it. The flying lizards, Draco lizards, and the flying snakes. So there are two clades that are working on flight. They're not really that far along, which is kind of the development that the lizard has is the gliding mechanism that it has is freaking fascinating, because it's not unlike all of our other flying organisms and gliding organisms for that matter. It did not develop its little wings from its limbs, but from its ribs. So it has wings that spread out from its ribs that it glides with. The flying snake is believes it's like ventrally compressed, so it flattens its body and is able to fly pretty far. But other than that, no lepidosaurs have managed to take to the skies. But that split is not on here. It should be somewhere after the turtles split off, but before we get this whole, because this on the looking at the fork for the diapsids, what we see on the other side is we get the turtle splitting off one way. The other side we have all archosaurs. So everything else is on here is an archosaur. Archosaurs are very distinct.
I am glad crocodile side never learned flight.
Yeah,
that would been
crocodiles
cool.
would be terrifying. But yeah, you could you can almost look at some of the early pterosaurs as looking like little flying crocodiles, though, because they were very, very toothy. I can't express how the scale of the compared to their heads, how big these early pterosaurs' teeth were. It's almost comical how big their teeth were. But
now, real fast, I guess bring this up because I think Dapper would obviously, but this thing here, it's just dinosaurs. This whole thing right here is this whole thing. Both these things are dinosaurs. This whole line here, not just this little section.
Right. Yeah. There shouldn't be any divider between the hawks and the sauropods, and I think that's an arcus, or supposed to be a what is that, like a baryonyx? So it'd be a theropod. So yeah, but the birds shouldn't be. There shouldn't be a dividing line drawn there. It's kind of weird. Weird flex, but yeah, maybe that's done to help people understand that the birds are a unique and distinct clade. That's why when we talk about dinosaurs, we'll say non-avian dinosaurs, because if you just say dinosaurs, you know what it includes? Our little fluttery buddies, our little feathered friends.
I was talking about birds. Also talk now. Do you think, is there evidence that you think birds like got their wings pre-flight and they used it for other things, like maybe like sexual selection, stuff like that, maybe?
Yeah, and I think it was. I want to think that it's evidence that even the earliest theropods were probably warm-blooded or mesothermic, maybe, because the the feathers indicate that, especially on early species, that they were trying to keep their eggs warm, and that's something we see in other archosaurs too. We see that in crocodilians, for instance, that they actually depend on the decomposition process of the organic material they build their nest out, that decomposing to provide enough heat for their babies. It's really a cool process. But we think that dinosaurs, even early on, were trying to keep their eggs warm, and we're incubating those, and it does indicate that there may have been some warm-bloodedness there. And mating displays on that would definitely, you can think about if having good warm feathers is beneficial to the propagation of offspring, that the females would be looking for a male that had genetics showing that he had good feathers. So you'd start to see feather displays showing off how healthy they are, what a good partner they could be. So, and we see that in birds today. They show off and do their dances and everything for the females. And you could see how that could develop into more elaborate feather patterns, coloration. I think that may have contributed to the development of. I mean, it's just, of course, there's a pet theory that may have contributed to the development of new feathers, which, as we move along, started to tend towards flight. I think that they used them. I'm more of a fan of the idea that they were using them for balance while they were pursuing prey, throwing their wings out to the side. And that's how flight developed in birds, more so than necessarily from the gliding from treetop to treetop like we think about with pterosaurs. But I'm welcome to be proven wrong. I like being proven wrong because that means I get to learn new research.
Yeah, this is RJ says that the genetics of feathers and hair turn out to be very similar. Cover that in Rocks Volume 1. If you haven't bought that yet, you should buy it.
Rocks Volume 1. Mm-hmm.
But also, I can find a picture of it somewhere. But like, there's like going dinosaurs and birds. There's different hair, like feather hair transitions. Like from like little things. I forget how it goes.
Hymenoptera, yeah. Is what it starts with, and we see that, and that's where we have a convergence between pterosaurs and dinosaurs. We don't know if that's a homology or an analogy that they both developed a pycnofiber, but
we see that now kind of in baby birds, how the transition might go through the dinosaur lineage.
Mm-hmm.
Like, because baby birds are more downy and stuff, and later on they get more feathery, less downy.
Right.
But
nothing novel was involved in flight, stroke for grasping arm theropod to bird flapping. Right, yeah, they already had the muscles to do it, right? They already had the muscles to move their arms in and out. They could go, back and forth. That's why when you see dinosaurs and recreations all the way up into, even in modern times with, like, again, Jurassic Park, I bring that up again, the dinosaurs' arms are pronated like this. And that makes sense why people don't think that dinosaurs could evolve from, or birds could evolve from dinosaurs, because they make their arms like this. When you look at their arms like this and watch them move, when we do the actual reconstructions based on the anatomy of the bones, it's very clear how they developed flight.
Oh, do you see the new trailer for the new Jurassic Park?
Yes, I did.
It has feathers in it now, finally.
Yeah, it looked pretty. I thought it looked pretty good. There's some of my paleo pals on Twitter and stuff that did not think it looked good, that thought it looked like everything wrong with reconstructions. But I'm just glad they got a feathered Maniraptoran. I'm not sure what the species even is. I'm assuming it's supposed to be an authentic velociraptor, but if it is an authentic velociraptor, it should be much, much smaller. Maybe it's an authentic Deinonychus or what do they say? Deinonychus. I always say Deinonychus. But Deinonychus, or maybe a Utah raptor or something like that. I'm not sure what it's supposed to be. Have you looked into any other information on that?
No, I saw the trailer like 5 minutes ago.
Okay, I saw it a couple nights ago, but I didn't do any research on it. Richard Plum brushed a lot of work on proto-feather evolution.
Yeah, I'm sure our friend, I don't think he's still in the chat, but I'm sure our friend God, damn, my last his name. My
We
brain
had
going.
Gregory, Mark,
No,
Eddie,
oh,
Eric.
Eric is a big Jurassic Park buff. He knows all this stuff.
Oh, cool. I'm a Jurassic Park buff myself. Not like, I mean, there's other things I like as well, but I do love Jurassic Park. It's right up there with Marvel and
Oh yeah,
Godzilla
yeah.
for me.
I know it's off topic, but I first saw Jurassic Park when I was 13 in '93.
You were 13 in 93. I was 10. But I saw Jurassic Park in the theater as
Well,
well.
you're not that much. Wow, I thought you're not that much younger than me then.
No, I'm not. I'm
But yeah,
I'm approaching fastly approaching 40. Faster than I
Yeah.
want to approach it.
yeah. I had a crush on the granddaughter character.
Yeah, she was in another movie from that time period. A couple of years later, she was in Angus. I liked that movie too. She really didn't seem to do much after that, though.
But yeah. So that's off topic. Now, bird wings. I guess later on, some species, I don't know, it was either all at one clade or different clades. They lost their flying wing ability, but they still kept their wings, kind of.
So, the current standing on that is the generally accepted reason for that is not that it was one clade that lost its ability to fly, and then it was one clade that was prone to lose its ability to fly, which we see the ratites. They tend to, when they get in an environment where there's not the pressure to need to be able to fly, that they stabilize and develop large bodies. But this is in no way unique to ratites, because we see it in other clades as well. There's swamp hens, and the dodo was basically an oversized pigeon that underwent the same development. We see it in waterfowl, like ducks and geese. They will in Hawaii. There was an indigenous flightless clade of duck, or I think it was geese. It might have been a duck that got just as huge as a goose. They were huge and they couldn't fly. There were other islands. I think there was an island in the Mediterranean that had a swan that could not, that they don't believe could have flied because of how heavy it was, but it was in the early stages. Australia being one of the Australia in South America, for that matter,
With the Kiwis.
Well, Kiwis are New Zealand, which is some set of islands that are southeast of Australia. But yeah,
Australia.
they had two clades of ratites that were flightless: the Kiwis and the moa. And the Kiwi is actually more closely related genetically to the elephant bird of Madagascar, which was the largest flightless of these flightless birds, than it does in common with the moa, which shared its habitat. Australia has the emus, but they also had what they called the demon duck clade of birds that evolved. Was in the Miocene. Look that up for me, would you, RJ? The Miocene, I think it was. In Australia, it may have been the Pleistocene, though. I don't think it was that late, but it might have been. But so there's this trend towards when a clade of birds finds a habitat with an open ecological niche for something as a large grazer or even a large predator. In the case of some of the like South American birds that evolved when it was an island.
Yeah, it's been in South America, but the terror birds kind of took the dinosaur. They were the dinosaurs.
South America, RJ.
Were for a long time the dinosaurs were still the top predator in South America until the isthmus connected to North America.
The isthmus of Panama connected to South America, and the forest rockids that were the dominant predator in the area. Along with, there were some marsupial mammals that were pretty good too, that were doing all right in South America. We'll talk about that some other time though. But yeah, the flightless forest rockids have a modern ancestor, or some modern descendant in the Siriema. And if you ever see a Siriema or get a chance to look at one, they are quite wicked dinosaurian looking birds. But yeah, what RJ is right about this. When that isthmus connected North and South America, we did see an influx of predators that had evolved in Eurasia and kind of the top
Yeah.
tier.
That they came all the way from the Bering Land Bridge Strait to the Panama Land Bridge.
Yeah, well, they had been established in North America for a while before making their way south. But some South American clades did move north, including some forest rocket clades, and they were semi-successful moving into North America because when you think about North America, it was more like would have had more in common with the current African fauna than it would with what we actually see currently in North America. There would have been more variety of more large predators, more large prey species, and there was the forest rockets were able to carve out a niche in that environment. Now, early on, forest rockets were depicted with arms like dinosaurs, so it wasn't until later they started just to reconstruct them with wings, but they could in the long term, they could not compete with the large mammalian predators. We had this Smilodon populator, which was an argument could be made that it wasn't, but it was the largest feline that ever lived. Found a niche dominance in South America and kind of pushed them into the margins, and eventually they faced extinction. But so. Yeah. Competing with mammals makes flightless birds not perform so well, and we see that continuing on today.
Yeah, one thing I didn't know that dodos were like in the pigeon clade.
Yep, they're just giant pigeons basically. I say basically, I mean that loosely. I'm being hyperbolic. Don't anybody say Brainbug said dodos are pigeons. No, they're in the same clade with pigeons. But yeah, there were a few island species that evolved from different.
Well, at least that's sorry for fast. At least that's better than your quote earlier today that you agree with.
CMI.
CMI for Orptic topic.
Creation Ministries International. Yeah. Well, I had to agree with them. They're right about the shroud, aren't they? We'll talk about that maybe afterwards because we're getting off topic here. It's easy.
That's what we do here. But yeah, I'll also. And one particular species of birds, they're using their wings for swimming.
Yeah, penguins. Auks did that too, and that's independently. Auks still do that. There are several diving birds that use their wings for swimming. When they hit the water, they swim through the water just like they're doing through the air. So wings are versatile. Wings are amazing. Developments, and like RJ said, once you develop wings, they go all over the place. You have everything like look at each one of these clades, except for maybe the pterosaur, which is the flight and everything's very homogeneous with them. But with birds, there's everything from the rapid beats of the hummingbird to the soaring of the wandering albatross that never touches the ground. So once the wings evolve, they could just split off in so many different directions. And bats too. Bats between the megabats and the microbats. We have a tiny little bumblebee bat that is smaller than my thumb, and we have huge fruit bats that navigate through the forest, flying underneath the canopy, and then insects. Don't even get me started.
Yeah, the same way of insects. Once they like you said, only one clade happened. Once they happen. Got the wings of from the wings of the dragonflies to the colorful wings of butterflies.
Right, they just diversify, and it's especially we see this diversification happen a lot after major extinction events when ecological niches open up. But the ecology of the ancestors matters too. So why was pterosaurs so homogeneous in their wing development after they evolved? They didn't have a big window. Most of we had theropods moving into that niche right on top of them, following right in their footsteps, developing flight, and the pterosaurs evolved from gliders. So their evolutionary history shows that was, but we do still have, don't get me wrong, we still have some diversity here. We have everything from tiny crow-sized pterosaurs to huge giraffe-sized pterosaurs. The biggest animals that ever flew were pterosaurs.
Yeah, I know. Also, not that's here, but I did not know that uh, pterodactyls were a branch of little clay inside pterosaurs. You always think they're the same thing, but they're not. Pterodactyls are like a little small group inside of it.
Yeah, it's a nested clade within pterosaur. Yeah, and that's I think that's a lot to do with the generation that you and I grew up in. That was in the 80s when, yeah, I didn't even know there was anything else besides a pterodactyl when I was a kid in the 80s, because everything was a pterodactyl. I almost want to blame the Flintstones for that, because all the flying pterosaurs on there were called pterodactyls. But you grew up with the Flintstones too, right?
Well, yeah, well, because I think RJ might have grown up more than we did. The time we were there, they were already in the rerun phase.
Oh yeah, it was definitely reruns. It was yeah, whatever played on Nickelodeon after school.
Yeah, maybe some movies and stuff, but yeah, I think I definitely watched them as a kid.
Yeah. So, and just everything called a pterodactyl. And the depiction of pterodactyls, even in modern times, even in movies that are coming out this year, even in movies that are scheduled out this summer, even in movies that we were just talking about the trailer for, we still have pterosaurs that are grabbing things with their hind feet. I could go on a tangent about that, but their feet were not evolved to grab things. They had huge giant heads for a reason. It's because their limbs were occupied. There was no feeding function that we are aware of in their hind feet. They were not swooping down and grabbing things with their legs. They were feeding with their heads. They were hunting with their beaks. They were, and I say that because in the new Jurassic Park trailer, there is a Quetzalcoatlus attacks their plane in the trailer, so I'm not giving any spoilers. And it's tearing the plane apart with its claws and with its hind feet, which is totally unrealistic. But it is Jurassic World after all. It's the Jurassic Park franchise, and we do expect them to see.
Yeah, talking about that like what they. I don't like off topic again, but I realized it so later. Like thinking, why do they use frog DNA? Why don't they use bird DNA? Like, even in the 90s, so like we'll use frog DNA to fill in the gaps,
or even crocodile DNA, just to explain the reptilianness of them.
No, we use frog DNA.
Yeah, no frogs. It's because I think it's because the frogs change their gender, or not their gender, their sex.
Yeah,
and they talk about that. But there's lizards that change their sex too.
Yeah, but I know, but still, even us mammals were closer genetically to the dinosaurs than the frogs were.
Yeah. Yeah, amphibians, this cladogram that we have pulled up here right now, they don't even make the cut to be on this list. They're the outgroup of vertebrate. There would be another fork here before this split between synapses and diapses. Another fork way back that would have amphibians and then other terrestrial tetrapods. So there's another fork back there. We are distantly related to frogs, and so are dinosaurs, and we cannot splice in frog DNA in their genes or ours. But I know that they're going for the wow factor by having the pterosaurs pick people up and carry them around and pick them apart, and it's just not realistic. It's not something that's actually gonna that actually happened in history.
But also we were talking about this earlier with how the birds had to go to fight with the world already dominated by the pterosaurs. Same thing happened for the bats when they started flying. By this point, the birds had dominated the air, and now here comes the bats late on the game when it goes to the air too.
Oh yeah. Bats are fairly they're the new kids on the block when it comes to flying around in the sky, and again their habitat right now is very niche. Bats are good flyers though. There's things there's aspects of flight that bats are actually better at than birds are, which is, a lot of people will be surprised at, because birds are the cream of the crop when it comes to flight. And in some aspects that's true. Again, I go back to the soaring and the insulation of the feathers, the superiority of archosaurs in general. We could really talk about their hollow bones and their respiratory system and the air pockets in their bones. We could go into all of that, but there are aspects which placental mammals are very good at when it comes to this small scale, like we see with microbats. They are filling. The reason they were able to fill that niche is because birds were not. There was a whole environment on the ceilings of caves that birds just were not able to occupy, and to the extent that bats are, and this nocturnal.
And plus there's the live birth aspect too that bats have the other ones didn't have.
Mm-hmm. Yeah, they don't have to build a nest. They live in big colonies for the most part. But one of the most fascinating and important aspects of bat flight is how they feed. They're not just flying around grabbing stuff with their mouths. They actually balloon their wings back, curl their tail in, and basically make a wind pocket to drive masses of insects into their mouth. They actually turn their body into a funnel while in mid-flight and suck insects in.
Oh yeah, I saw this video or an article years ago about brown bats, or maybe it was black bats, I forget, but let me like them, that they can eat like 600 mosquitoes in an hour. I'm like, I need those in my community. Eating all those mosquitoes that sting me all the time, that bite me.
Yeah, it's impressive. Bats are impressive. I will beat that drum because people are like, oh, bats are a kind of a failure because they haven't dominated the niche that birds were already occupied in the flight ecology, but they have developed their own unique niche. They are very successful in it, and they're very good at it. And there are, again, things that they do better than any bird does as far as flying and feeding.
Yeah. Now, I originally took this topic out because a few months ago I was watching Jackson and Dapper were discussing with the creationist Bread of Life.
I know Bread of Life. Rebecca, yeah.
Yeah. And one of the things he talked about is why don't horses and stuff like Pegasus come and sphinxes? So why isn't there a sphinx / Pegasus clade of flying tetrapods?
Yeah, it's because of monophyly mostly. So you would not expect to see feathers develop in any clade of synapsid. It's just evolution. That would disprove evolution. If there was a synapsid that had feathers, it would show that that this was that it was not something that was inherited and passed down. It was something that was able to evolve anytime, any place. That's just the same thing as like talking about like a cat giving birth to a dog or something like that. If we saw that, it wouldn't prove or if we could demonstrate that, it wouldn't prove evolution. It would disprove it because it's descent with inherent modifications. And
plus RJ could talk this. Maybe it's talk discussing comments or take pictures of, but yeah, they would have to get some extra 6 limbs on their back that have wings and stuff.
Yeah, the closest thing that you could expect evolutionary, and I don't expect that it would happen, but would be something along the lines like what the Draco lizard evolved with its ribs evolving into flight membranes, because that's how that lizard is. It has specialized ribs that have evolved to spread out and be like a gliding wing apparatus. Maybe something like that could evolve in a mammalian clade. But you wouldn't see a hexapodal. You wouldn't see a hexapodal mammal either. That's so yeah. They would just develop new limbs.
That would be a very big mutation for that to happen.
Yeah, I mean you probably pull something like that off by messing with its Hox genes, like they do with Drosophila, the fruit flies, so they can like limbs grow out of their backs and stuff like that. But Hox genes also do regulate wings in insects too. So there's a Hox gene there for that too. That is how we are able to develop flightless fruit flies, which I use to feed my baby mantises when I have babies. I don't have any babies right now. I need to get some. Not till the spring, though.
So, by the way, also on topic, have you ever like you capture you insects in your do you ever have any mosquitoes in your collection?
I have caught mosquitoes and fed them to my mantises. Sometimes when I sit on my patio and the mosquitoes are laying all over me, I'll let my mantises crawl over me and grab them.
like I like mosquitoes. They're great food for my other insects.
Yep, it's like you come land on me at your own risk because I am covered with mantises when I'm outside barbecuing in the summer. I don't really keep too many out. I don't ever have more than 2 out at a time because they do tend to be curious and start trying to go run around and explore, and you got to keep track of them. But they are excellent also when you're out barbecuing for keeping flies away. So what I'll do is when I'm barbecuing, I have my fresh cooked food there. I'll have my mantis. I'll get their deli cup and have them perched on the top of it, and they'll just snag the flies right out of the air and eat them.
So yeah. Also, another thing that YC's talk about is but we evolution. Like, what's the use of a half of a wing? Like, how can they survive one wing and one arm and all this stuff? And I don't know how they say it.
Gliding is a good use for half of a wing. Keeping your nest warm is a good use for half of a wing. Balancing yourself while you're running, balancing yourself while you're climbing or while you're walking on branches. Building or keeping you warm in an environment that's Arctic if you're warm-blooded. Obviously, cold-blooded animals aren't going to do that. There's lots of good uses for half a wing. There's more animals that have half a wing than animals that have a full wing because most beetles have half a wing, and then they also have a full wing too. But we won't talk about that. Flies have a wing and like an eighth of a wing. So yeah, there are functions that they can perform.
Because like you said, it doesn't happen all at once. It happened in like stages.
Yeah, mating displays. There's another one. Mating displays is a great use of half a wing. And we were talking about that when we were talking about birds evolving feathers, that they could have evolved as they could have become into use as a social display, and that's why the wings started to get thicker and fuller and become a major use of energy in the species.
Yeah, I guess the last case, we didn't actually grow wings, but we made our own wings and planes and helicopters and stuff. Yeah,
we explode into the sky. We explode on the land too, though. But we've learned all of our machines are at least our combustion engines are. We travel through the air via explosion. We all helicopters, airplanes, all that is exploding into the sky.
And even though it's not, even though creationists say it is, the clades of helicopters, but it kind of was, that we took, it's helicopters are designed and stuff. We took a little different wings of planes until we find the one that worked, and that branched out from there.
Yeah, look at the early records of different flying machines that were invented at the beginning of the 20th century. The Wright brothers weren't the only ones working on stuff. There were some wild designs of flying machines in the world by World War One. There were planes. They were kind of crude, but zeppelins and dirigibles were the main thing on the scene. So yeah, we started flying with using gases before we started flying using explosions. Or we really took off.
Until we came onto one design with the wings that have the air flowing thing, which all planes now have. I'm pretty sure.
Yeah, and it's all it's kind of using the same physical features that soaring birds use when they're up in the atmosphere up higher, because they ride the air currents, and you can actually utilize those to maintain flight, and it makes it more energy efficient that the wings are able to do that and the planes are able to do that. Doesn't mean that they're not constantly the energy. There's a formula for it. I could get into that, but for the energy used versus since our run to the family tree didn't grow wings in our arms, so we had to do it mechanically. Yeah, I guess the closest thing that we have to actual wings will be like an elytra, something like that, which I know doesn't exist in the real world, but except for in like Falcon and the Winter Soldier. But I would love to go hang gliding sometime, or like a flying squirrel suit looks fun too.
Yeah, I don't know. Part of me wants to do that, but the part of me that's scared of heights is like nope, 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 nope.
Are you really scared of heights, or are you scared of falling?
I'm not sure, but it's funny. I can be on roller coasters. I can be on the top of like an Eiffel Tower. Where it's gated on. But if I'm on my roof, this is much shorter. I'm terrified. But on airplanes, I'm fine.
Yeah, it's circumstantial. It sounds like, but yeah, with a hang glider, I'd imagine it'd be more like being on your roof than being sitting in an airplane. So maybe that would. Are you like bungee jumping and things like that? Have you ever done any of that stuff?
No.
Okay, I was just wondering.
Part of me is curious, but I probably close my eyes the whole time.
I've never been bungee jumping either or anything like that. I would love to. I'd love to either go hang gliding at some point, parasailing, or take a ride in an ultralight would be cool. Just something to feel the wind on my face as I soar through the sky. Sounds amazing.
But like I said, like humans had to do it the mechanical way first through like hot air balloons and gases. Like first it was hydrogen. I like how they switched from hydrogen to helium because they find out hydrogen is much lighter, but it's also much more explosive.
Yeah, I was talking to my friend, Almost a Doctor, Matthew. That's his channel, Almost a Doctor, but a couple weeks back, and we were talking about the Hindenburg and that it was kind of the death knell for the Zeppelin, which Zeppelins are the ones that flew with the hydrogen gas, where helium is what we use in blimps. So that's the difference between the two. And Zeppelins, the hydrogen used in there, I think it was 98% hydrogen or something like that. I'm not sure about the formulation, but it was a death trap just waiting to happen. All it took was a spark.
I know it's science is weird. How one less proton electron can make it flammable. One more makes it not flammable.
Right? Yeah. How? Why? It's crazy. It's amazing. The elemental variables are so fascinating. I like how when you can mix two together in different combinations and turn something that's volatile into something that's edible.
I know, like salt is sodium and chloride, both poison, but
yeah, exactly.
Put together, it's like you need it to survive.
And sodium is freaking explosive by itself, and chlorine is a noxious gas. But put them together, and you put it on your freaking taco.
Same way with hydrogen, oxygen, both burnable fuels, but water.
Yeah, and then good old carbon, which bonds with everything, making all kinds of different formulations that are poisonous, that are beneficial.
But that again, that's a topic for different day. But all right, so wrapping it up, wings. Four ways of happening. Three of them were arms, and one of them
was gills.
Yeah, and that's the thing. Like, and pretty much the Pegasus Sphinx clade can never happen unless a lot of mutations happen.
Monophyly says that it probably won't happen, but
sorry, you can always read about them in mythology books.
Yeah. All right. So what's your next show going to be on?
Right now, I have nothing planned, but I'm working on some. Right now, I'm talking to some musical band guests for music episodes. Anything happening on your show coming up besides Live from the Hive and your replays of your breakdown shows?
Yeah. So the 19th on Your Friendly Neighborhood Atheist, we're doing the annual fundraiser, which is always a blast. We have some great names, some big names in the atheist and skeptic community. People like Seth Andrews and Shannon Q. lots of big names, lots of cool stuff coming up. That's on the 19th. I'm on the Perspective on the 22nd, which is also on Your Friendly Neighborhood Atheist. That's the call-in show that we do. I have a show that I'm working on with One Ring 42, and it is going to be on the 20th. So the very next day, it's Sunday, we are going to be talking about Starship Troopers on his channel, or their channel. Sorry, they're they. So we're going to be talking about Starship Troopers. We're going to talk about the book on their channel, and then at some point later on in the year, probably later on in the spring, we're going to do part 2 on my channel and talk about the movie. So it'll be a fun. And I'm going to be doing something with Pale Blue Mama. We don't have it set a date yet. And in Dark Matter 2525, we're going to be collabing on something there too. Hopefully, that turns out to be a good time. I will also go ahead.
There'll be a voiceover for one of his cartoons.
I don't know yet. I hope so. That'd be awesome. I think I'd be happy to be a voice in a Dark Matter 2525 cartoon. That'd be amazing. I have a interesting voice. Maybe he'll be interested.
Yeah, that's a voiceover work on my own channel with different video game characters. I can do a high pitched real voice, kind of not very good, but it's what I do.
Yeah, that's. I mean, my voice is kind of high pitched, but a lot of people tell me I have a soothing voice that's nice to listen to. And some people are annoyed by my voice, so I guess it depends on who you are.
I guess it depends if they're annoyed by how you sound or what you say.
Yeah, I think a lot of people are annoyed by seeing someone who is biologically male talking like this. But fucking Mr. Rogers did it for 30 years, and everybody loves him. So screw you, guy.
Yeah. I watched growing up, Mr. Rogers.
I liked Mr. Rogers. You know what I like about Mr. Rogers? Mr. Rogers was actually he was a minister, or he was a religious leader. He didn't push it on you. He didn't talk about it ever. He was just a friendly, nice individual, and it was good.
Yeah.
Wish more people could be like that. Take a page from that book and just be nice to everybody, regardless of what they believe in, and engage them. I love talking to people about science. That's why I keep coming back here, because I love your enthusiasm for these topics. So thank you again for having me on. Hopefully we can work together in the future. And if I do something on my channel, I'd love to have you on too. That
sure.
you're
and feel free to mirror this in your channel. Is the insect part you want to mirror it?
Yeah. No, we did this whole thing, me and you. I could mirror the whole thing at some point. Yeah, I'll probably do that in a couple months. I like to wait until you'll see that with the way I do my show. I'll do the closest thing is the Crypto Corner segments are 3 weeks out from the date that they actually were live on. So I
just start doing that too. Sometimes break down, because I get fixture editing. I break down these longer segments into bite-sized segments.
Yeah, because you have so you have your viewing audience, and when you premiere or when you're live, but you want to make sure that other people who might be interested in it but aren't able to watch it live can come back and watch it. Nobody wants to go back and watch through a 2-hour live stream. So if you divide it up into sections so that they get say they're interested in just this part or that part of your stream, they can just watch those. That's my thoughts behind it, though. I get it. Allow a completely different audience to be able to view your content. We can talk about that privately, though. We don't have to bore everybody in the live chat with it.
But anyways, so you have anything to say what's your closing statement for your shows?
I need to get more winged insects in my collection so we can talk about them together. I would love to raise some butterflies this spring. So let me know. I'll probably put a poll out at some point. Let me know if that's something you'd be interested in seeing in the hive. I think that we should probably get Vandalia 1998 to get some butterflies too, and we can raise them together.
Sweet. And as I always say, never stop learning. Enjoy the randomness. We'll see you next week. Hopefully. Bye. Hey, just do it. Turns out okay. But not today, because today it's not okay. Not okay at all. Today we were talking about the stuff that we watched that made us just break down.
Yeah, I've had a hard time deciding which one I wanted to go with on this one. There's so many movies that were impactful emotionally to me growing up, and still now, even today. I recently watched one of these movies that I've listed as mine, and it made me cry just the same as it did 20 years ago.
Oh yeah. Oh yeah. Before we start, your stream earlier this morning reminded me of an honorable mention.
Oh yeah?
Yeah. I mentioned this in your chat, but in this game called Steins Gate, CERN is evil.
Mm-hmm.
And they used their collider to make time travel possible, to make the whole world under their control in a utopia.
Oh, yeah. I'm not familiar with that series. Is that you said it's a game?
Yeah, it's called. It's also an anime, but the game's better.
Yeah.
But
yep, I'm not familiar with it, but it sounds pretty cool. I like
but anyways,
speculative fiction.
Yeah, in it, this one girl dies, and her best friend goes back in time to save her, but he keeps on dying, like over and over again. He goes back to save her, but every time she dies over and over again because of CERN. So that just
like a time loop.
But different way each time. Either she gets hit by a car, gets shot, or she has a heart attack. No matter what he does, she always dies in that time. While CERN is in control, she always dies.
Yeah. I tell you what, if I'd thought about including video games in this list, I might have put Ori and the Blind Forest on the list, because that first, the arc of the first story where, what's her name? It's not Gooman. He's the froggy dude. Have you ever played that game?
What's it called?
Ori and the Blind Forest.
I have not, but now I'll check it out. As long as I'm on my meds.
Yeah, it's kind of a nice pace game, but it does have some emotional drivers to it. So there's always that. I see Regios in the live chat. Hey there, Regios. Good to see you. Thanks for coming and hanging out with us. Can you believe you're on season 10 already?
Oh yeah. He said, "Oh, it's a game and an anime." So I guess he's played it.
Yeah.
So Reggio, did Mayuri's death make you cry? Especially in the game. But
all right. So movies, right? What year were you born? I think we were about the same age, aren't we?
79, December 79.
Okay, so I'm a little bit younger than you, but I was 83. But we should have grown up with a lot of the same media together, so there should probably be some overlap here.
Yeah, I was like 3 days away from 80, so I'm either the youngest Z or the oldest millennial, or I'm a zennial.
Yeah. Oh, all right. So you want to go first? What's your number 3?
Number 3.
Yeah, this was mine. This was the one I just mentioned a second ago that I watched recently, and it gave me the same emotional response. The ending to Iron Giant is a fantastic. It spends the entire film attaching you to this, what seems to be a machine, and throughout the series, the series of events that unfold through the movie, you start to identify the Iron Giant more as a being of consciousness and thought, and just as it starts to find itself as a thinking being, it finds itself in a position where it can choose to change the course of things for the people around it, and it sacrifice himself, and he actually does that. And yeah, the end credit or the final scene with the parts pulling themselves back together, kind of a cop out, but it did, as a kid, it made me feel better. But I like that leaving the ending ambiguous might have been a more interesting approach to it.
Yeah, I kind of I right now a little bit. It's been a while since I've seen it, but yeah, it's like if they give him friends. Everyone thinks he's just a killing machine. He does the opposite.
Yeah. It kind of reminds me of the. Did you ever watch the movie Monster Squad that came out in the 80s? Frankenstein and Dracula, and there's the kids that are trying to stop him from just entering the world. But Frankenstein's actually not a bad guy in that movie. But that's what this relationship reminded me of when I was growing up, because I grew up like from a very small age with like Monster Squad being one of my favorite movies, and then this movie came out and it does the relationship between the Iron Giant and the little boy reminds me of the relationship between Frankenstein and the little girl in Monster Squad. And he actually, that was actually one that kind of towed the line of getting on this list for me as well, because there's a scene where at the end, I don't spoilers for anybody who's never seen Monster Squad, but Frankenstein gets sucked into the abyss with the rest of the monsters, and has to leave the little girl. But it's very much the same type of scenario here, where you have this relationship with somebody who's, and I say somebody loosely, the Giant's obviously a machine, but somebody or something that thinks that's developed its personality based on its relationship with this small child, and became I want to say almost like I don't want to say a pet, but like a affectionate friend, but not maybe something more of taking them under their wings. But throughout the course of the movie, they develop this relationship, right? They become good friends, and the Giant learns how to be a person by interacting with this little boy. He learns how to be a good and make good decisions, be a moral person, based on his interactions with this child. And then before they can move forward from that, I mean, it's just at the very peak of the movie, there's really this full understanding that, hey, this is a person now. He turns up and looks at that rocket coming down, and he says, Superman, and spins his rockets and everything and flies up there to stop it. Yeah, so much emotion right there.
Yeah. My number 3, I kind of cheated a little bit.
Mm-hmm.
It's pretty much every ending of every Kingdom Hearts game there is.
Okay, I'll give you that. And I don't play Kingdom Hearts, so you'll have to elaborate on it, because what happens?
Well, let's see. In the first game, there's these 3 friends on the island,
Mm-hmm.
and at the end, they're all separated at the end of the game. One's in the evil dark world. Another one is by himself, wandering the outworld, whatever. And the girl is back by herself on the island where they grew up. And they just, and she goes back and sees this drawing that he made for her, the hero made for her, and she just cries, and she draws a picture. Yeah, a picture of him giving her a fruit, to eat, and she gives it back to him, draws the same thing, and this tears, and the music just implies it in the first game. And then this game, one of them Xion dies, and everyone forgets who she is. Like everyone loses memory of her after she dies. And then everything is just sad for a Disney game, for half a Disney game. This series is sad. The only one that had a halfway happy ending was Kingdom Hearts 2.
It all ends with kind of a somber note, does it? Every single one of them?
Yes. With deaths, forgetfulness, disappearances. Just
Well, that's a good choice. I guess I'll let it pass. This is a whole series of games, but I did put yeah, the reason my third place ended up in third place is because, again, the giant maybe didn't die at the end, maybe, right? That was
yeah. Well, this
So,
is what.
all right.
Yeah, I could, like I said, I couldn't decide which of these was the saddest. You know, which one made me cry the most. So, like, Kingdom Hearts in general, it's just
Yeah, Kingdom Hearts. Each arc ends on a somber note. I get you. Yeah.
By the way, do you have any sad games you ever played? I mentioned the Steins games.
Well, like I was saying, Ori and the Blind Forest. The mother she's not really his mother, but she raised Ori. She dies of starvation at the beginning of the storyline, so it is kind of sad. You see flashbacks of them being affectionate and her raising him from a infancy, and then she dies of starvation, and his journey begins there. But the whole time that you're on this journey, there's a somber overhanging that he's lost the most important person to him in his life, and now he has to continue on and face the cold, unforgiving world alone without any kind of support.
Check it out. All right, here we are at number 2. One second. Well, he's not here to talk about it, but Eric's number 2 was Land Before Time.
Yes, Land Before Time. It was traumatizing. It was the Bambi for 80s kids. It was mama dying, and there's almost there's the trifecta: Bambi, Land Before Time, and Lion King. If you want to have, cry about the loss of mother. Now, when it comes to these cartoon classics, one that kind of dodged that bullet, yeah, pun intended, was The Fox and the Hound, where we didn't actually see Copper's mother get shot. We just heard it in the distance.
Well, I think I think that was a cartoon, but I think for movies like Land Before Time, Deaths and stuff, I think between Bambi and Land Before Time, there was the Old Yeller one.
Oh, well, yeah, Old Yeller wasn't animated though, but Old Yeller was rough. Yeah, Old Yeller's not on my list, but it is a sad one. This one's not on my list too. I definitely agree that Land Before Time is sad, especially oh my gosh, the scene where he's where he thinks he's seeing his mother again, but he finds the herd. His grandparents take care of him, but still it's rough. And this,
as soon as he catches up with them, because he's left behind with all the other babies.
And Mama got her butt kicked by Sharptooth, and yeah. All right. Yeah, but I don't have much more to say about that one because it was Eric's, right?
Yeah. Yeah, like I said, it was. I remember that one too. But all right, here's your number 2.
Yes, if anybody's ever seen this, some people are like, "What are you talking about?" There is a part in this movie where he's journeying into the swamp to it's where he goes. He's going to speak to this wise old tortoise thing or whatever. But it's called in this place called the Swamp of Sadness. And when you're in the swamp, as long as you keep your will to live, you can keep your head above water. But as soon as you start losing your will to live, you start sinking into the mud and quickness and into the sadness of the swamp. And this the main character, the main character Avatar character is Atreyu. He's this magical Native American tribe that lives in this fantasy world, but he's a character Avatar. Was the main character Sebastian is reading the Never-Ending Story book and visualizing it, and it kind of unfolds as you read it, and that's the point of the story. But Atreyu is his avatar, and Atreyu has this horse called Atrax, and it's like his best friend through all this adventure that he goes on, all the quests that he's sent on, because he's trying to stop the nothing from consuming the never-ending story, consuming the world. And one of the quests he's on is he needs to go talk to this big turtle in the swamp, and his horse loses its will to live along the way, and the horse sinks into the swamp. And the most traumatic and tear-filled pleading of this little boy for his horse to regain its will to live and to come back out of the mud, and the horse just keeps sinking, and the boy's despairing, and he's in this swamp now all by himself as his horse is sucked into the muck to disappear forever, because there's no coming back for within the story itself. There was no coming back for Atrax. That was the end of his story until Sebastian actually jumped into the book and reset the timeline or whatever and brought everything back. Like he hit the reset button basically. But there were other entities that were lost too in this story. And Atrax is the saddest point, but there's also, as you can see, the rock biter. He's the one above her right shoulder, the big rock dude. He has all these little friends that he hangs out with. He's a giant. There's a guy with a racing snail, and there's a guy with a bat and a glider bat thing, and they're all this little group of silly characters that basically kind of tertiary characters to the story, explaining how the world's changing, right? And they're all on their way to kind of meet up together. They're on their way to try to suss things out and figure out what's going on. But there's a scene where Atreyu finds the rock biter, and he talks about how the nothing took his friends, took all these other characters that were kind of with him at this point in the story, and he's lamenting how his, these are like, look at these hands, right? They seem like big, strong, powerful hands that you can count on. These are powerful tools, but it pulled my friends right out of my hands, and they disappeared forever. And he's just sitting there, just in sorrow, lamenting the loss of his friends. It's unexpectedly blindsides you, because it's just a children's movie, but it's not pulling any punches on giving you some real content.
Yeah. Again, it's been a while since I've seen this movie. I think I lost all this in the 90s, but it's but unfortunately I have a good memory, so I remember some of this stuff.
Yeah, it was sad. I mean, it made me cry when I was a kid. I mean, again, this is another situation where there's kind of a tacked on ending part where they're like, oh yeah, reset everything back to normal. So it makes the whole plot of the story pointless, because there's no consequences. But
yeah, except for the only consequences there was for those 2 extra movies they made this game.
Yeah. The third movie though has a young Jack Black in it playing a school bully. It's fantastic. He's like, he chews the scenery and does the role justice. Jack Black, you can kind of vision him with a shaved head and leather jacket as a teenager, and that's
how old was he in that movie? How old was he in that movie?
He was a teenager. I would say he was somewhere between like 14 and 18.
So he actually was a teenager then, wasn't like that?
Yeah. No, it was because he was like kind of a teenager in the Tim Burton's Mars Attacks too. He was the soldier boy hero in that that the main character was kind of jealous of. And he was a teenager and had the same kind of look in that movie. But yeah, it's wild to see him so young. The youngest thing I've seen Jack Black in is, if you look it up, it's on YouTube. He did a commercial for Pitfall, the video game Pitfall, for Atari, when he was like, I don't know, maybe 7 or 8. So yeah, he's been around for a while. Story in Pick of Destiny about his origins is just a lie.
And so I remember something about, he gave the girl his mom's name or something in this movie.
Yeah, he gives the childlike empress. She doesn't have a name. He gives her his mom's name, and it saves everything. Yep. All right, what's your number 2? I'm interested to see what you're going to
Alright.
pull out.
I mentioned this before, but my number 2 is No Way Home. Ending of No Way Home.
Oh my gosh, yes, No Way Home was Aunt May, his friends forgetting about him. We do get the redemption moment with Andrew Garfield's Spider-Man, though. That was freaking this scene you have at the bottom on the bottom right. That is a beautiful scene. I feel so good that he got to dive and save MJ. Finally, he saved MJ.
Yeah, that was one of the 2 scenes that when I was watching the movie the first week that got an applause or a cheering from the studio.
Actually, I said MJ, but his problem was he couldn't save Gwen. But in this universe, there's no Gwen. Which I always liked Gwen better than MJ too, but that was always just my opinion.
Well, I didn't like the MJ played by Kristen Dunst in the Tobey Maguire trilogy, but I did like this MJ.
Yeah. Well, I mean the character from the comics too. I was a big comic book nerd when I was a kid in the '90s, and at that time MJ was his arm candy, but there was always flashbacks to the death of Gwen Stacy and his relationship with Gwen. I always kind of liked that better. I kind of wish they left Peter single and I hate to say that, but Peter being miserable is kind of the driver of the story, him struggling and failing in life while he also, while he struggles and succeeds as a superhero. But and his candid demeanor is kind of a coping mechanism for all the hardship that he suffered in his life, the way his behavior is and the way he talks and quips at the villains.
And I know this one was sad because he promised them that remind them, but then he's like, no, they're better off without me. So I'll let them live their lives without me.
Yeah. Kind of wonder where they're going to go with things moving forward.
Well, I think
go ahead.
Second one.
I was just going to say the death of Aunt May was very very traumatic for the series, but after the loss of especially after the loss of Tony Stark, but then him losing his best friends and losing the only other parental figure he had, which was Happy, that was miserable too. But now he gets to be where he's supposed to be as Spider-Man, poor Peter Parker, going to university, living in his single low-rent apartment.
Well, if he even can get university, hopefully he does. But I think he's the only. I might be wrong. I've seen all the comics and stuff, as well as the cartoons. But I think he's the only Peter Parker that hasn't graduated. That can't graduate from high school.
Did he not graduate then?
Well, no, because all his records were gone. So he had to get a GED. He had to get at the end of the movie. He had to get a GED. Because,
oh yeah, so he's like starting all over again. He was like IT tech school intelligent. I wonder what happens to all the stuff that. See, there's some holes there that I don't understand. What are they going to do with all the stuff that Tony Stark left to Peter Parker?
Well, I guess it's all. I think most of the data was erased from him, like all the pictures, like they showed something like that in they remade the movie a month or two ago. They had a new ending, where their kids were graduating, and they showed all the like pictures and videos that they made throughout the year, and somehow Peter had been edited out of all of them, like either cropped or like birds, or like in the picture of them in Europe, they had birds in front of his face, so no one could see him, no one remembers him, nothing. There's no record of him at all.
Yeah. I still haven't seen Multiverse of Madness or anything since then. I've just been kind of, because my living situation is mostly what's kept me from being able to watch that. Haven't seen She-Hulk or any of the new Marvel stuff that's come out. So this was the last big Marvel release that I saw. So I'm like way behind. I love the MCU. I've just not been able to catch up with it because my life's been kind of whirlwind lately. But I hope to get caught up, and hopefully you're not gonna have any spoilers related to any of these characters for me.
No, but all I is hope somewhere in the future that they remember. Hopefully they remember him, because I don't know what it is. I think it's unfair if he tries to get a relationship with him again, they don't remember him. It's like a one-sided thing. Somewhere, hopefully, I want him to have a happy ending. It's at least his two friends remember him.
Yeah, but Spider-Man's not supposed to have a happy ending, though. That's part of his character. I mean, he's supposed to have a happy ending for the superhero, but not for Peter. Peter has to sacrifice his happiness every single turn for Spider-Man and the greater good, because he cannot focus on his personal life or his own happiness because he has great power. So since he has great power,
that's the sucks though. He's the only Marvel hero that can have. He's the only Marvel hero that can have a family. Like
he can
everyone
have.
Else.
And there's a story arc, okay, where Peter and MJ do go forward and have a family and have kids. MJ dies of radiation poisoning from copulating and having Peter's child. There's a version of the Marvel universe where that happened.
It's sad
because it was radioactive blood, radioactive semen. I mean, I don't have radioactive semen that anybody knows about, but I don't imagine that I'd be too thrilled about it if I did.
Yeah, this is sad. Like Ant-Man, Hawkeye, pretty much everyone, even Iron Man had children.
Right, got to have happy ending and children, but not Spider-Man. Oh no, oh no. I thought you were gonna, like, I see you're pulled up. I wish I would have been able to send you some pictures. I'm so sorry. I would have sent you the pictures of him with the horse in the swamp. It's such a sad scene. So that you can compare it, like what we're seeing here, actually seeing the emotion in the character's face. She's an actual amazing actress, Zendaya.
Yeah.
My son says, "Oh, I can't stand Zendaya," but she's freaking phenomenal. She's sardonic, but that's most of the time that's the character she's playing. But
yeah,
she's a phenomenal actress.
Yeah,
look at that emotion in those faces.
Yeah, I like the line she said. She told for the memory spell. She said, "I love you." He tried to say it back, and she said, "Tell me when you see me again," and he didn't.
Yeah. Because he's letting her live her life and trying to let her have her happiness, because he cannot have that. All right.
But I know it's fair, but I know it's his trial, but I want to see the consequences on their side too. To see if
what happens
if their lives are, if he thinks Peter thinks that being away from them will make them happy. But I want to see if that's true or not. If it's true, or if they're like sad.
If Ned and Mary Jane or MJ are actually happier and better off without him.
Yeah.
Well, I thought that Ned was going to be a wizard. Now it's kind of that's been nixed. He's not going to be able to be a wizard.
Yeah, it's like, like they go on throughout their college year thinking something's wrong with something's wrong. At the end of the movie, you can see it. It's even in the script that they see. She has like a deja vu memory or something. When Peter leaves, she's thinking something's happening in my brain. Do I know that kid? It's like,
yeah,
the memory's there and just in the back of her mind. But it's not there. Oh, and there was, I don't know if it's gonna be happy in the future movie or not, but there was that line, where Ned said, "I promise not to become a supervillain and try to kill you."
Yeah.
Well, you know what that's referring to?
What's that?
In the comics, Ned becomes one of the hobgoblin.
Oh, I didn't know that. Ned becomes the hobgoblin? I know there's been a few different hobgoblins throughout.
Yeah, one of them, he's the hobgoblin.
Yeah. Okay. Well, that's interesting.
So that'd be a cool thing, since if he doesn't remember Peter, and he tries to kill Peter because he knows who he is, and that's another consequence of him not keeping his promise,
Yeah.
Because now he has to fight with the other Peters. He has to fight his best friend now.
Well, I mean, we've seen that before with New Goblin with in the Raimi universe, where Tobey Maguire's Peter Parker fought Harry Osborn.
Actually, in both movies.
Yeah. Oh yeah, with the Amazing Spider-Man too, or the yeah.
Because that Harry's the reason that Gwen died.
Yeah.
But yeah. Oh, I was off topic. You know, a lot of it's the same thing with the new mermaid thing. A lot of people don't like this her playing Zendaya playing MJ because, you know, race color and stuff.
Yeah, just people being silly racist.
But like I said, I liked her a lot better than I liked Kristen Dunst's performance.
Yeah.
Personally.
Yeah, I agree.
Yeah. But
All right.
unfortunately, this is only my number 2. So now we're going to get to our number 1. First, we have Eric.
All right. All right. Yes. We kind of brushed over this when we were talking about Land Before Time, but The Lion King. Yeah. How traumatic is that? That scene right there. You got to get up, Dad. You got to get up, and then.
Yeah, I was 14 when this movie came out in the theaters.
Yeah, I was 10. And I remember watching this in school in 4th grade, and so many people cried. So it wasn't isolated that this movie was sad. They took what Bambi and Land Before Time had done and kind of amped it up here with some dialogue that includes not only him being sad, like what you see with Littlefoot and Bambi, with the character mourning the loss, but you also have a vicious, underhanded, villainous character who comes in and with fake sympathy blames the member, or blames the child, I guess we call him the child, for the death of his own father that he just killed. It's very Hamlet.
Oh yeah,
that's Hamlet. Is it Hamlet? Yeah.
With Hamlet, but with animals.
Yeah.
And the thing about this one versus Bambi, I don't know if it's sad or not. Like they did Bambi's mother off screen, so we didn't actually see her die. Is implied, you know, but you know.
Oh yeah, seeing Mufasa fall. But then he gets, so you see him fall, right? And Scar throws him off. You see his face, the terror in his face as he tumbles into the wildebeest herd, right? And he disappears in there, and Simba's like, you know, oh my God, my dad. Then Mufasa leaps like a boss out of those wildebeest, works his way over to his child, grabs him, and manages to rescue him and put him up on the ledge before being carried away. And the next time we see him, he's right, like we see him right there. He's gone.
And he's pretty much on his own until he meets the 2 other people. But yeah, because Bambi is not. Yeah, Bambi's with his friends, and so is Littlefoot with his friend, but he's pretty much on his own.
Yeah, Bambi and Littlefoot both had their friends like close by when they had their loss. Simba was all alone. He was not all alone. He was with Scar, and and when Scar said, "Run away and never come back," Simba was on his own across the desert, wasn't he? He ran across the desert as a cub.
Yeah, deserts, plains, savannah, whatever they have out there, until he ran into the comic duo.
Pumbaa and Timon. Yeah. And then the story gets a little lighter from there. But up until then, you're dealing with this. There's a lot. Well, and it kind of comes back and haunts him a bit too, like when he sees this father of the clouds and stuff. That kind of imagery, and seeing Nala again brings that all flooding back into him. Yeah.
Yeah. Well, he could always ask his brother and sister Luke and Leia for help.
Yeah. And this was Eric's too.
Yep, that was Eric's number 1.
Yeah. So Eric, I think we can tell a lot about Eric based on his picks. Yeah, here's my super, super sad one. This is my number 1.
My girl.
This movie it did not in any way prepare you for what was going to happen at the end. The story didn't even give you any implication that this was the direction things might head. It was a coming of age story about a little girl and her summer after her summer of coming of age, if you will, and the loss at the end of her best friend was blindsiding. There was some foreshadowing to it with the bees before, but it was almost played off comically, right? They ran and jumped in the water. It was cute. This cute little couple of kids running down the dock and jumping in the water by being chased by a swarm of bees. And it was just played off that way. But when they find Veda and tell her that Thomas J went back to get her mood ring, her reactions, and it's so real and so heart-wrenching.
And her breakdown in the middle of the funeral.
This scene right here, oh my gosh, yes. Didn't she start singing here? There's a part where she starts singing.
I was singing, but here she says, "Where's his glasses? You can't see all his glasses."
Yes. And his mom is in the funeral parlor sitting there. She's watching this, and you see the emotion and breakdown that she is having, seeing Veda respond this way and react this way to seeing Thomas J in the coffin. There was some foreshadowing too when she's watching them bring in coffins, sitting there talking to her dad at some point, or caskets, and sitting there talking to her dad, which is Dan Aykroyd. Great, he does a great job in this movie too. Him and Jamie Lee Curtis play their roles excellently. But she is definitely the star of this movie. But she's asking him what's the reason for the small caskets, and he says they're for small people. And I think she asked if they're for children or not. But seeing her come up to him like this, laying in the casket, because there's some foreshadowing to that too, that when her dad and his partner are down in the funeral parlor part of it, down in the room where they actually do the preparing the bodies, she's terrified to go down there. She's terrified to see dead bodies and see dead people. So her going up Thomas J like this is showing a growth of character too.
Yeah, I forget how old I was. I maybe a little bit later, but it's more of a happy thing. It's sad too, but I think if I remember correctly, she was. I think she might have been the first actress I had a crush on growing up.
Yeah, sensible. Yeah.
I think it was more the second. I think it was more of the second movie I developed in. I might have been too young still to like girls yet at this point when this first movie came out. But,
yeah. The second movie where she's kind of more of a teenager and going with bohemian lifestyle and stuff. And leading into that.
And when she thought she lost that ring, his ring, in the guitar pit, he freaked out again.
Yeah. He was just playing a prank on her, wasn't he?
Yeah, and she thought he threw in the guitar pit, and she lost it. The same ring that
she was going to climb in there. Yeah.
This is the ring that he died for.
Mm-hmm. Does she ever explain that to that other kid in the
I
second
think so.
movie? Yeah. The only thing I remember about him is it's the same kid who played in the last Action Hero.
Yeah, but I think this movie right here, the first one, came out in between the two Home Alone movies.
Yeah. Yeah, because My Girl was before Home Alone, right?
I think it was before. I think it was after Home Alone 1, but before Home Alone 2. I think.
Okay.
I could be wrong in my timeline, but
he looks so much younger in this movie. Macaulay Culkin, I mean.
No, he's supposed to be 8 years old in the first movie, but he the character was supposed to be 8 years old, in the first movie, first Home Alone movie. But I guess some child actors, just look younger.
Yeah, no, I get that, and it's funny thing about Macaulay Culkin is he's still out there doing stuff now. I mean, he was out of the scene for a while. He was actually delivering pizzas, I think, or something along that line, but he's actually back doing some acting again.
Yeah, and he has a kid with another actress.
Yeah, I remember that. I can't remember who it was though. It was somebody it was a TV actress though.
Brenda Song from Zack and Cody.
Yeah, there you go, from Zack and Cody. Exactly. Yeah.
But yeah, it's like, and also the couple, I was having to get chemistry back. My number 2 is, Peter and MJ are dating in real life.
Oh, are they?
Tom Holland and Zendaya.
I didn't know they were actually dating.
Yeah.
That's interesting.
They have puppies together. But yeah.
Savannah Smiles was really sad at the end. Who's Savannah Smiles? Is that at the end of My Girl?
I do not remember.
Is it the song that plays maybe? Yeah.
But
My Girl 2 was not nearly as sad as the first My Girl. There's nothing that compares to that first My Girl.
Yeah, I think it's supposed to be a sad. What's a sad movie really? What's to be? But yeah, it's kind of like what I think of it for. Well, I forget what my train of thoughts. I forget. But yeah,
I almost forgot her poem at the end that she reads to the to the poetry class is really impactful about the willow tree and where they had played as kids. Because it really is a coming to age. She is up until the scene after Thomas J's funeral. Well, she goes from Thomas J's funeral, then she goes to that teacher that she had a crush on and finds out that he has a girlfriend and gets upset about that too. So there's just
everyone she cares about is disappearing from her life. First her best friend, and then this.
It's cascading down around her, right? She has a bit of a breakdown. This is doubly impactful to me. When I was older than this. I was 15, but I actually had a friend die when I was we went swimming together, and he drowned while we were swimming together, and it really messed me up like this for a while. I was wishing it would have been me and things like that. It took me a long time to get over that.
I was 11 when this came out.
Yeah.
91. I was 11 years old, so I was just at the age, like girls are being yucky, girls are being icky and liking them.
Oh, yeah. I do remember this being more popular with the girls at the time. I was pretending to be a boy, so I really wasn't allowed to express myself. How much of this movie impacted me and how much it touched my feels, but it really did. Now I'm more free about it. So, yep, this will make me cry every time. Just make me watch it, and I'll bawl like a baby.
Yeah, but now I checked it. I was right. Home Alone 1 came out in 1990. Home Alone 2 came out in 92. This came out in 91.
Yeah, so those were projects back to back to back.
Yeah.
All right. And what's go ahead.
Number 1. It's an anime based on a game called Dog Naropa. This was episode 10 of the Despair arc, Chaki Nanami's death. This was so bad that I have not been able to. This was so bad to me that I have physically not been able to watch this episode again. I can watch every other episode of this anime, but this one I skip over every time. I cannot watch this episode anymore. It was that the death was that bad for me.
Looks like it was brutal.
Yes.
Is that blood?
Yes.
Oh my gosh, that's brutal. What happened to her? If you don't mind me asking.
Well, she had to go through like a hallway full of torture devices, like pins, spears, like everything, and all of her classmates were forced to watch this happen while being brainwashed. Her dying because this evil bitch called Junko created like a thing, that controls people's minds, almost brainwashes them, makes them think like her. And she forced all of her friends to watch her die while they sink deeper into despair, and at the end it brings them joy. Imagine, this girl, she's in all the games, imagine if being sad got you off sexually.
Eek.
And the sadder something is, the bigger orgasm you have, something like that.
Yeah.
That was her, and she made all of her classmates think that way. So in the thumbnail, right there, you see her, says, "No more. I don't want to see this." You can see them. The thumbnail, they're crying. They're also smiling. That's how twisted this made them.
Yeah.
All her friends, she going to save them. She went to save them, but the deck was stacked against her, and she got impaled by spears at the end.
Yeah.
It was so brutal. So I cannot. Like I said, I cannot physically watch this anymore. It's got me so bad. So
I can think of something that's maybe similarly brutal. But go ahead. I'm sorry. I didn't mean to cut in.
But like I said, I don't know. I lost my train of thought. What's brutal, like you said?
Oh yeah, I was going to mention the end of the first season of Primal. You ever watched the Tarjinsky's Primal? It's about the spear and fang with the caveman and the dinosaur. The end of the first season, the dinosaur saves the guy from this ape monster, but it gets like beaten to a pulp and is basically dead at the end of the season. And you leave that season thinking that Fang is dead, but the second season shows him nursing her back to health.
But yeah, and this thing also so bad that the boys he had a crush on disappeared, earlier in the series, and he like a different person. Like he got experimented on. And in this world, there's the talented and the non-talented. And the non-talented are looked down like second-class citizens. Like kind of like in ghettos. You don't have talent, you're nobody. So like the guys he had a crush on went, to get a talent, to do that, the school she goes to erased his personality entirely and planted nothing but talent in him. So he was pretty much a super husk. He was super talented, but since he had no personality, no emotions, he's like everything bores me now. I can do anything. Like he doesn't even try to do anything because he can do it. He's the best at everything. He's like, whatever, yeah, I'm throwing the baseball, I win, big deal. And but at the end, she reaches up, to say she wanted to play games with him and her class one more time, and she dies. He picks up the her hairpin, and he starts crying out of nowhere because I guess the inner him, his past self, was just crying. He couldn't understand why he was crying. And
Yeah.
in the game sequel, all of her friends are put in a VR, a virtual simulator, to like try to help them cope, or get hope back. And in the simulator, like they're supposed to break. I don't like explain. I'll get that fast. But like what's what I'm looking for. Personalities are like they're all scanned, for a
Okay.
Come on.
I wish I could help. I'm not familiar with the series though.
But you can talk about. Was there any anime that you ever saw that made you sad?
I do, to be blunt with you, I don't really watch anime, so no, not particularly. Anime is just not a media that I've ever really got too much into. I've seen some of the, the sequential ones, the not the sequential, the quintessential animes like Cowboy Bebop and Akira and that kind of stuff, but I've never watched too much beyond that. And it's been a long time since I watched either of those too, if I being completely honest.
But yeah. I can't explain it, but I'll show if I can see the video working. I'll show it real fast.
Mm-hmm.
It's working. Hopefully the sound works, but.
Mm-hmm.
が抱くイメージは
If not, you can read the set. Oh, that's right. I needed it. 1 second.
I can hear it.
ねえ、ひなたくん、知ってた？みんなが新世界プログラムに入ってきたとき、みんなを管理するための AI が作られたんだ。それが私。まず、みんなの管理者にふさわしいイメージを読み出して、それを統合して一つの人格を作るはずだったんだけど、でもね、その必要はなかったんだ。みんなが抱くイメージは一致していたから。みんなには心の底からもう一度会いたいって思う人がいたから。性格には別人だけど、 みんなのおかげで私はもう一度に会えたんだよ。
But yeah, like so much that they all like I said, the personality is supposed to be a mixture of everyone everyone they cared about, but they all thought about her. So
And it's created an AI that's basically her.
yeah, like usually someone you miss somebody, they miss somebody, and they can personalities come together, to create a new person. But all 15 of them thinking of the same person.
Yeah. Right.
Like
That's your number one.
Yeah, even despair, even their despair and stuff. Their best friend, their classmate, was in the back of their mind this whole time. But yeah, that was, and like I said, it's my number one because, like I said, I cannot watch that again. It was so bad.
Yeah, sounds like it was pretty traumatic for you. Yeah.
Like I said, if you ever watch it, you probably only can watch it once. Just
yeah, could be pretty brutal.
Yes.
Yeah. Well, yeah. Thank you for bringing me on for this. This was fun going through this list with you and just seeing some of the stuff was overlap. Were there any of the movies that you that would have made it on your list if I hadn't picked them?
Let's see, movies. No, I think every movie you mentioned, it was on me too. But like I said, some of the movies have been so long since I've seen them. It doesn't have that. I mean, if I think about it, it's emotional impact. These more ones are more recent and more recent.
Oh yeah, I get you. So yeah, and I was thinking that way when I was picking mine too. Is that that a lot of these that I mentioned are ones that impacted me more during childhood than they have.
But yeah, but like I said, I still remember them too. It's just, and even in our old age of 40 in our old age of 40 right now, like these still make us cry.
Hey, I'm 39. Don't age me before I'm ready. All right. Well, I'm going to get off here and go something to eat. Thank you so much.
I was asking what's going to be up on your channel.
Okay. Yeah. So I should be back next Saturday with Live from the Hive. Next Saturday is going to be our Halloween special. So pop in for that. I'm not giving any spoilers, but it should be a fun ride if you're into that sort of thing. And then I'm not on my channel, but on Amy Newman's channel, I should be having a conversation with Cindy Lincoln coming up here pretty soon. So that should be entertaining as well.
All right, so everyone, check out his channel and see that. And you have a catchphrase you say at the end of your show?
Yes. Remember to be kind and take care. I'll see you next time.
Right, and never stop learning. Enjoy the randomness. We'll see you then. Bye. It's a little delayed, but we finally made it.
Yeah, almost exactly half an hour late. Sorry, that's all my fault. No, I'll tell you the truth. I lost my phone, so I couldn't connect my headphones. So I was technical difficulties. I've been crawling over the house. It was underneath a chair, by the way, just so you know. I was in there.
Oh, that and confusing Eastern with Central.
Mm-hmm. Oh yeah, that's why I wasn't prepared at all. Yeah, it was the time zone difference. But yeah,
welcome.
But since then,
you know who she is. Why don't you introduce yourself?
Hi, I'm Bree. I have a channel called Hive Science where I debunk bad science and also explore some good science from time to time. So if you like that sort of thing, come on over to the Hive. Maybe consider joining the Hive and subscribing. We are very, very close to hitting our first 1,000 subscribers. So I'm excited about that. Hello, Regios and Dr. Tapioca Weasel, by the way. It's good to see my friends popping into the side chat here. Sorry if my tardiness has ruined the evening for you, but I'm glad to see some people out there to hear us talk about what's the topic today.
It is, I can't pronounce it, but carcinisation.
You said it just fine. Carcinization, to become crab. Am I right? That's what we're going to do. We're going to become crab tonight.
So why is everything becoming crabs?
Why become crab? That's a good question. So let me see if I can't fix my camera. I'm really freaking blurry too. I will be right back. I'm going to go off camera for just a second here. So to minimize the resources necessary to support an organism with a minimum amount of space, right? So as long as they have the legs to move around and the claws as a feeding apparatus in the front, yeah, that's optimal. You see that with a lot of organisms, not just decapods, but it's especially prevalent in decapods, which includes both the what's the term I'm looking for here? Sorry, I'm losing my trying to adjust my camera here so I can come back on so you can see me. So you have Anomura, which are the porcelain crabs. They are decapod crustaceans. Then you have the hairy crabs, like the Yeti crabs. They are also subject to carcinization, and it's taking on these features with a small round body and a bear with me. Just
you mentioned that. I think you mentioned this earlier.
Technical issues galore, right?
On your channel, but some of these crabs aren't really crabs.
Yeah, well, it depends on how you define crab. Crab's kind of one of those terms, like, I don't know, like for instance, like monkey, right? That maybe isn't as informative as it sounds and on face value, because it's polyphyletic, right? It excludes a certain, like fish. There's another great example.
So crab itself is its own clade then.
Yeah, crab is applied to, because what we call crabs, and what we assumed were crabs for a long time, and when they were defined by fisheries and such, we've come to find out are classed in two separate groups, right? So you have your Brachyurna and your Anomura. So those are different.
We started usually looking at DNA and not just the
not just
surface features.
That they're shaped this way and have pinchy parts, right? That's you got to look beyond that. There's more to it than that. So what we call true crabs are the Brachyurna. They're completely carcinized. They're to the point where their rear legs actually stick out backwards. They're so carcinized. They tend to have a sideward locomotion, but they also get pretty dang big. The biggest ones are the Japanese spider crabs, which I'm sure you've seen at some point in your life. At least in photos. I've seen some in different aquariums and stuff, and they are essentially human-sized crabs. They're really skinny and alien looking, but they're human-sized crabs. The Japanese spider crabs are the biggest among them, and there's tiny little ones too. Like you see them, like just the same size as they fill in the same niche as insects in this semi-aquatic environment. But they all have one thing in common, and that's carcinization.
Now, is carcinization only happening on the Protostome side, not our Deuterostome side?
Well, you could make a case that like a turtle's body plan is a tetrapod attempt at carcinization, but that'd probably be about the closest you'd get is outside of Deuterostomes. You really don't get too much carcinization outside of I can't think of any true carcinization outside of arthropods, and it's really outside of crustaceans that it's questionable where there's something something would count as carcinization, right? So you consider something like an amelie pigeon, which are arachnids, but they have a lot in common with crabs and do have some degree of carcinization in their physiology. Another organism that's outside of the crabs or Crustacea is the pseudoscorpions, and they're an arachnid as well. And they are basically look visually, at least, like a scorpion without a tail. So, but their rear portion is still segmented. This is also what keeps the Inourna from being considered true crabs as well, because they have their rear or their abdomen is still segmented, at least in most species, right? Like you look at a hermit crab, for instance, when you pull it out of its shell, or when it climbs out of its shell, there's a big juicy bit that's all segmented. It's not completely carcinized. But it's got all the organs and everything in there.
Hermit crabs are kind of cool. I saw this video about them where apparently they line up. Some of them line up in like a parade to get new shells.
Yeah, they'll do a little trade-off system. Like when one of them's getting ready to molt and meet a bigger shell, they'll climb out of their old shell and molt, and then the next one will be in line to check out the shell and see if it wants to move in, and they just keep moving on down the line. But the hermit crabs that you really can really identify carcinization with are the ones that become huge, the coconut crabs, right? They are much like the spider crabs that we talked about with the true crabs under the sea. They're a giant false crabs, I suppose you would call them. I don't know if you'd call them that. They're usually listed as Anomura, hermit crabs, and others, but they have closer ancestry to other decapods that don't have necessarily the crabby bodies, including something called squat lobsters. But when it comes to
I think you mentioned that on your live show earlier, that like crabs go through a lobster phase in their embryological
development. I think I actually had a picture of that pulled up.
I was going to say in the womb, but I mean they don't have a womb.
Yeah, in the egg, I guess would be the best way to describe it, during their eggy phase. Let me see here. I had that pulled up. Just a moment. It was like carcinization. I got some pretty cool pictures.
If anybody's interested, I got 2 links down below about some papers about carcinization. You would read.
Yeah, I got some stuff I can read here too. I don't know how to use this system though, so bear with me. No, it looks pretty straightforward.
This third button, screen sharing.
Yeah, here's some fun. The crab was inevitable. Soon they shall rule the earth. I love become crab memes. Every now and then the internet discovers something you just sort of assume everyone knew. And that's, not all the nerds knew that carcinization was a thing. Like the fact that pufferfish inflate themselves in water and not in air. It seems logical that people would assume that fish, which famously remain underwater, when they are not dead, fill up with water, when they inflate themselves. But apparently, vast swaths of the internet learned this information on pufferfish from underwater levels in Super Mario. But this latest discovery is one that's a little more niche and a lot more interesting. Today's topic on the internet discussion is carcinization, or how everything in nature, well, just crustaceans, thankfully, seems to want to be a crab. crustaceans have evolved into the shape of a crab at least 5 independent times. I do not like. Somebody said they didn't like it, and you don't get to like or dislike it. It's just it's a preferred form. It's a favorable shape. I think that you could make an argument that what would you call it? What would you call taking the shape like of a true bug, like Hymenopterization, Hymenopterization, where you like what you see cockroaches do. I don't know, just a thought.
And
like tech bros repeatedly trying to invent a new type of transport and accidentally reinventing the bus. Evolution seems to keep spitting out animals that look like crabs. First coined as a term in 1916, so this has been around for a while. Carcinisation was originally defined as one of the many attempts of nature to evolve a crab. Convergent evolution is when similar features evolve in a species from different periods or regions that have similar forms or functions despite the last common ancestor of the animal or plant not having that particular feature. That is the difference between a homologous feature and an analogous feature. Homologies are ones that you share as holdover from a common ancestor, whereas analogous features are features that you evolved independently from a common ancestor that did not have that feature. That does not mean the common ancestor could not have had prerequisite features to the feature that you both share in common, but they cannot perform the same function that they do at their current evolution state that we're examining. Convergent evolution is when similar, we just read that.
So
think how echolocation evolved both, like bats and whales. There's a good example. Or flight evolving.
So are lobsters crabs that decide to give up halfway through?
Well, lobsters, you could almost call it neoteny in a way, but I don't know if honestly from my position right now, I'm not sure if the basal state is actually the crab or the lobster. I think it would be the lobster. I think the ancestors would be more lobster-like than crab-like, based on my understanding of how early arthropods evolved. I would say the one with more segments is probably ancestral to the one with less segments, and that the original organism had it is ganglia divided into this segmentation at the very beginning that was it was repeated, right? So that you start with an organism that's very worm-like with segments, and then once those segments of the body start to specialize and form different functions of the body, and you get Hox genes involved, and all the legs segments start specializing, and then the segments of the body that support those legs will specialize in order to support them, and suddenly you have specialized segments of the body, and the number of segments that are available to do whatever they were initially doing starts to slim down. The thing that happens with carcinization is basically all the segments, the original segments are gone. Just the segments of the body that made up the head remain, the cephalothorax, if you will. There's no the abdomen, which is the rear part of the organism that supports organs and waste management and reproduction. It all curls underneath in development and fuses with the cephalothorax as well. So basically everything is fusing to the head. The head is becoming they're essentially becoming a walking head. Minimizes the amount of resources they need to take in, but it's a loss of segments, not the lobster didn't gain new segments. So the lobster would be ancestral or more basal, I guess, of the forms. Is that the better way to look at it?
Okay. So have you ever had to debunk creationists on this topic?
I was just talking about crabs today. You know that. You were there.
Yeah.
I actually didn't. I didn't even. I should have put 2 and 2 together. It's crazy that I didn't. I'm like talking about crabs this morning, and I seen you in the side chat. I didn't even say, "Hey, we're gonna continue." I don't. Did I? Did I give you a shout out when we were talking about crabs? We talked
Yeah.
about the samurai crabs, and I actually got my channel or my stream pulled down for a for streaming AIG content. It was kind of a shocker to me, but you know, it is what it is.
So you finally figured out who flagged you?
Yes, it was AIG. AIG did not like me telling the truth about their crab videos. They were claiming that the evolutionary argument was that animals evolve human faces on them, specifically these crabs that evolved human faces on them to scare away humans from eating them.
And then we threw them back, and they're the ones that survived. I think I asked that question in the side chat. So would that be natural selection or artificial selection?
Yeah, that's like it wouldn't even that it's
because
so it'd be natural selection, right?
Are causing them to breed faces. They're the ones that get like nope. We'll get the non-face ones. And the face.
Yeah. Well, the thing is the faces came first, right? The fact that humans could see a face in there is just pareidolia. That's the way that we evolved to pick out patterns and faces and colors and all this stuff. But one of the features is for us to look for human faces and everything that we see in nature. You know, we're always looking for faces so that we can find them in these crabs, and maybe it spooked people out because they look like angry faces or angry samurai mask is what why they call them the samurai crabs. But the idea that these faces evolved in order to in response to them throwing human heads into the water and the crabs deciding that it was a good idea to look like human heads to scare humans away is really weird. And I don't think that anybody was ever saying that or trying to make that argument. What do you think?
Yeah, it's just, I was just thinking. I was just, like I said before, I was just thinking that by doing that, we're letting them breed more and this have sex more, and so that's why there's more population.
Yeah, if you take a group of organisms from in an environment and say, I'm not going to eat these organisms, those organisms will thrive in that area because you won't eat them, so they're going to thrive. You're a predator, no predatory pressure, they thrive. That's not even speculative.
It's the same. It's the same with fish. Everyone catch the big fish, not the little fish. All of a sudden, there's no bigger fish left, and so the fish, only the smaller fish are breeding, and there's no big fish to eat.
That's what happened to the whaling industry, right? The whales that we have today aren't even. They're maybe 80% as big as they were 100 years ago before industrialized whaling kind of. It basically wiped out all of them, all the large ones, except for like marginal populations that are just starting to come back. But the ones that remained are not the big giants of the past. They're not the ones.
I think the same's happening to elephant tusks too.
Mm-hmm. Yeah, elephants are the ones that are reproducing have smaller and smaller tusks, and now they don't even have tusk in some populations. So, because it's a better survival trait to be tuskless in the current environment.
Yep.
The current biome.
Natural selection is now going against our human predators.
Yeah, and so it's not unfounded to say that because the resemblance of the crab to the samurai mask helped prevent the species from being hunted or being preyed upon by humans. Specifically, if you want to use ecological terms, but that's not to say that they became the samurai mask look. They developed that look to to deter human predators, which is that'd be like Lamarckian evolution, right? That'd be like saying, "Hey, it turns out that looking like a samurai mask was a benefit, and now I'm going to pass it on to my kids because it was good." That's not how it works. It's just like what you said. The ones that don't get killed off because superstition, that's still going to affect what genes are passed down and what populations thrive because of the superstition.
Now, you mentioned this happened. Carcinisation happened 5 times, at least in this family tree. Do you know which ones they are?
Yeah, I think I got it. Got the list of carcinization pulled up right here. It's just from Wikipedia, but it's got a short list of the groups. So carcinization, you have within a decapoda, you have the king crabs, which are popular dinner items. You have the porcelain crabs or the squat I guess these aren't squat lobsters. They're related to squat lobsters, right? And then you have your hairy stone crabs, hermit crabs, including like the coconut crab that we talked about earlier. And then you got the group Brachyurna, which is the true crabs. So those are your groups that have gone through this process that are officially subject to carcinization. You can see the lineages branching off here in the groups that Vandalia has pulled up here, so you can kind of get an idea. Now, the processes that cause this are generally that this is a good foraging body type. Most of these organisms are going to be a mobile forager. That's not a hard fast rule, but that's what this body type favors. Not a lot of swimming up higher in the water column. These are going to be bottom dwellers. Terrestrial groups, of course, can become more specialized, and obviously there's other crab groups and groups that experience carcinization that are filling other niches as well, including in terrestrial biomes. All right. I wasn't finished reading this. Nope, not that. Where's my article at? There we go. Okay. Now it tells us a little bit about convergent evolution. Uses
So that's
all
like
the
what
different
we talked
worms.
about. That's how like all 5 of them decide that they go in that body shape plan. Even though they're nowhere near each other in the family tree.
Yeah, it's niche driven more so than individual genetics driven, right? So it tries to it weeds out when you're mapping is you gotta try to weed out the convergent from the analogous, right? I got that backwards, from the homologous, right? You gotta weed the convergence where 2 groups had a common ancestor without the feature and developed it independently. And where do you draw that line? So the fact that we know that early arthropods, for instance, had an ability to generate different structures of its limbs, including pinchy parts, that even as far back as, like, we're talking early trilobites had little pinchy parts where they could help feed themselves. The genes to create this grabbing appendage. And is the fact that all arthropods have potential to develop that? Is it convergent, or is it
kind of like you can say the same thing for like dolphins and ichthyosaurs?
Mm-hmm. Yeah, because is the dolphin just convergent evolution? Because the dolphin did have an aquatic ancestor that at one point in time that was very fish-like. The
fish.
Our tiktaalik ancestors are it's still sauropterygian fish. They're still dolphins have taken a fish body plan, became a mammal, had paws and everything, then went back to fish body plan. So
And the same could be said for seals, sea lions, manatees, walruses. They
Yeah.
all
there's
from the
only
different
certain
sides of the
ways to
family,
go
but
back to.
now they all have flippers instead of instead of.
The funny thing about that with the mammals and the flippers specifically is that that no matter how flipper they are, they all still have the same digits that we have, the same sauropterygian, lobe-finned fish digits that we inherited from the first ancestors that flopped out of the muddy depths, right?
Oh yeah,
As
you do know mermaids are just the survivors of Noah's Ark flood.
Yeah,
That's
just the bottom half had to change, right?
Yeah.
Yeah. So I see a question that crabs are a type of, what's the question? Sea
animals, like from the sea.
Sea animals. Okay. It was covered up by the thing. I see you got it pulled up down here though. Sea animals, correct. So I mean, there are crabs that live completely terrestrially. Well, as adults anyway. All crabs, I think, spawn and reproduce or need water to spawn and reproduce and lay their eggs in. Correct me if I'm wrong, if you can think of a species that doesn't. But I think most of them need seawater specifically. I think some of them can survive in brackish or even freshwater as adults. I think in their juvenile states, a lot of them are planktonic as juveniles, so they live in like floating in the water column with plankton and such, right? But as adults, there are ones that are completely terrestrial. There's some where they're arboreal. There's coconut crabs are called coconut crabs because they climb up coconut trees, and that's their lifestyle. That's their natural lifestyle. But they're also called.
Can their claws break into coconuts?
Mm-hmm. Yeah, they got such strong crushing claws that they break open coconuts, which some of the other organisms on the islands that they live on completely depend on the coconut crabs to crack the shells on them so that they can get a snack too. But they're also cannibals, so there's that problem. When coconut crabs are babies,
species can be good and bad sometimes.
Yeah, when coconut crabs are babies, they actually do like other hermit crabs. They live inside their little shells, and but when they get too big, that there's no shells will fit them anymore. That's when their abdomen kind of fuses up and hardens up, so they become more crab-like, and they don't no longer take a shell. And that's when they start really living the lifestyle of climbing trees. And they call them robber crabs for a reason, though. But it's because in addition to climbing up things to steal coconuts, they'll also climb up things to steal just about anything that they can get their claws on. So
do the coconut crabs still have to lay eggs in the water, or
they still spawn in the sea?
Oh, so they haven't come kind of amniote in that side of the family tree?
Nope, not these guys.
I guess that's only an us thing so far.
Yeah, so far. Well, other arthropods did become. I mean, I guess you wouldn't call them amniotes, but they did finally develop eggs that could be laid on land. I think they actually probably developed that, but way before we did, before tetrapods did. I think that there would have been insects.
Damn, arthropods always first on land, first in the air.
I'm thinking that beetles were probably able to lay. They probably needed moisture. I mean, even now, most organisms need some level of moisture to have their eggs thrive. Like you'll see species that lay their eggs in like a desert or something, and they won't hatch until that rainy season or things like that. There's actually some crustaceans that do that too. So, brine shrimp, as they call them. Mm-hmm. You'll see these big puddles in the middle of the desert, and you'll see all these little creatures scurrying around, and they're brine shrimp that had been dormant for months and months since the last rainy season. And then when it rains and these pools fill up, they they hatch, they grow up, they mate, they lay more eggs, and then they die off as the puddle dries up again. It's really cool kind of life cycle that they have, and who knows how long that they can survive. I know that we've had some experiments done where they survive in this dehydrated egg form for years, for even decades, and then are suddenly propagating when they get wet. Interesting stuff.
Yeah, I know that the samurai crab things are like quote accidental things. But has anyone ever tried to actually breeding crabs themselves, like we breed dogs breeds?
Breed crabs?
Yeah.
Well, there's crab farms that people mostly for food though, that people can breed them kind of like they do with tilapia, but it's definitely not there hasn't been anybody who's set up a good enough system that we could start specializing, that we could start
get to it, Bree.
Yeah, right. There are some, I think that
on YouTube here.
So when it comes to arthropods and trying to do that stuff with them, like fairy shrimp are probably the go-to that people think of, because with fairy shrimp, I have some fairy shrimp back here in this thing. They like different, they come in different colors, they respond to different kind of tank lights and stuff like that. So I think if there's anything that we need to do that with, it's fairy shrimp. I think fairy shrimp we should replace night lights with fairy shrimp with little LEDs that make them glow.
All natural light bulbs.
Yeah, natural light bulbs. All right. Let's see. I thought we'd have more to talk about with crabs, but carcinization is really just kind of self-explanatory. Now, it turns out crabs are a form so efficient, many crustaceans are getting in on the action.
So this basically this is this head with legs.
Yeah. This is the ideal male body. You may not like it, but this is what peak performance looks like. Do you see it?
Yeah.
Don't throw no shit.
They have like 6 legs and 1 and 2 hands.
Decapod. Yeah.
Oh, decapod. So like they have 10 stuff.
Mm-hmm.
I think Deca is. I think
now that I look
10.
at false crabs, it makes sense. The ideal body is less than 50%, is at least 50% weapon. Yeah, because those huge, great arms is what you call this. It's another feature that pops up in developing arthropods. If there's not something in the environment that has great arms, it seems like evolution's more than happy to try to take advantage of that and add these huge weaponized forearms in order to
claw size is like a form of sexual selection, I think. Hey, that guy's or that girl's got a big claw. I'll mate with him.
Yeah, because big claws are sexy. I don't even think humans disagree, but it seems that people will accept convergent evolution in species, but they draw the line at carcinization. Some cosmic horror for you, given the consistent nature of fluid dynamics and water temperature where carbon-based life can survive, the sheer probability of life to be rife in the universe, that there are probably several intelligent species of crab-like aliens out there. I am ready to meet them. I'm ready to actually bow to them. Let's welcome our arthropod-like ancestors. Or not ancestors, but overlords. Here's what I was talking. This is the life cycle.
Yeah, I used this as my thumbnail, but I had to cut half of it off.
Yeah, this so at least from right here, they take on the very crab-like appearance. But up here you can see
a little bit on that.
Let's see here. Yes. An image. Well, let me do it. Let me see.
can.
Is that helping?
Oh, wait. Yeah.
All right. This is the green drop down thing moves anyway. All right, yeah. It's just the life cycle of a crab where it starts off. These are planktonic forms right here. As it gets more crab-like, as they start to drift more and more towards the bottom, they start to take on more mass and become heavier. This one, as you can see here, still has its paddly legs there, but is also more in depth for living and scrounging through the soil. But you can see also that here's the segmented body. This is what I was talking about, the ganglion segmented biology, and there's legs homeobox genes can express to allow legs to sprout out of this segment, or it can fuse, as we see with crabs. It starts to curl under here. The abdomen is half curled under itself here. Finally, as the rest of the body reduces, as the rest of the body grows, it reduces and atrophies to curl up underneath, fuse with the adult body, and voila, now you have a completely carcinized true crab, my friends.
Nice.
Nice, right? I hope everybody's getting kind of the idea of what's going on, how it started and how it's going exactly. This is just the nature of the beast. Aliens arrive. There are two options. They are space crabs, or they are running from space crabs. I want to meet space crabs.
Space crabs. Is that like the octopus from space theory thing?
A space octopus, yeah. Oh, let's watch this. Here, do you want to see a boxing crab wearing its Unedited boxing gloves?
Sure.
Yeah. I'll get your channel taken down too. They wear those on their.
So that's like what's it called? Not parasites. The cooperative one.
It's it is mutualism.
Yeah.
So the anemones protect the crab from because you can use them as predator deterrent to ward off threats, and then anemones get the protection of, hey, we're part of a crab, and we can collect and they can carry us to where the food is.
How? I guess that for stinging, because I guess that's for stinging. I guess because really whatever could eat that crab can't really be eaten by that enemy unless it has a big stomach.
Yeah, right. So the fact that the anemones get to feast on whatever the crab manages to grab a hold of and kill helps,
Yeah.
Mm-hmm. But what's your favorite kind of crab?
I guess the hermit crabs, because
yeah, I like hermit crabs with their protective shells.
I guess that they're like the mobile home people of the crab family. They go like, okay, time to get a new house, and move in.
I got let's see here. I want to share. Share that too. Look at this. This is since you said you liked hermit crabs, this is a coconut crab, which are essentially just giant hermit crabs. This one is grown big enough that it no longer needs a shell, but you can kind of see its crabby little tail folded underneath there. Do you see it right there?
Yeah.
It folds underneath. Just like where's the camera? Like that. Just fold it, like it starts off like that, and as they go into the shell, and as they no longer need a shell, it curls up underneath, and and that gives them their crabby appearance. Then this is our crab. This is our squat lobster. You can see they have more more prawn-like faces than real crabs do, or than more prawn-like faces than a hermit crab as well. But these ones tend to have a lot of seta on their arms. The Yeti crab falls into this group, but I like this one because it's zebra striped, so I picked it for the picture. And then I wanted to show you this too. This is a amblypygid becoming crab. Seems like one of its sensory arms is missing. Yeah, these are I was looking at different arachnids that they use in spec evolution to become carcinized. And then lastly, this is the pseudoscorpion that I was talking about, where it's like a scorpion without the tail. It's the same, it's very similar structure to its pedipalps and claws. And yeah, but you can still see that it's very much is still a segmented organism with all the features that you would expect from an arachnid. Now, there are no spiders with claws. I just want to get that out of the way there. But spider crabs can be considered a sort of convergent body plan to a crab, in the same way that their body is fused, that their abdomen is fused into one area, but obviously they're still segmented in the thorax and the cephalothorax. But amblypygids, like we were just looking at here, completely fused cephalothorax. The abdomen is fused, but it's still mobile. So it's in the process of an evolutionary process of fusing. It's likely that the descendants won't have separate cephalothoraxes and thoraxes, if that are cephalothoraxes and thoraxes, cephalothoraxes and abdomens. But the other group of arachnids that also could be considered in this family would be like, or in this group that would be carcinized, would be like some of the more specialized harvestmen or empiliones. So another interesting group of creatures to look into. I didn't pull up a slide of them though, unfortunately. All right.
So
okay. Do you have any other questions about crab I could entertain?
Yeah. Anybody in the audience have any questions? Put them in the chat right now. But here, like, so these are all. So is this all the crab family, or only on the?
Well, let's look at the bottom here. So the very bottom, you see, we got Murina, right? And then you got Anomura and Brachyurna. Now, Brachyurna is the true crab. So right at the start, you see the carapace flattening and widening for the Brachyurna. Very beginning, that purple, that pink dot at the base, at the root, down at the root of Brachyurna. See the pink? That one right there. So at that point, they developed the carapace, which is flattened and widened. So the carapace, which is made up of the cephalothorax, or the cephalus and the thorax fused, the cephalus and the thorax fused ganglion. And then when you see the pink develop in these other groups, is further down the line, or the purple develop in these other groups. Specifically among the Anomuras, it's more of a modern.
So these are the imitation crabs portion on the Amur side.
Yeah, and some of them don't even have some of them don't even have the flattening among their characteristics, right? But some of the other features, because all four of these features are basically what makes carcinization a thing. Reduced or lost uropods, pleon flattened and bent, sterline fuse into wide plate. So these are different characteristics that become present in different groups as they carcinize. And you could apply some of these features to different groups like amblypygids and the arachnids, and certain groups of sea spiders too, for that matter.
This one, the bottom got all four at once.
Yeah, they were lucky. I think that's the king crabs down there, which king crabs are the most crab-like non-crabs, or the most be crabbed of the crabs that crabbed.
Like the furthest away from them, I kind of.
Yeah, they are uniquely divergent from. And there's true crabs, like look right there. So there's true crabs that don't completely develop too, that express neoteny where their abdomen doesn't fuse. So it's not out of the question. Do crabs tend to move sideways? Yes, Dr. Tapioca Dr. Tapioca Weasel, they do move sideways. The true crabs do. Generally, that's how they want to run. Crabs do have an interesting design. I don't know. Saying the design would be, it implies that that there was intent in what they were doing. It was what worked. So design's kind of a weird way to describe it. But yeah, if you want to use that term hyperbolically, I don't mind. Panspermia, but with crabs. That is my kind of space story. Let's make that thing. I make that a real thing.
So are crabs at near the top or bottom of their food chains? You know.
So crabs are mostly deuterovores or herbivores. So they generally are the bottom to mid rung of the food chain. They generally serve a purpose that's towards the bottom, but there are crabs that transcend that role and become more of a mesocarnivore. Coconut crabs again are a great example of that. In certain regions where having a rigid exoskeleton is beneficial, allows you to dominate like the midnight zone of the ocean, crustaceans become the apex predator. So like the Japanese spider crabs that we were talking about, they are apex predators. They are on top of the food chain in their environment. But in most regions in modern times, crabs serve more of a bottom rung on that food chain or food web, if you will. And it depends on what stage of their development is too, because even the mighty coconut crab has planktonic developmental stages that it's not exactly going to thrive during. And even when it comes onto land, it's still hiding inside of a shell because of predators. So it's still a prey species up until it becomes this massive brute of a creature. You can consider that very similar to the way that tortoises are too. You know, they're very vulnerable when they're small. When they get full grown, they're practically impenetrable. At least to conventional weapons, right? Yeah. Or sea turtles are another example.
So do we know when the crabs came on the scene? Was it in the way in the past, or the dinosaur time, before dinosaurs, or more modern times?
So there's been crabby things in the seas since the Cambrian explosion, right? There's been things that kind of filled this niche or filled this role, or had at least a couple of these characteristics that we're calling carcinization here. We've always had those as long as we've had hard-bodied organisms. These guys have been around. There was a period, though, during the Cretaceous that was like they call it the Cretaceous crab revolution. Yeah, it refers to here it is, the diversification event of Brachyurna, also known as true crabs, that took place during the Cretaceous period. So nearly 80% of all modern groups of crabs just appeared during this crab revolution of the Cretaceous period. All these groups were just boom on the scene. So it's sort of a Cretaceous crab explosion when, but there was no butter because there was no mammals that were producing enough milk for there to be a dairy industry at this time. So we had crabs with no butter for at least 65 million years.
Yeah, it wasn't until after the Cretaceous that mammals started kind of like the milk decided to make an explosion.
Yeah, a delicious explosion of crab because I love eating crab. Love me some crab legs.
I don't think I ever had true crab. I think I had the fake kind.
Like synthetic crab meat. I don't know. It doesn't really compare though.
Unless
crab.
there's real crab and crab cakes. I doubt it though.
There should be.
Okay.
They should chop up real crab in there for you. It's a dick move if they don't. Like, why would they do that to you? You know. So my favorite crab, because you didn't ask, kind of hurt my feelings.
I thought you were just gonna tell me.
It's the Christmas crabs. The ones that migrate. I had those on this morning too. There'll be hundreds of thousands of them migrate across these islands. And it's so cool to see it because it's just like a big red wave moving across the land, and they block the traffic and everything for them. Let them do their spawning.
Yeah,
but
I think I might be wrong on this. But are they the ones that are what's it called? Invasive species, or is that another crab?
Invasive. Well, there are crabs that are invasive species, but those ones are not. No. And crabs are more likely to be victims of invasive species than invasive species themselves, because, like coconut crabs, for instance, again, I keep going back to this particular group, but they the way they spawn allows them to reproduce and colonize islands like to the far reaches of the ocean, right? So anywhere they can go, they're already there. Some use imitation and others use a blend in crab cakes. I like authentic crab cakes though. Like if you go to like Joe's Crab Shack or something, you're getting real crab cakes. If you go to Red Lobster, they're going to be real crab cakes. Yeah, I do. There's been a terrible drop in the number of crabs. Hold on, I wanted to mention that too while we were talking about this. Just a second. Crabs disappearing in Alaska. Yeah, let's look at this real quick. We'll wrap up with this. That sounds like a good topic. Okay. Have a little bit of conservation at the end. Are you okay with that?
Sure. Save nature is something I used to do back in the day. I should do it more often. So
this is fairly recent. This is November 2022. So it's like 3-4 months ago. 90% drop in the crab population led officials in Alaska to cancel the official fishing season for both king crabs and snow crabs. The snow crab and king crab seasons are canceled this year in Alaska, officials say. An annual population survey is well below the safety threshold and up to 1 billion crabs short. This area has suffered climate change effects for decades with recent escalations. In October, news broke that scientists were estimating the disappearance of up to 1 billion wild crabs from the usual steady supply in the Bering Sea. This represents a 90% drop in crab populations, they say, as the news spread. As the news spread, officials in Alaska canceled the official fishing season for both king crabs and snow crabs. Science explains the world around. We'll help you make sense of it all. What is this? Join the Pop Mac. Okay, I don't know what that is. If the population of crabs isn't sufficient each year, fishing boats will end up scraping too deeply into the entire group, reducing its viability in subsequent years. Instead of a sustainable fishing process, it turns into the giving tree, the story of the tree that gave up its whole body to satisfy the needs of one human. The Bering Sea economics, Alaska's economy is inseparable from the environmental health of its ecosystem. Because of that, officials in the state must keep their fingers on the pulse of the mathematical model and population survey that shows the overall health of populations like red king crabs. Experts say Experts say their surveys must have 8.4 million mature female crabs in order to approve the fishing season. Ben Daly, a researcher with the Alaska Department of Fish and Game, told Oregon Live that the mathematical model itself may need to be adjusted after the dramatic decline in population a few years ago. These closures are linked with Alaska in terms of governance, but they affect an economy that rolls down the entire western seaboard. Ships come from the continental United States for just this time of year and plan to make the bulk of their annual income in the waters off of Alaska. And that's not even counting what may happen from the Russian side or even the nearby Japan or Canada. The Bering Sea occupies a space between Alaska and easternmost Russia. It formed by a circumference of the Alaskan mainland, the Aleutian Islands, the Commander Islands, the Kamchatka Peninsula of Russia, and mainland Russia. The Bering Strait, it forms roughly enclosed area of an ovular that is ovular in shape, and because of its positioning, the very center of the international waters between these two iconic and confrontational world powers. But it's not just an interesting for its political reasons. Yeah, I didn't realize it was going to go all into that. Sorry.
Yeah. It's very, very detailed.
Yeah. The Bering Sea is a huge area for commercial fishing because its special ecosystem creates an unusual geology and biology. The sea is technically just a portion of the Pacific Ocean, but it sits mostly in a shared continental shelf between the land masses of Alaska and East Russia, where the shelf drops down into deeper basins. The clashing of the water masses creates just the right mix to produce tons of living things that need an active swirling supply of oxygen and other nutrients. It's an octone, a place where two biomes meet and mix. Arguably, the most important of these organisms is the tiniest and most basic, the phytoplankton. These microorganisms play a crucial role because they turn simple energy from the sun into more complex compounds than other living things need.
Yeah. So basically, are they overeat? So are they either overfishing them or overfishing the big crabs and the little baby crabs?
Well, climate change is part of the problem too. That there's this biome is kind of vanishing, and that this planktonic biome, what it serves in the food chain, is no longer there because of the climate change. And that's what it's going to get to here about the population drops.
Oh, the crabs are boiling, basically boiling in the water.
Yeah, so you see that because the warmth doesn't allow for the reproduction of the plankton, and it kind of rolls down to the crab population. Yeah.
Yeah, when plants die, everything else above kind of has to die too.
Right. So yeah, that's something that we're still dealing with today. I don't know what the next season is going to look like. Who knows what could become of these different species, the king crab, the snow crabs.
I guess pretty soon it'll all be imitation crab. and all the stuff. Just
So
there won't be any crab to eat.
right. So are you ready to become crab? I think it's time.
Yeah, sure. So how would us on the mammal primate side go in the carcination?
Well, so that'll take us back to, let's look at that chart again. We had that little chart that showed us. Yeah, here we go. I'll pull that back up. And we'll just Oh, that's not the chart I was looking for. Just a second here. Maybe you had it up. The one with all the different groups and stem. Yeah, that was you that had that. What am I looking for? Yeah. So let's look at the features for carcinization again, the ones they had pointed out with the dots, the pink and purple and green and blue dots. There we go. Yeah, that's the one. That's the ticket. Okay, so as far as humans go, which features do we have? Scroll down to just we just need to look at the key really to decide what we need to do. So flattened and widened. I think humans are getting wider. I don't know about flatter though. We generally tend to be taller these days than we were. So half of that, maybe half a point. So we're half a pink point. Sternites fused into widened plates. We don't even have sternites, so we can't do that yet. We need to grow.
Would that be an internal thing then?
It's actually external.
Skeletons on the inside.
Yeah, it's actually external. It's it's where it's where the thorax and the cephalothorax fuse together. That's what it's talking about here. But we don't have either of those. So, well, technically, it'd be like we'd have to lose your neck. Is basically what it's saying there. So, to be analogous with carcinization, we'd have to lose our necks. That's true. Your face would have to come erupt directly from your from between your shoulders. So, that's something we'd have to do. And then pleon flattened and bent. We don't have a pleon either. We also don't have the other tetrapods would have a tail that kind of can conform to this instruction, but we do not. So we can't
already lost our
tail up underneath. Yeah. We can't fuse our tail up underneath our body. Lost of uropods. Yeah. We don't have uropods either. We actually don't have enough limbs to afford to lose any in our carcinization process. It would actually be better for us to gain some limbs.
Yeah. We get to be tetrapods, only 4, not 6 or 8 or 10 like these guys.
Yeah.
We only had
no decapods, no.
Only.
I wonder why we don't call arachnids octopods. Probably because of octopuses, huh?
Yeah.
So that's what it would take for us to become a crab. Mm-hmm. So I still have my neck. I like my neck. I think it's a good neck. I'm not planning on losing it anytime soon.
So any last minute questions in chat?
Regios? Questions? Sage
Ohio, Dr. Tapioki, Eddie.
Do we really want questions from Dr. Tapioca Weasel though? I want you to think about what you're asking before you say it out loud.
We're waiting. Anything coming up on your channel you want to advertise?
So we're doing. I'm got the scripting for part 2 of Aaron Ra's Arachnomorpha done. I'm fact checking and editing for him. So that'll be coming out soon on his channel. I should actually get a shout out this time. I told him, I said, you want me to do this? You better give me a shout out. I'm trying to get my channel over 1K. We are super close to 1K. So if anybody's watching this, that's my goal. We'll be back live from the Hive this Saturday or this next Saturday, just like I was today. Monday is going to be Creation Watch. Monday is going to be some Hive Science. Wednesday, Creation Watch, and Friday is Cryptic Corner, which I think is the audience favorite show. So Cryptic Corner on Friday nights at 8 p.m. Don't miss that. And I may or may not become Crab. So yeah.
Nice. For me, next week on the, I am mirroring. I'm going to mirror Dapper's interview of me at Leaving Creationism on the exact 2-year anniversary. I can't move that perfectly. He interviewed me on February 18th last year,
Who did?
2 years ago, and it happened on the 2-year anniversary. So I'm gonna mirror it. So it's gonna be a rerun. But
Who was the interview with?
Dapper.
Oh, Dapper. Okay. Yeah, that's cool. It's awesome. I love Dapper. I was watching Dapper earlier today, talking about what Catholic
Apparently,
creation
you're
or
only
whatever.
55 viewers away from your 1K goal.
Yeah,
I think that's what you
only
said.
55 away.
All right, so even Travis hasn't described the Hive site yet. You click the name in the
Yeah,
title
please.
and go there.
I need all the subs. Give me all of them.
And same here.
Sub sandwich.
Same here. If you haven't click subscribe to my channel.
Yeah, absolutely. Don't forget to subscribe to Vandalia. All my accounts are subscribed. So
Yeah, and also if you haven't seen it yet, go back to season 10 and watch me and Bree talk about what made us cry in media. It's a very, very sad episode.
I'll give a spoiler. Iron Giant made my list. And if you don't understand why, then you just don't get it. You don't get it. All right. Well, yeah, I'm gonna go have some dinner. Yeah.
You have a catchphrase you want to say?
Yeah. Oh, for sure. Yeah. Please remember to be kind and take care, and we'll see you next time.
As I always say, never stop learning and enjoy the randomness. We'll see you next week. Bye. Welcome to Talking Time with Caffeine, the only podcast where we take a subject and just talk about it for however long we have to talk about it. I can take a hello to our kind of sponsor, Junebug Films. Yep, got a sponsor now, kind of. But,
woo!
Yay!
You got a sponsor. That's awesome. I see him in your side chat too. Thank you for sponsoring our stream, Junebug Films.
Jesus, this restream has changed a lot since last a week ago. But anyways, in case you don't know who you guys are, introduce yourselves.
I'm Bree. Oh, go ahead.
Oh, I just want to ask whether you want to go first, but you go first.
Yeah, sure. I'm Bree, Bumble Bree. I have a YouTube channel called Hive Science, mostly based around skepticism and debunking bad science. So if you're interested in that sort of stuff, come on over. We do cryptozoology and alien encounters. We do young Earth creationism and and then we do some real science too. So today we were talking about the St. Bathans Formation in New Zealand, a wonderful fossil formation. So if you're interested, go check that out from this morning, live from the Hive. And we are there every Saturday morning, so certainly feel free to drop in and say hello. I'm so happy to be here to talk about the evolution of hymenopterans and insects. And yeah, let's do it.
And I am Neslik, where you can call me Nes for short. And I mostly work with Jackson Wheat for his videos, and sometimes I'm also appear here as a guest as well. And today again. But this time we're going to talk about like last time I was talking about gymnosperms, but this time with a new topic.
Yep. Always ahead of the curve, kind of. But anyways, I got this idea. I think either from one of Bree's Life from the Hive shows, or it could have been just some random time you decided to just post a live video, not on Saturday. But you were talking about the war of the native bees versus the invasive bees here in America.
Yeah. I was talking about that. Yeah, the honeybee is not native to North America. It's not a benefit to the natural ecology either. They're essentially free ranged livestock that have gone feral and mostly supplanted the indigenous population. There's a few bee species hanging on, but native bees, which are largely stingless, and some of them are so tiny that like little flies. There's a wide variety of them, which we will probably get into in just a bit here. But yeah, they are struggling, and now you see all these Save the Bees campaigns with honeybees as the image of the Save the Bees campaign. And that's really counterproductive, since honeybees are more of the problem than the victim of the insect decline.
Eat the native bees to make something that we want to eat ourselves.
No, native bees, some of them do make honey, but not anything that would be commercially viable for us to make an industry on it, for it to have any agricultural significance. That native bee honey, it would be like a exotic commodity.
Like, are also the honeybees that we use, are they also largely domesticated, or are there like wild counterparts to the European honeybee that are more or less the same, or are there significant differences between the wild and the ones we use for production?
Mostly just behaviorally, like in the way that they act towards humans. They've been conditioned to. The domestic ones have been conditioned through generations to tolerate us. Honeybees were actually domesticated fairly early on. You're talking Old Kingdom Egypt. We have talk of bee domestication and a honey industry at that time. So,
did they originate in the Middle East or in Europe?
So the honeybees that were originally domesticated in Egypt are not the same species that we have domesticated now.
All right.
So they started domesticating them in Egypt, but apiaries that are found in like you said, the Middle East, the Near East, Southern Europe into the Mediterranean area is where we really start to see the European honeybees being domesticated. The monks played a huge, just like they did with domestication of the goldfish, and domestication of the rabbits for that matter, played a huge role in what species that we see, in the agricultural industry today.
But it was the same species that the Egyptians domesticated, or was it a slightly different species that the Egyptians domesticated?
It was a different species of honey. But
and we'll get to eventually. But the funny thing about invasive bees, we did it twice. First, we brought over the European bees, and then we're like, nah, that's not good enough. Let's bring over the African bees too.
Yeah.
And somebody was thinking, perhaps it would be a good idea to hybridize the European honeybee with the African bee, and nope, it was not a good idea at all.
Yeah.
I'm just glad it doesn't get warm enough that much to get them all the way up to Ohio.
The Africanized the killer bees. Yeah, they got killer bees and murder hornets, and they got all these lovely names for them.
Oh yeah, that reminds me. I love when people thought the murder hornets were trying to kill us, but no, they're killing the bees.
Killer bees
Because-
are the same way. That's the thing about killer bees. They try to make it out like they're going to be stinging the people, but the main concern with Africanized honeybees is that they overrun and kill European honeybee colonies and supplant them with their own, and then their own colonies are not able to be harvested because of their aggressive nature.
And we never,
Yeah.
our bees apparently never learned to stop invading hornets by boiling them alive.
Yeah, it's the Japanese subspecies that can do that. The Japanese honeybees.
Then we just gotta get a third invasive species and breed them all together.
Yeah,
African, European, Japanese bees, all one big combination. Really, ruin American even more.
Mhm.
well, I mean, we've brought over bees. Domestic bees were brought to the Americas in like 1620. One of the earliest of
Like with Jane,
livestock.
like with Plymouth.
Yeah, it's like the original 13 colonies. They had apiaries. Apiaries have always been part of European society since medieval time. Collecting and harvesting honey has been the. Ooh, are we ready to get into the slides?
Yeah, well,
So I know I get off topic talking about the cultural impact, but
that's what we do
I say-
here.
yeah,
But-
that's my where I really like to discuss is the cultural impact and the
Mhm.
ecological movements.
We'll probably can do
yeah.
that with each individual slide if you have time. But
Yeah,
first of all, the title. What does Hymenoptera mean? If you know.
Hymen is it's a reference to the reproductive organs. Actually, it's the same root word that is a hymen, like when you talk about virginity, but has I believe that's a Greek origin to that
Yeah.
prefix.
I've
The-
looked. Okay, go ahead. So you finish first. Sorry.
Oh, I was gonna say it does kind of carry the weight of their weaponized genitalia, is what I was gonna say. So that's what a stinger is, in on bees, ants, and wasps. It's weaponized genitals. So
Yeah, that's maybe also a good reason, but I looked up the etymology and it's a bit confusing too. It's not really clear why it's called this. Like there are two parts of this word, hymen obviously, and
Mhm.
terra. Terra is referring to the wing of the
Mhm.
insect. And
hymen wing.
yeah, basically, yeah, and hymen has many different usages in Greek. Like it can mean membrane, as in the membrane that it also, young people. Some people have it. In their genitals, of course, as you mentioned
Mhm.
before. But it can also refer. In this case, it can also refer to the membranous wings of wasps and bees.
Mhm.
But also, there's also another thing that has been claimed. It may refer to the way that the wings of these species are like you have the front wings and the back wings, and these two are connected by hooks in Hymenopterans. So an hymen has often also been used to refer to marriage. So basically, it basically means a joined or married wings. It could also mean that way as well, by referring to how the front and back wings are hooked together.
Oh yeah, I was just my definition was ad hoc. Nessa's
Yeah.
is the correct. I was just ad hocing on there that it works in hindsight to them
Yeah.
having the modify the most of the females and eusocial hymenopterans. Any of them that have stingers are not generally going to be reproductive, because those are modified reproductive organs that have turned into a stinger instead.
Now, is this the clay? Maybe other clays too, but is this the clay that decided we wanted to have a monarchy?
Yeah, these are the these are the eusocial insects. The only other ones I can think of outside of hymenopterans are termites, which are in Blattidae, and they have a different kind of social structure for their hierarchy.
Yeah.
But within hymenopterans,
And termites are also within the cockroach group.
Mhm.
They are actually cockroaches. Yeah. So
nested right there in
eusocial
Blattidae.
cockroaches.
Yeah, but because of their unique ability to digest certain cellulose, that there's ants that can break it down, but none of them can digest it quite like a termite can.
They use fungi for that to help them break down the plants.
Mm-hmm. Yep. Let's see. You want to move on to that next slide? Talk about where we are on the tree of life. So here we are. We got the common ancestor to all arthropods. All right. We got the trilobites with their calcium rich remains that we have such a massive fossil record of, that we use them to measure time in the Paleozoic. And it separates out chelicerates, which are surviving. We have living arachnids and horseshoe crabs, but it gets a lot more complicated than that when you go back into the Paleozoic record. But we're not here to talk about spiders.
That's another story.
If you're interested, though, me and R and Rod did a great series on a 4-part series that was like breaking it down from this point on. So yeah, very similar to what we're doing today.
The Creepy Crawler series.
Yeah, and you get then we get myriapods. This branch going off to the right here is from common ancestor is mandibulata, right? So everything from this on this side has mandibles. It's not labeled here, but that's what that first branch is. And then I believe we'll have it's got myriapods here on the branching off to the left, but there should also be. Oh, I'm not going to worry about that right now. I was going to say the rimipedes branching off before that too, but that's like a very, very niche grouping. And again, we're not here to talk about those. But then you get into pancrustacea. Pancrustacea is what used to be divided into different groups, with insects being outside of crustacea. But now we know, don't we, guys, that insects are just crustaceans. They're just crabs that learn to live on land.
Although the group that includes the crabs and lobsters are still distantly related to the insects. Like there are,
yeah. Well, crab is such a funny word because
I think like you have very how do you call it? Very obscure crustaceans like the triops. Mm-hmm. I think the triops are more closely related to the insects, if I'm not mistaken.
Yeah, I think it's this what he has up here in the crustacean section here that they got it divided off. That's a triop, and they are closely related to insects, but they've been historically classified as crustaceans, mostly because of their anatomical features that they retain, such as like gills and things like that. Not that insects that there are insects that retain some basal features. If you want to pop on to what will be the next slide?
Yeah.
Next slide, we're talking about biomes, but
before we do that, we got two things. So we got a question in chat.
But what is it with bees and sugar? Because they were attracted to my soda. They make their honey out of sweet stuff. There's bees that they've got to make honey out of, like grape soda and stuff like that. There's grape soda honey that they've made. It's kind of funny. Honeypot ants are also an interesting topic to talk about.
I see those. They have the big social stomachs, like fat ones.
Don't bees get into trouble like when they use like purified syrup that doesn't have many protein, for example, they don't get enough of the other nutrients when they only take up like these purified syrup solutions. So they need
Absolutely.
they
And
need
they
a
could run into
variety
that.
of nectar.
Yeah, because they could run into that same problem when they try to get them to pollinate monocultures too. The hive can't thrive off of one type of nectar. Even it needs a variety. It's just like what you need in your diet. They need the same thing. You know, nectar from this flower may be a little bit different than the nectar from that flower.
Yeah,
But yeah,
I have, I once I bought a specific type of honey that was made from brassica pollen, for like in this is completely white.
Oh yeah,
Completely
that's
white.
cool.
Yeah.
And also, we brought this up in our Protostone episode, but I might be wrong here. But I think the trilobites are the only ones that never made it to land. The other ones have made it to land at least.
I think so. Yeah, I don't remember any trilobites that have been found on terrestrial environments.
You know what? I would not ever.
Yeah.
I would not be surprised if we did find some, but I don't.
Yeah,
I
maybe,
can't think of any.
Yeah.
I would, because we found there was terrestrial eurypterids and things like that. So, who knows?
Mhm.
But we're going to go down that insect branch from here.
Zooming in a little bit more, we have.
Now we talk about some biomes here where decapods dominated the ocean, but as we just discussed, insects are actually are descendants from descendants from decapods. So yeah.
Oh, no, the decapods are a separate group. The decapods include the lobsters and the crabs. And then you can see also like one other group is of crustaceans, the brachiopods. That's the one that includes the triops.
Yep, that was the one that was on the same branch as the insect.
Yeah.
And here I believe this is a firebrand it has here for hexapods in the green. It might be it might they may be trying to to present a silverfish, but it's one or the other. This artistic rendering. I'm gonna call it a firebrat. There's firebrat, silverfish. And oh my gosh, now I can't think of it.
Bristle tails.
Springtails.
Springtails.
That's the word. Thank you. Yes. Yes. So when I say decapods, I mean the insects had ancestors with 10 legs before they came on land. Yeah. I did. Yeah, the clade decapod is a reserved for specific groups of crustaceans.
And even the decapods, within the decapods, some have also lost many legs as well. Within that group too, it's just a name that like even in our group, the tetrapods, the four-legged vertebrates, many have lost their feet as well.
Yeah, and then there's isopods, which also are another group of crustaceans that manage to conquer land and the farthest depths of the ocean. I wish there were oceanic hymenopterans, but unfortunately there are not. Hymenopterans have evolved to a completely terrestrial lifestyle. You can tell by the fact that they see so many of them floating in your swimming pool, but they're grouped into so in Hymenoptera there are the ants, bees, and wasps, basically Apocrita. But there's also, before you get to that line, there are the sawflies, which are pretty unique little creatures. They do look a lot like flies. They have generally phytophore larvae, which live inside of leaves, often called leaf miners or leaf borers. You can see their little doodlebug trails on some species of tree leaf. When they mature, they're fairly tiny, about the size of most of them are fairly tiny, about the size of a fly. There's some bigger ones that live in coniferous forests. They've carved out a specialized niche there to thrive in that type of environment. So they get a little bit bigger in those clades, but they're sort of the out group of hymenopterans. All the rest of them have one thing in common, and that's that they're descendant from parasites.
Mhm.
Yeah.
Also, about the question, many bees are reluctant to sting. Do many bees not die or not lose their stinger? Okay, do you know about, or do most bees lose their stinger, or only one type of bee?
You know what's funny to say? Most bees don't sting or don't have stingers. It's only certain groups that retain that sting prowess, if you will. They the bees, when it comes to bees, they generally die because they're eusocial. The warriors are not so much concerned about their own individual life because they are part of a larger, almost like a. I don't want to call it a clonal organism, but it's about the closest that you're going to get, right?
Mm-hmm.
So they don't. So it doesn't matter if they die. Basically, is what it comes down to. And they know it doesn't matter if they die. That they, as in their genetic profile, will go on.
Yep, we are now in the Devonian, but let's zoom in a little bit more.
Mm-hmm. Yep. So we're in Hexapoda. We're looking at 6-legged organisms. Pterygoda, which is gonna encompass our dragonflies and damselflies under Odonata, the Neopterans, which is the pretty much everything else. I mean, the new wings. All their ancestors are descendant from 4-winged flying insects, but Neoptera have a common lineage where, and you're talking about Diptera, Hymenoptera, Hemiptera, everything except for the primitive dragonflies, the mayflies, and of course the like silverfish and things that they're silverfish, fire brats, and springtails are the ones that never had wings. Their ancestors never had wings. They diverged off before that. And then you get into Pterygoda, which is the development of 4 wings. So there's some. Did you have some slides that showed the wing development too? I think.
Oh
yes.
These are slides that go further in. But for now, like for here there are. I highlighted some of the non-insect hexapods, like the springtails, the two-pronged bristletails, and the coneheads. These are like
fish, yeah.
And these are not very. I don't know how common they are, but they are very obscure. Like you wouldn't notice these, unlike the insects, of course. The insects are the biggest subset of the hexapods, of course.
Yeah, it's amazing that when you actually look at this, how many things aren't insects that people think are insects.
Mm-hmm.
Well, everything on here is an insect, I believe.
Oh no! It's like you can see on the base that you see hexapoda.
Oh yeah,
three branches coming off it. And 2 branches going onto the left are not insects, but the 1 branch going to the right is insecta.
Okay, I see what we have here. It's got springtails. Springtails aren't. Maybe I'm using springtails wrong. Maybe I'm thinking of bristle. Maybe I'm thinking of bristletails. Which ones
like if I may interject, like you have 2 groups. This one is the springtails, but you also have jumping springtails, which are insects. It's confusing, I know. It's very confusing.
Yeah. Okay. So.
Yeah. The jumping springtails are insects. Yeah.
And those are the ones that they sell on the like when you're trying to. You can buy cups of those online to.
I
revitalize your vivariums.
I watch this channel on Saturdays before I watch a Breeze channel. It's all about making ant farms and stuff. And they put springtails in their ant things so that they eat the ants' garbage.
Right, yeah, they're cleanup crew like isopods. Bristletails. There's so fire brats live like they're the animal that we found living the deepest in the earth is fire brats. So that's an interesting group of these hexapodal creatures as well. Let me see how deep down was that.
How long ago was the I think the last common ancestor was maybe in the Silurian of hexapods. Like maybe according to molecular dates. I think I think so. Maybe early the Devonian at the latest. The Devonian is when the insects came onto land within that period. Yeah.
Yeah, some people will mix up fire brats and silverfish too, but fire brats tend to be a little bit smaller.
And I see one of these lines are no longer with us.
Oh yeah. There's a very within that. We also get some of it later, but you have this group called the Pterygota. These are the winged insects. And you have like one extinct group of winged insects too.
Yep.
They're no longer with us.
F in the chat for our fallen. Can't pronounce it.
The Pterygota means like you. I think it refers to wings. Yeah.
Terry's the wing. Yeah, same as the Terra.
Yeah, pterosaurs too. Same etymology, I think.
Chiroptera is what they call as bats. Means wing. Yeah. Hand wing is what that means. Yeah.
Yes.
Chiropractors gets the same. Oh my gosh! Now we're going to start talking about all the. I love talking about cladistics.
This could be a whole. This could be a whole mini series if we have time.
But I think we can move on to the next slide. I just include some of the an interesting paper about the developmental genes that are involved in the transition towards 6 legs. Like as you mentioned before, the crustaceans have originally had many legs, but in the evolution of the hexapods, you had a change in the regulatory function of some Hox genes, like UBX and abdominal A in particular. In the hexapods, they repress a gene called distallus in the abdomen, which meant that insects and their hexapod relatives don't develop legs on their abdomen. They only have legs on their thorax. And that's it. Yeah.
Oh, and I do want to mention about, because we have onychophorans on here, and I want to say that the velvet worms, their legs they're not actually legs, like pseudopods. The genes that form them are Hox, or the Hox genes as well. But I would have to go back and look at me and Aaron's video on that. But I say me like I did anything besides research stuff. But the same genes that generate that, or that generate those pseudopods, are found in insects when they're in their larval stage. So it's the embryology of the development of velvet worms and the development of insects in their larval form is very, very interesting to look into, and some of the x-rays of their eggs, even species that don't look like anything like a velvet worm, look a lot like a velvet worm when they're developing.
We can move on to the next slide, I think. Yeah.
Oh, yeah, this is going in the Hawk stuff.
So is this, I do like this slide though. Is this the actual genes?
Yeah, I think although this is a fairly old paper. It's from 2002, but I haven't seen any recent paper that contradicts this story. Perhaps
it's a good visual anyway.
It's always more complex. It's always more complex in reality. But I think this is a very important factor in the developmental evolution too.
Only
Yeah.
one of these clades has snot cannons to trap their prey, though.
Oh yeah, exactly.
All right. Next.
Next slide. All right, we're getting into Insecta. Here we go.
It's a
Got,
very blurry image. Like later, like in the next, I have included a better image about the phylogeny of the insects. So maybe I can. Or do you want to use this slide or the next slide?
I have a
please?
couple of things to say about this slide before we move on.
Sure.
Okay.
Sure.
Yeah, just that earwigs have wings. Really cool wings too. Some of the coolest wings with the most folds in the animal kingdom. That's why they don't look like they have wings, because they fold them up so good. And the only reason I mentioned that here is because I didn't see earwigs on any of the upcoming slides, so I wanted to make sure they got some love, because they are very unique in the insect world, and the fact that they can fly was completely unknown to me until fairly recently.
I think they are called Dermatera. Apparently, like in this slide, Dermatera. It means
Derma
skin wing.
Mm-hmm. So
is there a reason for that? Why they are called skin wings?
I don't want to assume the entomology behind it, so I can't say. But the fact that their wings fold out like the way they do might have something to do with it.
Or maybe do all of them fly, or do have many of them lost flight in earwigs?
As far as I'm aware, all the earwigs are capable of flight.
All right.
I mentioned this. I think I mentioned this in our wing episode, but I'll bring it up again. These guys didn't have to modify one of their forelimbs like the pterosaurs, dinosaurs, and bats did. At least most of them didn't. They got a pair of wings in their backs. We didn't have that. Us vertebrates didn't get that privilege.
Yeah, let's see, we have the Ephormaterans, mayflies, Odonata, which is the dragonflies and damselflies. They all don't have wings that don't fold, is what they have in common. So you got kind of a step down. You got from wingless, never had wings at all, which is your there we see bristletales and Zygentoma and silverfish, and then you have ones that have wings but they don't fold. They either dragonflies and griffinflies, which there aren't any griffinflies left, but they all had wings that not only do they not fold up, but they lay flat no matter what. Whereas with Ephemertera or the mayflies and damselflies, their wings can fold up when they're at rest. Another interesting thing about dragonflies, and just why we're here, is that dragonflies can't really walk. Like their legs, they don't walk. They can just stand. Yeah, like helicopter. All right,
just landing legs. Yeah.
So according to this chart, apparently the butterflies and stuff are our topic's current closest living relatives.
Yeah, well, and you'll see that with the similarities between the very primitive, what we talked about with the sawflies, and the very primitive members called caddisflies. They have a lot of characteristics that it's similar between the two of them and the way that their larvae live. So it's not surprising that with their larvae having similar, with the basal members of the group, with their larvae having similar lifestyles, that they would be closely related. That actually kind of checks out. All right, next slide. I love this slide, by the way. I don't know. Did you pull this one or?
I found this a very good image from. Although it's the one downside, you cannot see the names of each group. That's one downside, but you can see a big overview of how the
I
insects
would love to
are,
have a poster of this.
Mm-hmm.
Yeah. And you can see it, what we were just talking about on here too, with the bees. Try and get a closer look at it. I don't know if it's actually, if my eyes are blurring or if the image is just super blurry.
The image is just very, it's very, like the original image is very large, so I had to to compress it down. To fit it in the slide. So yeah, it's one downside, but you can see there are like three these are all the insects, and insects are in the modern classification, they are defined by having external mouthed parts. And there are two main divisions. One is a paraphyletic group called the A Pterygota, which are the wingless group, and they also don't have metamorphosis. The
Pterygota is in red.
Yeah.
Here.
Yes, it's in your red. They don't have metamorphosis, and they also don't have wings. And the groups that are colored blue and green, they are the Pterygota. They have the winged insects.
And the difference between, and then we get to the difference between the blue and the green is when the ones in the blue are born, they have like a fully functional arthropod body, whereas the ones on the in the green have a soft body larval stage. So that's the difference between these ones, and they go through a pupal metamorphosis. Generally, they go through a pupal stage.
So are all of these lines living lines?
I think so. Yeah, they all continue down, or they all continue up to the modern time. So I think they are all extant.
That's the word.
I stand corrected. I thought I saw griffin flies on there, but I guess I was looking at the mayfly and dragonfly wrong. All right, yeah, this would make an awesome poster for the hive. Just saying.
Also, here I've given like one recent paper about the evo of the evolution of insects. Like the evolution of insect wings has been hotly discussed. Like there were several hypotheses. Like one hypothesis was that they are modified gills, and the gills of insects develop on the upper parts of their legs, if I remember correctly. But an alternative hypothesis was that the wings develop from the margins of the body, basically. But in this paper, they looked at the developmental expression of genes, and they conclude that it's both hypotheses are right. The wings evolved from a merger of these two distinct tissues, from the leg and from the body.
I knew that the Hox was the HOX2 gene, right?
I think so. Yes.
Yeah,
but there are several genes shown here in the expression patterns. I cannot read exactly what these are called. Again, it's a I can zoom in for myself. I see VG, I see NOP and AP. Although I'm not familiar with many of these genes, but you can see the names of the genes in the image.
Yeah.
Yes.
Right. Yeah, I don't know. I don't have too much to add on to this. It's really. You moved on. Sorry, I was still looking at the last slide of my.
Sorry.
Terry. We get to Pterygota, and then you get to Paleoptera and Neoptera. Paleoptera, like we were just talking about, they don't fold their wings up. Their wings are they are also the oldest flying animals on Earth.
Yes.
So
And they are paraphyletic. Like some are more closely related to the Neoptera, and some are more distantly related. Yes.
yeah.
I think you can also see like one, like in the image you can see one of the extinct groups, the Paleodictoptera.
I
Yes.
don't think it's mentioned
Yes.
any of these things, but I think
Okay, and
I
also
don't know. I also don't know if it's unclear or not, but I've seen that some insects only have 3 stages while others have 4.
yes, there's like some of the extinct winged insects had 6 wings, right? Like they also
Yeah.
develop.
No, I meant stages of life. I meant some have pupil, larval, pupil, and adult. Other ones have like this nymph and adult. They skip the pupil stage altogether.
Well, so their nymph stages are generally broken down into what they call instars, which
Mhm.
are
Okay.
just the larger versions of or it starts off with what you might call a neonate version of an adult, maybe with some certain features not as expressed. And as they grow and molt, the body layout stays pretty much the same, though they might develop secondary adult features or secondary sexual characteristics when they reach a certain stage. And some of them, the female goes through more instars than the male would.
But I also think that Vandalia was mentioning that some insects, they don't develop into adults. They remain basically larvae. Like I think there's like one group of beetles that, like the female doesn't develop into the adult form. I think.
Yeah. So the
Yeah.
having the imago stage be that's we think that way because we're vertebrates, and that's how it is with vertebrae, that you spend the most time in your adult form. But for like beetles especially, beetles sometimes spend orders of magnitude longer in their larval form. The majority of their life is as a larva. In the adult form, may not even eat in a lot of insect clades. And it's just a reproductive form and serves no purpose. It's a short-lived. In some species, it's the only time during their development that they actually have wings is during the adult stage where they don't eat and all they can do is reproduce. I know of a longhorn beetle species that can spend up to 40 years in its larval stage before maturing out to an adult that only lives for a matter of months.
Yeah. It's also the case like many there are some moths that when they are adults they don't have any way of consuming food, so they basically are starving to death after they have turned into the adult form, and their only goal in life is to reproduce, and they never eat anymore. They only eat when they are larvae.
Yep. Their larva is the primary stage of their life where they spend most of their time, where they do most of their living. That's why they eat so much. That's why larval stages are always munch, because when they reach an adult stage, many of these clades don't have the ability to eat at all or don't have the ability to eat as much.
Mm-hmm.
Mantises are a clade that have wings as adults, but don't generally have wings as the smaller forms. But other than that, their infant forms, their neonate forms look essentially like the adults, just going through slight variations as they grow. Variation over time.
Yeah. About the question that's now shown here about the many insects only have wings in males. I am familiar with one called the velvet ant, where the females are wingless and only the males have wings.
Yeah.
The velvet ants. And they are and the velvet ants are not actually ants. Actually, so they're called they're called velvet ants, but they are not ants.
The ground wasp. I used to have some in the hive. They have a really, really long stinger. The females are completely flightless. There's some mantises too, where the females don't fly and the males fly. some stick insects as well, where the females don't fly and the males do fly. And some stick insects where the females don't have wings and the males have wings, but they don't fly, but their wings can be for display. So, how's that for some variation across kinds?
Yeah, it's also interesting to note that like okay, can you go back for a few? Thank you. Like most insects have four wings, or at least the original insect, like the dragonflies have 4 wings. But many groups have specialized some sets of wings. Like the beetles have specialized the front set of wings into the elytra. Basically, it's only acts as the cover that protects the hind wings. And in the flies, the hind wings are modified into halteres. And if I'm correct, the halteres in flies are used to like as a gyroscope, basically to detect movement to maintain balance in flight.
Yeah, it's kind of funny how the beetles and the fly both went in kind of opposite directions on that. Although the elytra can also serve as a defensive feature as well, so it has dual purposes. You know, certainly the fangs of a spider have more trouble penetrating in the elytra. Now there's this wild Russian conspiracy that the elytra of beetle wings actually has anti-gravity properties. Did I ever tell you guys about that?
I have never heard about that.
Oh my gosh. Well, a topic for another time. It's hilarious. You'll get a kick out of it. But
let's see. Next, we go to
these are more better images to illustrate the differences between the developmental patterns observed in insects. Yeah, like as I mentioned before, the earliest insects that don't have wings are so-called ametabolous. They don't have any. They don't have metamorphosis. They are distinguished as like after they are hatched from the egg, they are juveniles, and the juveniles are basically just miniature versions of the adults. There's little morphological differences between the adults and the juveniles. But when you move into the winged insects, the pterygotes, you see that the nymphs are wingless, and the adults, like after many nymph stages called the instars, the adults eventually develop the wings in the partial metamorphosis, also called hemimetabolous.
Yeah, that's the instars that we were just discussing. Yes. Yeah, the hemimetabolous. They go through. As it describes there, these insects grow larger in stages, adding new features when they reach maturity. That's like the wings in adult mantises. And then, you have the holometabulous, where each stage of its life is very different and unique, and has specific anatomical features that are not present in the other forms that it takes. This is a perfect example of it. Here is the butterfly going through that. Now, one thing that stands out to me about this, though, is I would have thought that dragonflies would count as holometabulous because their instars are very different. They're also super primitive, so you know what I'm saying? Have you ever seen a dragonfly nymph? They're pretty.
I have seen videos of dragonfly nymphs, and they are horrifying.
yeah, they're retractable, like they have the jaws like the aliens on Alien. Yeah,
they seem more vicious in their nymph stage than they do the adult stage.
Yeah. Well, I will say the adult stage of a dragonfly is the most effective predator on Earth, right?
And they are very, very agile. Yes, and
Yes.
there's also about the jaws of the nymphs. They
Mhm.
like it's also interesting to note that the mouth parts of insects originally evolved from legs, like
Yep.
appendages, and you can clearly see that in the nymph stage of the dragonfly. Like if you look closely at the jaw of the nymph dragonfly, they look like legs, just fused. That's all they look like. Yeah.
Crab mouth parts are like that too. If you look at a crab's
Yes.
mouth parts, they look like just like tiny crab legs.
Yes. Exactly.
We have a question. It says some birds have grown too heavy to fly. I wonder if any insects have done likewise.
A lot of
Oh yeah,
stick
me.
insects did.
Yes.
Yeah.
Although I think it has less to do with being too heavy. I think it's just they just don't. I don't know why they lost. Maybe they just decided to go full
Like,
camouflage and just
not too heavy, but like ants decide. I always have the wings to mate with and get rid of them afterwards.
Mm-hmm.
Yeah. So yeah, I always wonder why an animal would lose the ability to fly, but it takes a lot of energy. It takes a lot of energy when if you don't have to, then don't, right?
Yeah, it's like why use the wings when you can just raise 2 million babies?
That's my goal. Next slide. Here we go.
It's again. I gave an example of a debate about the origins of the metamorphosis in the hollow metabolous insects.
This is not settled at all.
No, exactly. Like there are like two main hypotheses. The one on the left is called the de-embryonization hypothesis, which says that the like in the hemimetabolous, or the insects that undergo partial metamorphosis, they have in before the egg hatches, within the egg, it's called there's something called the pro-nymph stage, and some people think that the pro-nymph stage is like the precursor of the larval stage in hollow metabolous insects. And then the pupa is basically the compressed stage of the nymph stage. You can see like in the it's colored orange, where in the middle you see the nymphs or the nymph instars. It's basically compressed into the pupa, according to this hypothesis. But on the right you have a different hypothesis which says that the pupa is basically a derived late nymph, and that the larvae are just specialized nymph stages. Yes. So from what I have seen, that there is a great support for the former hypothesis, but it's still a hotly discussed topic. The details, yes, for how this change happened.
And there's new studies and new research going into limb development and just Hox genes and how they're expressed in different insect groups at what stages. There's really going to help us understand how, again, like we talked about wing development, but also the structure of their mouth parts is just noted in the limbs themselves and how they've been modified from their multi-legged ancestors to fill different roles in their in the sorry, what?
I was just saying, yes.
Oh, okay.
Yes.
In their environment. All right. Yeah. Let's see. What are we looking at here? Okay.
Also, so somebody mentioned in the live chat that you have also a good example in centipedes, where the front pair of legs have evolved into these the jaws or the fangs,
for sepules.
Yeah. Yes.
Isn't that what we did too? Our gill arches modified into a mouth.
Basically, yeah.
Early.
Yeah. We didn't turn ours into wings though. We sucked that way. Wish we could have cashed in on that. Ooh, I like this one too though. Let's see.
Well, at the time that time we were still at the bottom of the food chain. Well, these guys, insect guys, were at the top of the food chain. Really, we were still at the bottom.
Yeah, we were still fishy swimming in the sea at this time.
With no jaws. While the Euriperids were like eating us for a light snack.
But you can see in this slide, you can see again the complete tree of the insects. But in yellow, those are the ones that have complete metamorphosis, the hollow metabola group, and they have 11
Think
orders.
butterflies.
Yes, they have 11. These include 11 orders, but there are 4 orders that are included most species. Like 1 million species are included in these 4 orders: the Coleoptera, the beetles, the Lepidoptera, the moths and butterflies. And moth is misspelled. All right, sorry about that. And Diptera, the true flies, including mosquitoes, and then of course the group that we are interested in, the Hymenoptera, the sawflies, wasps, bees, and ants.
And
I was gonna say-
we're going to give a shout out to the Hymenoptera. There's a lot of Hymenoptera out there too. So when it comes to the Pterygoda side of things, the Hemimetabolus side of things, the Hymenoptera are on top of the game.
Off topic, I just want to say,
are the Hymenoptera the true bugs?
True bugs,
or?
yeah.
Yes.
Yep.
Off topic, I just want to say,
cicadas.
I just want to say I'm a lousy speller. Every time I try to write insects and search, I get the S and the C backwards, and that's a whole different search engine altogether.
Yeah. I sometimes my fingers move faster than my brain. I think is part of the problem.
Yeah,
I think that's probably what happened with the word moths. There is fingers faster than moving.
But like I said, yeah.
Fast.
Insects with the C and the S switched, or it's a whole different story.
Of course, this image does not do Coleoptera justice either. Coleoptera not only makes up the majority of all insects, Coleoptera makes up the majority of all animals.
Yes, exactly. I would guess that they couldn't do it on scale because it would take up most of the image if they did it by scale. Yeah.
They're just biding their time till we leave the planet so they can take over.
And like the vast majority of them are small, black, and indistinct too. So people send me pictures of a black beetle, say, "Hey, what kind of beetle is this?" It's like, But yeah, beetles could be, if we do a show on beetles like we're doing on Hymenoptera today, we'll need a couple of days to complete it.
Mm-hmm. Yeah, exactly.
That's it. Let's go.
All right.
All right, we've arrived.
An hour into the 1 hour into the thing, we got the backstory done. Now it's time for the main subject. All that prep work.
Yeah.
We're here.
In this slide, I included the at least there is confusing about some confusion about the etymology, but one source claimed that it refers to the as married wings, where each wing or each front wing is locked with the hind wing by a series of hooks. Yeah.
Okay.
And Hymenoptera includes And Hymenoptera includes 150,000 species, and probably way more undescribed ones. Yeah.
And it's important to look at this cladogram that we're displaying here and understand that everything, only that very bottom one, is what people think of when they think of Hymenoptera. The rest of these are all sawflies and wood wasp, which people don't generally think of at all, yet alone think of as Hymenoptera, but they're actually quite a selection. And we did dabble into the sawflies a bit earlier on in in the segment. But sawflies are unique in among hymenopterans that they leave their young to on leaves to live inside of them, and they're folivores basically. Again, we call them leaf miners or leaf borers because of the little tunnels that they leave. No other hymenopterans do that. Most of the hymenopterans that you think of hymenopterans are probably bees, wasps, and ants, and they are all descendant from parasites.
Yeah, it's a very interesting to see that the at the base, like you see that the sawflies are not a monophyletic group. They form the base of the Hymenopteran group, and they use their ovipositors, as you said, they bore into plants. And there's one group, the wood wasps. They use their ovipositor to also bore into plants, but then they deposit their eggs into like insect larvae to as parasitoids. Like
Like
parasitoids,
like
parasitoids.
those longhorn beetles.
Oh yeah, yes. And like you have parasites, but parasitoids is referring to when your parasitic behavior eventually results in the death of your host. Like you make use of your host for some time, but eventually the host still dies. That's why it's called parasitoid instead of parasitism. Yeah.
Yes. And the host it depends on the when the host dies, it's parasitoid.
Either like they use the host as baby chow.
Yeah.
I think.
Yes.
Yeah. Yeah, so the origins of the stinger is as an ovipositor to paralyze prey so that they can lay their eggs on the prey, and the prey's still alive. And when the eggs hatch, they immediately start eating.
In this image, the wood wasps, they don't have stingers, and do they paralyze their prey? I don't think so.
No, the wood wasps don't. I don't believe they don't. I don't think they
No.
need to, because they target mostly beetle larvae living inside of tree bark, underneath tree bark and stuff like that. Yeah,
I don't know. On this chart here, I don't know if it's a monophyletic or a paleophyletic thing, but which of these things stays and takes care of the babies, so the baby takes care of them? Which ones just lay the eggs and head out?
Do they take care of the babies? Some of them do.
I know bees and ants and that little tree there, that they stay around and be a good mom. Other ones are like, okay, I laid the eggs in this dead spider. Bye kids, I'm off.
The use social, like the ones you mentioned are social. They form colonies and they take care of their larvae. Those social species occur later in the bottom, where you see the Apocrita, the wasp waste. Yes, so several of those are eusocial independently. Yeah. And you can see like in this slides, you can see the two main groups are the sawflies, or the paraphyletic sawflies, and in the bottom you see the Apocrita, where you have the appearance of a narrow wasp waist. Like if you see a wasp, the section that divides the thorax
Petiole
from the abdomen, they have like a very narrow waist. Yeah, a very narrow waist.
Narrow little area called a petiole.
Yes.
That Kent Hovind can't figure out how they live with such a tiny waist.
All right. I think we can move on to the next slide.
Next,
We
next
can move-
slide.
We had a question. Oh, what's
I think,
what,
did you mean polyphyletic
yeah,
Oh, yeah,
that's the word. I'm a
Yes.
terrible pronouncer.
or
no
paraphyletic
worries.
maybe?
Yeah, the evolution of social behavior is polyphyletic. It evolved multiple times independently within the Apocrita. Yes.
Like how monkeys are like a thing, or I don't know. I'll toss it again. But let's go on. Talk about that later.
All right.
All right.
This is the Apocrita within Hymen. As you mentioned before, the Apocrita is what most people would imagine wasps to be. Yes.
Mhm.
They are the wasp group. Yeah, the other groups are the sawflies, and they are not considered to be wasps. The other sawflies, but in this group, the Apocrita, you have the wasps, but also bees and ants. And it's also one thing about taxonomy is many terms are not used in a monophyletic sense. And there's another example here. Ants and bees are each monophyletic, but wasps are not. So if we were to be cladistically consistent, we should consider bees and ants as subsets of wasps. Bees are basically vegan wasps, and ants are a type of flightless wasp. Although there are some flightless wasps that are not true ants, like the velvet ant is an example of a group that's often called an ant or an ant, but it's just a different type of flightless wasp.
And most ants have the males are able to fly at least to some extent. You know?
Yeah. Yes. Although like in the ants, like the females also fly sometimes, right? But when they reproduce, yeah.
The queens will be able to fly to do because that helps them spread out, so they're not competing with their own offspring colonies. Yeah. But there are certain groups of ants that will actually, if the groups are close enough related, that they'll actually be able to work together with multiple queens at different ends of their colony and cover more ground. And that's also polyphyletic because that's developing different clades of ants for different reasons at different times.
Yeah. Some of the I also mentioned some of the notable groups within this Apocrita group. You have the Ichneumonidae wasp, which are like most parasitoid wasps are included within the Ichneumonidae.
Ichneumonidia.
Ichneumonidia, sorry. Ichneumonidia.
I was like, it's one of the words that I learned how to say when I first started doing this. That's like I love saying now. But yeah.
And they have also another group called the Proctotrypomorpha, which are some other parasitoid wasps. Like many groups within this Apocrita are parasitoids as well, and some of them have lost the parasitoid behavior, but and many of those are included within the subset called Aculeata of Aculata, which are the stinging wasp. Now we have the true stinger, which is basically a modified ovipositor, as you have mentioned before.
Yep.
Yes.
And vespids are probably the most badass of the true Aculata. They're like that's where your murder hornets are and all that good stuff. Now, spider wasp.
Are hornets? Are hornets in this group? Or are they?
Vespidae. Yeah. See where it says Vespidae?
Yeah.
That's you're gonna find your honey, not honeybees, honey hornets. I had it pulled up here.
If you can look closely at the image shown, like to the groups that are highlighted as bold in bold letters are parasitoid, but the ones in normal letters they have lost the parasitoid behavior. Like Vespidae is one group that has lost the parasitoids, although many are still predatory. They consume, they hunt down insects. With many like hornets are famous, of course. They hunt down, and they don't lay eggs inside the host, but they do hunt other insects. And you have also ants and bees are also good examples of groups of wasps that have lost their parasitoid behavior. Mm-hmm.
I think we can probably go to the next one.
Yes.
All right. Let's see.
One slide
here,
about the ants.
Here we go. We talk about hell ants.
Here we're talking about the. Here we're talking about the group that decide. You know what? I don't need wings. I'm in wood or in a leaf of a plant.
Yeah.
Like,
Oh goodness!
It's
or I'm gonna grow mushrooms, or I'm gonna grow or I'm gonna flowers called aphids.
So
I'm gonna fly me.
these guys innovated agriculture, both husbandry of a different species and farming crops of fungus long before humans entered the scene.
You know, I have learned something about ants watching that other channel. That is, apparently some queens are solo acts, and the other ones are team players.
Yeah, there's a lot of interesting facts about ants. One of my favorite channels is Ants Canada, where he teaches you about.
Yeah, that's what I'm
all
talking about. That's what.
Yeah.
That's why I watch before your show goes live.
Yes. Ants Canada is great. It talks about the ecology of all sorts of different species of ants. So if you're into that, you definitely should check it out, like me and Vandalia do.
Yeah, I it's been a while since he's done it, but like we talked about the bees, he has this little board in his backyard of native ants versus invasive ants.
Yeah, and there's I had a video on the battle between ants and termites. Someone recorded in their backyard. It was pretty awesome. Now
they go to war. Yeah,
I think termites are the insects that are like they're the ones that they're not monogamy. They stay like they get married and stay together forever.
No, the hell ants, as we have on here, are have these really unique jaws where they open horizontally and open and close that, which is unique among insect mandibles in general.
I think you meant vertically. That they vertical mandibles. Yes.
Did I say it backwards? Oh,
yeah.
Yeah, vertical mandibles, not horizontal. Yeah.
And I spelled mandible wrong in the slide. Sorry about that.
I think mandibles sounds just fine.
Mandibles.
That's what we'll call them when they open vertically.
If we ever discover a new species, we can change its name.
Yep. And this species will never get, or the hell ants will never get to see on Ants Canada though, because they don't exist anymore.
Yeah, they are Cretaceous group. Yeah, they went extinct. Yeah, in the Cretaceous. And do we know anything about their colonies, or did they form large groups, or were their colonies very small in size or number?
I believe the understanding is that they were living in like mobile colonies.
Mm-hmm.
similar to driver ants. That was my understanding and reading about them. Anyway, yeah.
And there's also one notable species called, or one genus called Phycomerma. It was a like since we like for a long time we understood that ants have evolved from the wasps. So there was a prediction that at early fossil ants should have had a mosaic of traits between, like they should have traits typical of modern or modern ants, but also some traits that ants have lost but are still present in wasps. And Phycomerma is a very good example of an extinct ant that has the some modern ant traits and also some traits associated with the typical wasps too. A good transitional species.
Mm-hmm.
It looks like these guys were starting to diversify. Dinosaurs or non-avian dinosaurs were on their last legs, and somehow they managed to avoid the asteroid impact like we did.
So, just to clear up something in the chat here, bed bugs are insects. They're actually true bugs in the order Hymenoptera. So, yeah, they are real bugs.
I did not know that.
Yeah.
What about lice, like head lice? Are they also?
Yeah, head lice are true insects or insects too. They are.
Are they also in the Hymenoptera group?
No, they are. What do they fall into here? Order Socodia,
Yeah.
which also includes bark lice, book lice. Yeah.
So what does this?
But they are closely related to the Hymenoptera.
Close, like a sister clade.
Yeah,
So
they
what
are in the same vicinity as the Hymenoptera. Yes.
So what does formicide
Formicidae
mean?
It's a type of acid that they blast out of their head. I'm not sure. It means ant. Formicidia is literally
formic acid. Yeah. I think it's the other way. I think it's the other way around. I think the ants were named first, and then the acid was named formic acid.
Yeah.
I think
ant,
so.
Which means antacid, yeah, and not antacid like Tums, but.
Yeah, I never realized until I started watching the ant kind of thing how vicious ants can be when they're eating. They find something and they grab it and go.
Yeah.
Yeah. Also interesting to note about formic acid is it's also one of the main compounds that forms the citric acid cycle, or at least in close proximity to the citric acid cycle. It's like in the center of our metabolism, with the citric acid and the formic acid and succinate and such. Yeah, it's one of the main components in our organic chemistry. And ants just use it to make their acid sprays. Yeah.
Now, are all three of these colored blocks still alive? Or
which ones?
The yellow, the beige, and the pink.
The bright green box there is extinct, and the light green is like the basal group.
Yes,
so.
The stem ants. Yes, the stem ants are in the green and light bluish or cyanish color. Yeah, and in the bottom you see the orange. I think those are those are all still alive.
Extant. That's the extant groups.
Ants.
Yeah.
Yeah. And some of the bees.
Here we
Yay,
go.
bees.
Bees.
Now these guys, at least some of them, decide. You know what? Instead of eating things, let's go after these new things called angiosperms.
Yeah, let's get let's collect some sweet stuff out of these flowers instead of hunting parasites. And you'll see like other closely related clades to bees are also tend to be pollinators. There's a lot of wasps and ants, for that matter, that also do the pollination function. But bees kind of decided it was a full-time job. So
I go to which species are highly specialized. I think several bees are highly specialized to one species of flowering plant, right? Or
yeah, especially a lot of these ground bees. The flower will be specially positioned and shaped that to only be pollinated by one specific clade of bees. There are some of our cash crops, or some of our historical cash crops, have been pollinated by a single species of bee. I don't remember the name of the one that pollinates pumpkins, but it's the only one that can do it.
Oh, really? And how do we pollinate pumpkins differently now, or?
I'm not sure. I think it's the only bee that can do it. I think there may be other insects that are able to do it.
Now, which of these colored blocks are our own patriotic American ants?
I think they are in the second group, the Apidae, right?
What are patriotic ants?
Yeah, the ones that are native to like.
You meant? I thought you meant the honeybee. Oh, yeah.
Like we're talking about invasive versus native bees. Like which ones are homegrown American?
Apidae is where we find the
honeybee. Yeah.
The European honeybees. But there's more than there's the bees are further divided into like long tongue bees and short tongue bees, and whether they live in groups with this many individuals or that many individuals. Some of them do different functions. There are ones that actually stab their tongue through certain parts of the flower in order to make it produce nectar. A lot of weird behaviors depending on what group evolved where and in what vicinity to what types of flowers. The interlinking between bees and the flowers they pollinate just it's unbreakable. It's scary that we're losing so much diversity on the.
Okay. Wait! You're saying that the animals and the things they grow up with are interchangeable, like a web of life and stuff?
Oh yeah, like a big web of life.
Also, one thing I can also mention is on the left, you can see the image from a reference to a paper called Dynamic Microbiome Evolution in Social Bees. This paper hypothesized that we know that bees evolved from wasps, but it's also thought that the bees, the ancestors to bees, were predatory wasps. They hunted down insects, and the hypothesis is that these insects that they originally ate were covered in pollen, and this pollen also had some of certain kind of microbiome associated with it. So, and that's how bees acquired the gut microbiome that allowed them to eventually transition over to pollen exclusively. So that's how they made the switch from eating insects to eating pollen.
Fantastic.
According to this paper. Yeah.
And of course they just had to be nice and help and help help the flowers have sex. I mean, it was like an instinct. Like for all this nice little stuff will help you have more babies.
Yeah. Thank you for carrying my gametes to my lover.
Do all bees have these thick hind legs for carrying pollen around?
I think that is a characteristic of bees, specifically. I think so.
Mm-hmm.
Until I never knew.
Some of them have very large, thickened hind legs. Yeah.
Mm-hmm.
Yeah, for the longest time, I never knew they actually ate pollen. I thought it was just a byproduct of going to flowers. I didn't know they were after that too. I thought,
well, they go after
after the sweet.
Yeah.
They go after the nectar.
Yeah, I think like all of them eat pollen, and many also grab the nectar. Or do all bees also eat the nectar too?
Well, the nectar is what they use to make food for their babies.
Mm-hmm. Also pollen, right? Like they have honey sacs and also pollen
pouches
chambers
on their back legs. Yeah, like the structure of the back legs are just designed to carry the pollen. Mm-hmm.
Mm-hmm. And you also have bumblebees. Apparently, as said, like you have honeybees and bumblebees. Do like bumblebees don't make honey, right?
No, bumblebees don't make honey.
No, but they do eat the nectar and pollen. But they also make nests from wax, right? The bumblebees, they make waxy shells.
Yeah, underground too is where we'll find bumblebees.
Yeah, I remember when I first saw a bumblebee. I was like that's a fat bee.
Yeah, they are fat and fuzzy, cute.
And do they sting? I think they sting, right? Bumblebees.
Bumblebees can sting, yeah.
Mm-hmm.
Bumblebees.
And they have also some of the you can also see in the image on the left that there are stingless bees.
Well, and when it comes to bumblebees too, it's some bumblebees will do like a cuckoo bird does, and like have somebody else take care of their babies for them. They'll actually lay their.
Oh, really?
Like abandon their kids. Like
actually
child services on them.
They're actually called cuckoo bumblebees. Mm-hmm.
Like, is there a child protective services for insects and stuff? We call for abandonment issues.
Child abandonment. All right. Yeah, there's why I was.
It's a little small here.
A little small, yeah.
It was like I had to zoom in on these things, but
I can see some of the names. You have the Marcianae and Leptinae. The one in blue, and then you have a green group. The green is paraphyletic, but you have also formicoids. The biggest subset of ants. Is there do you know any, like this is not something that I am familiar with, but do you know what the main differences is between the black group and the early diverging ants, like the one in yellow, Brie?
No, unfortunately I do not. I guess I need to watch more Ants Canada. I don't. As far as how ants are divided up, I haven't really studied too much into it, honestly. But yeah, I do recommend Ants Canada. Now, go ahead.
Well, I was gonna say, I thought, and you remember that scene in one of the bad Indiana Jones movies, the fourth one, where that guy got
where they had Sifasu in South America. That was weird.
and they took directed body into their hill.
Yeah.
Oh, now I remember. Yes. Yeah.
And yeah, and they lived. Those ants were so bizarre because they lived like driver ants, but then they also had a mound like fire ants. So they were like, and he called them Safasu, which is an African word. I can't remember which group it's from, but for their word for driver ants.
Maybe they are Africanized ants.
And they South America does have some pretty wicked ants. They've got the bullet ant, which is quite potent. Some people consider it the most painful sting of any member of the insect kingdom. This specialized soup that our Hymenopteran friends have been cooking up since the Triassic is finally ready for injecting into humans, and that's going to make you scream.
The bullet ants are from South America, right?
Mhm.
So,
Mhm.
was this perhaps a defense against the anteaters of South America, like the painful thing?
Yeah, against because there's a lot of insectivorous creatures crawling around the jungles of South America that these guys would be benefiting from with their potent sting. But bullet ants are also they live in the trees, so they're arboreal. And there are ants like the silky anteater that are specialized in targeting arboreal ants. So that would not surprise me in the bet that they had
and I might be remembering this wrong, but you can learn more about the anteaters and others in Arthurans and me and Ness's chat about Xenothrans.
Yeah.
Yes. A lot of we did it last year, I think. The Xenothrans, yes.
All coming back together, all coming together again.
Mm-hmm. Oh yeah, it's all coming together.
Yeah, and they're the ones that not the Xenothrans, but they're the ones that go like the army ants, the ones that go marching along and killing everything in sight.
Oh, yeah.
Yep. Actually,
do they have special? Do they have they probably have special names for different castes of ants? Like you have the ants that carry stuff around, and you have the soldier ants that will.
Yeah, I know that they have super majors, minor majors, regular majors.
Yes. I'm sorry to have to bail on you, but my ride just arrived.
Oh, no worries.
It's been real fun.
It has been 1.5 hours. That's a very good talk already. So
yeah,
we only had 2 slides to go, anyways.
Yeah,
but yeah, we'll wrap it up for you.
All right, sure. Yeah.
If you haven't done it yet, go check out Bree's channel, Hive Science, every Saturday, and check out the reruns on the other days of the week. Because he can do what I can't do. He can break up his show into bite-sized pieces. All right. So what's on this page?
I think that this is just. I think it's another phylogeny of the Hymenoptera. More simplified, I think. Yeah.
And finally.
And I'm not familiar about this slide. It seems to be to highlight a relationship between ant species and a few wasp species. Oh yeah, maybe it's just showing how some parasitoid wasp infects some of the ant species, I think. But I'm not familiar with this picture. Sorry.
Anything you want to say before we wrap it up? Anybody have any questions in chat before Bree's gone? Unfortunately, Bree's gone because we talked forever. But if you have any questions in the chat before we go, now's your chance.
I don't see any other questions. I think. Oh, somebody says I guess bedbugs in a general is a general ambiguous terms. I don't know about. I don't know whether bedbugs. Let's see maybe bedbugs. I think bedbugs specifically refers to one. It does refer to one specific group of insects, but maybe it's not a strictly monophyletic group as possible. I'm not sure about that.
So
Or there also
anything
like the Wikipedia article does say that many other insects like cockroaches are sometimes confused for bedbugs too. Yeah.
So anything coming up on your channel that you want to advertise?
Not on my channel, but I'm always active on Jackson Reed's channel.
Right. But speaking of your channel, if you haven't seen it yet, check out his nuclear power video. He took my episode of that and made it much more bite-sized and manageable.
Mm-hmm.
Thanks,
somebody,
Steve and Eddie.
Yes, so Steve was just saying it relates to the sentence before. Oh, yeah, the sentence before was bedbugs aren't insects; they are eight-legged mites. But I think we already responded to that comment before. Yeah, bedbugs are insects. The ones that bite you. Yeah.
Well, channel coming up next Saturday. Me, Tony Reed, and maybe RJ are going to be talking about how to find these sources. That if you have a creationist or something that you don't know, and you want to track down what they say is right or wrong, we're going to teach you how to find those sources out there in the internet world.
This is a very good topic. Yeah, you can teach other people how to find information for themselves. It's a very good discussion to have.
Yeah, but until then, never stop learning and enjoy the randomness. We'll see you next week. Bye. If you just do it, it'll turn out okay. If you were with us last week, we talked about fictional spiders, starring Andrew Garfield. But today, we are talking about the real deal and their cousins.
Hey, yeah, it's spider time. Let's get this show started. Talking about spiders and scorpions and talking about some solifugids and some ticks and mites, and there's so many arachnids are so much more diverse than people think. But most people think spiders and scorpions, but there's a lot more to them than that. And in the past, there was even more. And if you want to expand this to chelicerates, you get some really weird guys like the sea spiders and the horseshoe crabs and things like that.
But before we get started, because you've been living under a rock, guest, introduce yourself.
Hi, I'm Bree from Hive Sci. I have a science and debunking channel. Mostly we focus on debunking bad science, especially when it comes to animals and biology and phylogeny and ethology and ecology and all those overlapping fields. When that goes awry, I'm here to say, hey, let's pump the brakes there, kitty cat. And I started my channel talking about bugs, definitely extended beyond there, but I still love talking about our little arthropod friends because Protostome holds a special place in my heart. I do have a collection of arachnids myself that I've hand raised, each and every one of them, from a tiny sling to an adult spider. So I know my way around. Anyway. When you asked me to do this, I told you that that I had recently put together a whole bunch of content for a video I was helping another content creator with. So I had all my notes already ready for this, so it was fortuitous that you wanted me to come on and hang out.
Timing. It's always good to have good timing.
Mm-hmm. Yeah, and Ness, I believe, might show up at sometime during the stream. I don't know if they're still if they still plan to. If not, we'll just keep rolling. All right. So, what is an arachnid? That's a good question, huh?
Well, this is what I found out. Apparently, this might be the wrong list, but apparently there are at least 5 characteristics of arachnids.
Yeah, this is a good basics. Sure. Let's see. We got body segmented, usually consisting of a head, thorax, and abdomen. Yes, a lot of arachnids have a fused head and thorax called a cephalothorax. That's what you see in spiders. And opilions, those are harvestmen, the daddy long legs that look like spiders. They actually have a fused head, thorax, and abdomen. So they just look like little buttons. They don't have jointed body segments like their ancestors did. Now, other groups, of course, you have like the scorpion, which has its abdomen elongated into a nice sturdy telson to help it with its feeding process. Let's see next. We got jointed appendages. So this is definitely something so far that I can agree with. It's all characteristics of arthropods. Okay, I'm with them there. And firm but flexible exoskeleton are also a good feature for arthropods in general. An open circulatory system. Yes. Specialized appendage, including claws, crustaceans, or wings. So that's a weird thing to say that about arachnids, because there's no arachnids with wings. There's no.
Yeah, I was wondering why the insects. I thought insects were different clade altogether.
Yeah. So insects and crustaceans, they're the other major clade of arthropods. They're in a group called Mandibulata, so that they're actually it's split in two. And if you want to get technical about insects and crustaceans, insects are crustaceans. They're just hyper land developed crustaceans. But
if you want to go in a deep dive about talk about a certain clade of insects, go check out mine and Bree's episode on whatever the wasp name is.
Hymenoptera.
Yes.
So I was saying it's divided into, there's 2 major groups. There's the Chelicerata, the Mandibulata. That are the 2 major clades of extant arthropods. There used to be a lot more Radiodonta and all kinds of stuff, but right now we mainly have either Chelicerata or Mandibulata. Ness, you're cool. It's okay. People forget stuff. We're cool. Just join if you want to, and if you can. Love you and thank you for offering to pop in and entertain us with your big old brain. Anyway, so crustaceans and insects are Mandibulata. They're not going to be on the menu today, so we're looking at Chelicerata. Now, Chelicerata, you got to narrow that down more too, because we talked about there's sea spiders and the Eurypterids, the giant sea scorpions of the past, and then there's horseshoe crabs, all different clades of Chelicerata that are not arachnids. Arachnids are evolved for terrestrial lifestyle. So there's no primary evolved aquatic arachnids. They're all, if any arachnid has aquatic characteristics like a diving bell spider, there's secondary adaptations to help them make that transition. But arthropods did develop wings in the insect clade, but there's never been a Chelicerate with wings. Now, that doesn't mean they can't fly. Baby spiders can fly. They use a silken line that they navigate with the Earth's magnetic magnetic field. Pretty cool stuff. And they're not just floating around. They're navigating. It's pretty nifty. Welcome, Nas. Good to see you tonight. I guess it's.
You can make it as long as you can make it.
Yeah. All right. Yeah, here we go. We got a breakdown of the cladistics of arthropods. As you see, the first branch off to the left leads to velvet worms. Now, velvet worms are they're very closely related as a sister clade to arthropods. They're also a sister clade. If there was another branch off of here, it would be for water bears or tardigrades. They fit right next to the velvet worms, but when you get into that middle branch right there where it splits in half, that middle split is the split between Chelicerata and Mandibulata. Mandibulata is on the right. You got myriapods listed in there as well, which are centipedes and millipedes. And also, I believe remipedes fall into this group as well, but they're more distantly related to the rest of the mandibulates. Then we get into the clade that we're talking about today. You got Chelicera in the center left here. And as I mentioned already, sea spiders and horseshoe crabs, not arachnids, but that brings us down to this final little branch right in the middle where it says Arachnida with scorpions, spiders, and more. I cannot hear you, Ness, if you're talking.
Nope.
No.
We cannot hear you. So sea spiders aren't true spiders?
No. Sea spiders are just their own thing. They're really weird too. They're like minimum body proportions. They're wild. They're like 95% of their anatomy is legs. Even their lungs are in their legs. They're so unique.
Got the name, but not the clade.
Yeah. Well, and horseshoe crabs are not crabs. They're not even mandibulates, which is where crustaceans are. So they get misnomered too. But we got sea scorpions as well, which aren't scorpions, and they're also chelicerates.
Oh yeah, they're starts with an E, I think.
Eurypterids.
Yes.
Yes. I think we had a slide of Eurypterids if people want to see what they look like. Did you have that one or not? I'm not sure which ones you were able to utilize. I know there's a lot there, and some of it's more technical than you wanted to go because we're doing a broad overview. Not with Aaron, it was like a 4-hour thing, so there was a lot to go over. We're not going to go 4 hours.
No. This is the first part of your notes I copied over.
Okay. Here we go. So we talk about arthropoda. That's the source where arthropods come from. The Cambrian, the third stage, average temperature is about 70 degrees Fahrenheit. That's 21 degrees Celsius. I wouldn't use this slide though because this is just giving instructions about how to address the topic.
Okay.
Yeah,
Right.
I was providing this to you for these pages to you for the images, not necessarily all the notes.
Okay, then
yeah.
Hold on, then let me get that.
That's cool. Yeah, the Burgess Shale's full of lots of early arthropods.
Here's your first picture.
Okay. So again, we see the divide between insects and chelicerates here, giving us a broader spectrum of what falls under this spider clade here, but because they always started off with spiders when we're talking about arachnids, right? It's always spiders, then scorpions, then mites. Even though spiders are relatively newcomers on the scene when it comes to arachnids, whereas scorpions have been around since they were still living under the sea. Yeah, but they've been replaced in their niche under the sea by crustaceans. So that's why we don't really have any sea scorpions left today. Any aquatic or marine scorpions, because scorpions used to be actual actual arachnids that lived semi-aquatic lifestyles, true scorpions, like Pulmonoscorpion Carcinisation is the first scorpion that we're sure lived on dry land. Everything before that was either aquatic
Am
or
I
semi-aquatic.
audible now?
Yeah, we can hear you now. Woo!
Finally. Woo. All right.
Yeah, and
So
this one
my
done.
apologies for coming late. Sorry about that.
You're all right. I'm glad you're able to make it. And this one has anomalocarids on here too. It doesn't have so we're talking like radiodontia being off that branch as well. So yep.
Yeah, the
All right.
radiodons were the
Next-
first predator, like apex predators of the Cambrian.
Yep, early conquering arthropods. Really, that was the clade that put arthropods on top. Right before then, it was just little tiny things. Hard-bodied organisms were pretty basic trilobite-like. Everything was from what's the one I'm thinking of? It's like a trilobite, but it's feathery. Eek. Morelia. Yeah, Morelia. That's what I'm thinking of. Yes. So everything had that simple body form. I think trilobites are sea arthropods, if I remember correctly. That is true. They are another clade of arthropods that was dominant back during the Paleozoic era.
And sadly, they get past the Permian.
Few things did, though. So, I mean, we did. Go us, right, guys? Woo!
Yep. We made it past all. We've made it past all the big five.
Yeah,
I think it's also a debate. There's also a debate whether trilobites are closer to the chelicerates or the mandibulates.
Yeah, I know. I love that topic too.
Yeah.
That would be. I'm more in camp mandibulata, and I'll tell you why some other time because this is about chelicerata. But
yeah,
I think that trilobites.
You gotta pay for that episode.
Are the Eurypterids closer to the horseshoe crabs or closer to the arachnids? Do you know that?
Not right off the top of my head. I don't know. I wouldn't want to make that assertion. There's a lot when it comes to internal clades within Chelicerata and how they're related to each other. It's so disputed, and when things evolved, and what counts as a spider, and what counts as a scorpion, what counts as an arachnid, even is so hotly disputed that it's hard to pin it down. Anyway, what's our next slide here?
At least according to Wikipedia, Eurypterids appears to be the sister clade to arachnids, so they are more closely, at least according to what Wikipedia shows. But still, yeah,
that's the current findings. Then, yeah, I'll go with that until something proves otherwise. I'll accept that. Yep. All right. Let's see. So now we're talking about just the different appendages that these creatures have. So chelicerates, they emerged from arthropods in the Middle Cambrian about 500 million years ago, and like all the other arthropods, it was in the warm, shallow seas that they were really able to thrive. Right, some of them actually started leaving the seas really early on, about the same time, like in the early stages of the Paleozoic. Now, apart from their distinct chelicera, they also came to be distinguished by their unique brain structures because they lack a frontal portion of their ganglia that converged to form the brain in other arthropods and in our ancestors too. They never really did that with their evolution never really took them down that route, so they never developed what a brain really is. It's more, they have more of a system of extended ganglia, and it's segmented down their body. You see how these images have it segmented here. These traits, they go hand in hand with like development in other arthropods of like antenna and stuff. That's why you don't see arachnids with antenna, because they don't have that sensory part of the brain that was used to make antenna useful. Like we see in like insects, isopods, centipedes, so all the mandibulates that just never rose in chelicerates. We'll see a myriad of ways the chelicerates compensate for the lack of this sensory part of the brain. And I think one of the main ones that everybody can remember and kind of relate to is the whip scorpions that have the long front legs that are just basically turned into antenna that feel around in the dark. So that's a tactile alternative to having a chemosensitive antenna like a centipede or an isopod or an insect has. Now, there are some genes that we could talk about here when we're looking at this image right here, because this is going to be relevant. Oh, go ahead. I'm sorry.
Sorry. The first picture up there, is that all these pictures? Is that like the apex predator of the Cambrian?
So these images aren't specifically any species. It's showing the development of how these Hox genes. See the feathery appendages on some of these images?
Yeah,
those are lungs, or they're breathing apparatuses. So the Hox genes in these organisms developed to help them breathe through these. Each segment of their body has intake for its own oxygen, which gave them a advantage over other organisms that were competing in their environment, because they were able to maintain a more active lifestyle. Because they could, as they moved through water, they could siphon the oxygen from it, unlike like trilobites and stuff.
Just the arms remind me of that.
Mm-hmm.
I can't remember its name now.
So we're looking at when it comes to the gene development here, we're looking at do you all want to know names of genes and stuff, or you just want to
sure.
I mean, we're looking at SP6 through 9 and D2. Those are the embryonic genes to develop legs.
And you might want to know that. You might want to know more. You can go. You can look that name up now.
Mm-hmm. And the genes that were used to develop legs. Remember how we talked a minute ago about how they didn't have that ganglia in the front of their brain? So what they've done is they've used those genes for legs and put those in the front instead, where every other animal has mouth parts and maybe antenna. They have leg genes, which create things called pedipalps, right? That are pseudo legs. They're not really legs, but they're kind of like legs. And their chelicera also pulls in these genes to develop the chelicera, which are also like the leg genes, but in spiders they're fangs, and in different groups they have different functions. But really interesting. Go ahead.
Like in basal groups, they are more like claws, but they pinch.
Mm-hmm. Mm-hmm. Yep, because scorpions are the most basal. Yeah, they were claws. They were claws first, right, on all of them.
Yes.
Yep. Those genes have kind of pulled back to be replaced with these Hox genes for leg development. Now, some early arthropods had crazy leg development. We talked about radiodontids earlier. They had Hox genes that just went nuts. So they had like 14 pairs of legs and things like that. But with arachnids, it was whittled down to 8. But then they decided, again with this, and I say decided in a colloquial sense, but it was they developed these facial legs to supplement not having this front part of the brain that all the rest of the arthropods had. I always thought that was interesting. There's their distal leg genes is what they call them. But, now let's move on to the. Go ahead.
If I try and flip this up fast, in your personal list, what got you interested in arachnids?
So I always was like collecting and playing with spiders when I was a kid. I've always had spiders as pets. I was really into animals in general, and I wanted to have my own zoo, but that's not viable or good for the animals. But spiders and arthropods really they don't care as long as they can thrive in an environment that mimics their wild outdoor counterpart. They don't care about being in captivity. So I have my own little zoo of spiders and insects and arthropods. So yeah, that's what I did. I made my own little zoo. Huh? All right. All right, we'll be looking here. Okay, so now we're on some fossils. So here we're looking at some more of the early arthropods as they or chelicerates as they were developing early in the aquatic and marine environments. This is the era when they started to move on to land. Unfortunately, I don't have my notes on this particular slide, so I apologize for that. I don't know which species we're looking at here. I did have.
Let me check.
Go ahead.
Well, hon, I'm still copying the pictures over, but 1 second.
Yeah, sorry, I wasn't clear about this just being because this was literally just like notes on how to address the topics and stuff. So,
well, there's your document you had. I put in private chat. You check it out.
Yeah, well, I got it open here on my other screen. I already got it pulled up, so I got the notes, but it doesn't have the some reason when I copied this over, I didn't get the subtext for this particular image. I don't know why I forgot to add it, but I don't want to misspeak about what we're looking at here and what species these are. But I do know that these are a series of early chelicerates known from the fossil record throughout the Paleozoic era, that when hard-bodied organisms started to get a lot bigger and leave more robust fossils later in the period.
So what is the oldest? You know what the oldest fossil of arachnids are?
Well, as far as what is an arachnid is what we're going to get into there. It's really it comes down to where you want to draw that line, because there really is a robust transitional lineage that we can watch go from generic Chelicera or Chelicerata to specifically arachnids. Every stage along the way is accounted for. Now, let me see here. We're getting into too far ahead of myself.
I think there are also many groups too that have a very poor fossil record, like we don't have a lot of ticks, I would assume, right?
Yeah, because they've always been small. We do have ticks from like dinosaurs and things like that, though, which is really cool. Like a tick that was on a dinosaur feather. I actually did a response to somebody saying, "Oh yeah, we don't know for sure that it was a dinosaur tick." I'm like, it was found on the dinosaur feather. What are you fucking talking about? Sorry, language. I don't want to get your channel demonetized.
That we're not monetized to begin with, so feel free to cuss away.
Oh, I thought you were monetized. You have. Me and you have about the same amount of subscribers.
Yeah, it's half subscribers, but half view out. You also need the view hours to counteract that.
Oh. Okay, I get you. Where are my notes on ancestor of all arachnids? Here we go. It is estimated that 98,000 arachnid species have been. Okay, that's the OG arachnid body plans. The scorpion. The oldest scorpion is Dolichophallus. It is 436 to 428 million years old is how old the fossils are. So that answers your questions as far as being a true arachnid. Somewhere, go ahead.
So I said, all right.
Yeah. And then There are some genes that let's see, I already talked about that. About the leg genes.
1 second. I need to reset this slide real fast.
Mm-hmm.
So give me a second.
Yeah. Well,
What's the oldest scorpion and oldest spider that we have in the fossil record? Do you know that?
the and that's another kind of questionable pedigree there. What makes it? What really makes a spider? Because we have things that are for all other purposes. Everything about them is a spider, but they don't have the silk spinning genes. Now there are other schools of thought that would put like tarantulas, like my gallimorphic spiders, outside of spiders, so make them not true spiders. But we have things that are sort of a halfway point when it comes to spiders specifically. We have things like Chimera arachne, where it has a telson still, but it's definitely more spider-like, and in that spider lineage.
It did, like Chimera arachne did produce silk, according to the fossil, but it has a very like ancestral traits for arachnids. Like arachnids started out, as you said, they originally had a telson, like a long quote unquote tail on the back end. It's not a true tail, but you, like layman would say, oh yeah, that's a tail on the back of the animal.
It's made up of metasoma. Yeah.
Yes.
Which is what you see here is also the same condition in these early chelicerads that were maybe arachnid. These are the guys. These are the guys that are like, hey, are these arachnids or not? You can see that they're very horseshoe crab-like. They kind of toe that line. It's funny because people expect early arachnids to look more like Eurypterids, but they came in all shapes and sizes.
They also look very much like trilobites as well.
And then someone one of the creationists. That's one of the creationists saying that horseshoe crabs are really trilobites, lasted forever, and they're still alive. See.
Well, they'll look at like isopods and make that claim. They'll be like, "Look, isopods are trilobites. They're the same thing." It's like, no, not quite. But these guys definitely give rise to the Chelicera line, right? We're looking at the Ordovician. These are the early pioneers, some of the first organisms that are thought to have moved onto land even, and using early marshes for spawning and things like that. So pretty interesting ecology that they find these critters in, with lots of semi-marine stuff and semi-terrestrial stuff. So I really am watching.
These are glass pits, right? So are they their own group, or are they like a paraphyletic group?
They're primitive chelicerates is the best way to describe them.
All right.
They
all living chelicerates are more closely related to each other than they are to these glass pits.
Yes. Yeah. Even like between horseshoe crabs and arachnids, they're close related to each other than these guys. Even though there's the similar look, and you expect the original body plan to be something more like a Eurypterid, but it's really more like a trilobite.
So are these guys more Earth closely related to each other than we are to tuna fish.
What?
I think Vandal is asking, like, are we more closely related to tuna than the spiders are to the glass pits? I think it's almost the same, maybe. I don't know exactly when they diverged.
So
There are some. It says right here. There are some Cambrian types.
yeah,
So they diverged earlier. So I think we are closer to tuna than spiders are to these guys. I think.
That's
yeah, I think all
something.
tetrapods would be closer related to each other than these guys would be to any modern chelicerid.
Yeah.
But
that shows the diversity these guys have then.
Mm-hmm.
These are the types of organisms, though, that they will throw up on the screen and say, "Look, here's a horseshoe crab that hasn't changed." And they'll show you these, and it's like, these are not horseshoe crabs; they're not the same. But not to say horseshoe crabs aren't ancient; they are. But even the horseshoe crabs that are ancient aren't unchanged, right? There's adaptations that they have, but they're just really good at their niche. They're really well fit for their niche. That's all that matters. You can hold on to it for hundreds of millions of years if you're really good at it.
This is my territory.
Shark.
This is my territory, and you can't have it.
Mm-hmm.
Get off my lawn.
Also, it's like, as this image shows, that the Cambrian glass pits have eyes, but in the Ordovician they lost eyes. Like, were the later ones like deep sea dwelling, and they lose their eyes? Perhaps, I don't know.
You know, that's an interesting speculation, and you wonder if maybe they lost their niche in the more shallow waters to something else, to Eurypterids and more derived. I think there are radiodonts still around at this time, right?
Well, very few. There's like one famous filter feeding radiodont that survived in the Ordovician. Like, that's one of the latest survivors. I think most of the predatory went extinct in the Cambrian, I believe. Yeah.
Yeah, I think I know the one you're talking about. The Cories, Mecha Cories or something like that. Is football sized, but pretty big for the time that it lived in. No. All right. So this is just giving us our basic body plan of an arthropod, of a chelicera, and what sections of the organism that we are looking at, including the telson that we were talking about earlier. This one's not divided into metasoma, though. Metasoma is when the telson segments itself into different, they'll just be numbered: metasoma 1, metasoma 2. This one's just got the 1. But some of these body segments in early chelicera there was like a whole lot of segments, like what you see in more basal arthropods in general, right? But as they derived into different niches, they started to fuse these body segments together. What's interesting about that is those leg genes that we were discussing earlier. They would fuse and double up the genes like that too. So one leg is a clone of the leg on the opposite side, like exact clone. And if it loses that leg, it doesn't replace that leg with genes from the leg that was lost because it's gone. It replaces it with genes from the other leg. So they can actually manipulate. PZ was talking about this too. They can actually manipulate the genes in one of the legs to make it develop weird. I thought that was cool anyway. Like, make it fork at different joints and things like that.
So
I have a question about the telson. Like in scorpions, is the entire length of the like the stinger the telson, or is it more than the telson? Is the telson in the scorpions just the tip of the stinger?
So the tip of the stinger is what they call the telson in the anatomy of a scorpion, but the whole metasoma, all the metasomal segments are formed from the same genes as the telson.
So it's a lot of the the tail, quote unquote, of the scorpion is also the telson, basically.
Yeah. Every
Yeah.
every segment, they're called metastoma or metasomal segments, and then they're numbered.
Yeah.
Scorpions have 5, I think. It's because it's 5, but 6 if you count the telson itself. So
Now I know you're going to get to it later, but do these guys make a big impact in the Carboniferous like the insects do? Are they grow big sizes too, or?
Yeah. Oh, yeah. We got Pulmonoscorpius. The biggest scorpions that ever lived during the Carboniferous. Some of my favorites, and they were big. They weren't as big as the ones that lived in the water.
Yeah.
Eras, but as far as land dwelling scorpions, they were the size of. People will say they were the size of a cat. I would say it's better to say they were the size of a squirrel.
That's still big for them.
Yeah, because if you think about the way the tail curls and everything, yeah, the weight, they'd be lighter weight, and they.
I am glad. However, I don't know if you're glad or not, but I guess I'm glad that we never reached the old seaside, the big size of the scorpions underwater in the past that do on land in present day.
Yeah, be like Clash of the Titans, fighting giant scorpions on your way to school every day. Yeah, so the segments here, what it's calling post abdomen, segments 5 through 13. Those are the segments that are going to fuse into the metasomal segments in the scorpion. Now, all modern arachnids came with that fusion already pre-installed. They don't have this many segments. They really only have the abdomen, and here it's called pre-abdomen. They have this cephalothorax in a lot of arachnids, but that's gonna be a recurring feature that we see in all arthropods that we call carcinization. That means the more specialized they get into a niche, the more likely it is for future generations to lose body segments along the way. The more and more specialized they get to a niche, the more segments they lose, which is really fun when we get down to, like I was talking about at the very beginning, harvestmen, which only have one body segment left. They're just the butt and the legs.
And there's also a very misconception, like harvestmen are not spiders.
And they're not venomous, right?
Yes, also,
no venom. Yeah. And they're one of the few arachnids that can be that'll eat.
I think the group is called Opiliones, right?
Yep, Opiliones.
Mm-hmm. Yes.
Yeah, we talked about
they are closer to scorpions, I believe, right? Or are they than the spider? Yeah.
Yeah, so they are, and they're a lot more diverse than what you see, in your backyard. Till you get down to like jungles and stuff. Oh my gosh, they're so beautiful and diverse. Some of them are ornamented. Some of them are colorful. Some of them glow in the dark. I used to have some glow in the dark ones when I was younger, but I should get some more.
Just like scorpions. Cool. Yeah, scorpions also glow in the dark for some reason. Yeah.
Yeah, there's something that helped to do. I imagine it's something to do with their nocturnal behavior and their need to absorb certain wavelengths of light for their metabolism is my speculation, but I don't know for sure. It's all speculation on my end.
Yeah,
it's still a big mystery. Yeah, it's still a big mystery. Maybe there is no reason. There's also a possibility that maybe they just acquired like a fluorescent protein and it's just stuck around for some.
Yeah, like did you see that they put the glow in the dark gene in the cats?
Yes.
It was just a byproduct. Yeah.
Yeah, before you got here, we were talking about how sea spiders aren't true spiders. How names can be. They give them names, but they're not. The people name things, and later on, look, these aren't related at all.
It's folk taxonomy gets a lot of things off when it comes to arthropods, especially. Like there's little less confusion when it comes to like vertebrates. Like, oh, a fish is a fish, although even though that that has problems too, ironically enough. But yeah, it's like it's things that aren't spiders are called spiders. Things that aren't scorpions are called scorpions, and
Things that
very
aren't
much-
lizards are
yeah.
called lizards.
Yeah, also, yeah.
Well,
Yeah,
so
Yeah, unfortunately,
Mhm.
it's first come, first server names.
so there's the major ones that you think of when you think of arachnids, and those are mostly the tetrapulmonata, which is scorpions, spiders, amblypygids, and thelyphonids, which is like the whip scorpions. Then the amblypygids are the tailless whip scorpions or cave spiders, or whatever you want to call them. Those are the tetrapulmonata. And then outside of that, you have the pseudoscorpions, you have ticks and mites and acaria. And then you have closely related to mites, actually, a solifugids, the camel spiders. And you see that with how furry they are, how fuzzy they are, and how soft their bodies are. They have a lot in common with mites when you really look at them.
Oh yeah, like it's a very it's if you blow up a mite, then you can see the resemblance between a solfugid, yeah.
So Bree, if you
exactly.
go back and rename something, what would you rename something? If you go back in time and rename something in the tectonic record or cladogram, what would you rename?
Oh my gosh! If it does have to be an arachnid?
No, like anything you're like, that's a bad name for that thing. Like what they name?
Oh no, I would go back and change Basilosaurus to Zeuglodon if I had an option to do anything like that. I hope everybody would. So I think calling it a Basilosaurus is yeah.
Well, according to I see a phylogeny on Wikipedia for mites, and it says that the mites and the ticks are separate groups. They are not monophyletic.
Yeah, you got Parasitoforma, and then
yes,
there is another group that's got the Racinonuli and Solifugids and Opilians, and you got Acariforms, which Acariforms are also mites. They're the little red guys. And then pseudoscorpions are their own thing too. Yes,
they are closely to the Parasitoformes, the ticks.
Mm-hmm.
Yes, the false scorpions are closely to the ticks, and you have the solfugids are closely related to the vegan mites that don't suck blood, or at least some of them actually do suck blood too. Mites,
some of them are detritivores and some of them are predators. So there's a few.
We have a question for you.
Yeah, so scorpions' claws are not venomous. There's no venom in any claws of any arachnid that I can think of off the top of my head. I don't think any of them would have what you'd call venomous claws. No.
The claws in scorpions, they are they the chelicerates? Or I think they are not the chelicerates, right? Or are they?
They are the developed pedipalps.
Yeah, in scorpions, I think the big claws are the pedipalps, right?
Mm-hmm. Yeah, which is not convergent, which is analogous with what developed into the fangs for spiders. Now,
no, I think in the fangs in spiders are the chelicerates.
Oh yeah, I got that. Sorry, yeah. I'm mixing myself up here. So they're in spiders. They developed into the reproductive. With the bulbs on the end. Sorry, it's been a long day.
Yeah, the pincers in scorpions are the pedipalps.
Mm-hmm.
Yeah.
And they have but their chelicera are also little pinchers if you look.
Yeah, yes, they are. And they're very, very close to the mouth. That they chew the food before they digest, they ingest it. Yeah.
Very much analogous with the mandibles of Mandibulata. Ironically enough.
Speaking of claws, here's some pictures of.
Yeah, look at the size of these Eurypterids. You got Jackalopteris on the far end in the blue is the.
Real fast. You said that Ariparids aren't true scorpions, but are they arachnids?
No, they're not arachnids. They're
Okay.
a sister clade to arachnids.
Yes.
They're closely related, though, to arachnids. They have a lot of things in common. As you can see, though, from these models, they have specialized back legs that are paddles for swimming. You can see a lot of convergence with what would come later from the tetrapods that return back to the sea and how their body plans would develop with the large paddles on either side to help steer and navigate in a large flat tail. These guys are basically built like manatees if you look at them. That's what's so cool about them to me.
Most of them have these like these fluke on the end, except for the pink one, the one on the second right, the pink one. It has a more of a stout shape.
But unlike manatees, I doubt most of any of these ate plants.
No, they probably were eating small crustaceans and stuff. They'd grab them with those claws and crack their shells, and
those claws are the chelicerates, right? Like the claws in
yes, in Eurypterids, these are the chelicerates. They're the same structurally as the chelicerates or chelicerate in scorpions and true scorpions.
Yeah,
but in true scorpions, they're just so tiny. They're just these same type of claws, but just super tiny. Eurypterids also have
different appendage.
These guys might have hunted our ancestors.
Probably, I'm sure they probably did. Anything soft, they little sucky mouths, like a sucky hole. And that's the main thing that I like about these guys is that they filled this niche where they have the same body plan as things that would come much later. I said tetrapods, but there are other organisms that filled this niche too that aren't tetrapods, I guess. Not many, but some.
Like would these guys swim to catch their prey? Or I think some of them may have, because otherwise, why would you have a fluke on the end?
I don't think any of them were particularly fast. But I imagine if it hadn't been for that big catastrophe, that we might have seen. Because you can see the tail starting to fork off on the Jackalopteryx on the end there. See how it's starting to lobe out into two separate paddles. That's when you start moving a lot faster, right?
Yeah, I might be wrong in my history, but I don't. When these guys were in their heyday, I don't think our ancestors even had jaws yet.
No, we had like a notochord. We didn't even have bones. Well, did we? I don't know. Hold on. I might be misspeaking.
Oh, at that time, vertebrates had bone, but only on the outside. Like they had an armor of bone, and the inside was still cartilage.
The Raptorigians, then, is that what we're looking at?
They were armored, but still jawless fish.
Okay.
I think during the Silurian at least. I think at the end of the Silurian, then you have the first appearance of like jawed.
Then we can fight back or bite back.
Yeah, I'm looking at the Silurian right now, trying to see what kind of faunal exchange they had with from land to sea. See if there's any land. Sorry, go ahead.
So according to this chart, even if we were alive back then, we would have a problem because all these things were bigger than any of us as fully grown humans.
Oh yeah. Well, I don't think that they would have been. This is the thing that I talked to when I was on helping someone do a tier list of prehistoric animals, and it got to who would win a Neanderthal or not Neanderthal, an Australopithecine versus an Arthropleura. Unfortunately, despite the hype you might see in fiction and like even these pseudo documentaries, these arthropods are not like incredibly like strong. Like you could probably overpower one physically.
Yeah, it would have won the one probably. But I don't know if they got
Mhm.
if they got you in a if they got you a sneak attack.
Yeah, you could get swarmed by something, sure, but yeah, it's like their claws, because their claws aren't evolved to deal with large prey. They're the biggest thing in the water. Those claws don't have to be strong and stronger. Well, I mean
Yeah, the
claws on most.
I say back when we were little filter feeders, then yeah, that were no match for him. But maybe now we could pick up a fight.
Yeah, the claws on most of these guys were thought to have been crushing, like hard-bodied, like crustaceans, and they're not crustaceans, but trilobites and stuff, things filling that niche. But yeah, they probably would not have passed up on snacking on your ancestors if given the opportunity.
So do you know which of these which each of these are, or each of these species are?
Well, I mean, they're all different species of large aquatic Eurypterids. Jackalopteryx is actually the biggest. I've seen the fossil list in the Field Museum, but yeah, just slightly different niches and different time periods. No, I don't have these like laid out to which one lived when and what type of environment they lived in or anything. Just laid out by size for us here.
We just know that none of them are around anymore.
Yeah, and this is not chronological. This is specifically, I believe this is mass based. So yeah. Yeah, talking about some of the body parts on these early Chelicera.
Wait, like I think you also have seen this study like a few years ago. There was a study which says that the horseshoe crabs are within the arachnids.
Yeah,
Yeah,
they do. They go in and out, and different people will do different different.
It goes back and forth, and for now, I will say that they are not inside. It's the safest assumption for now.
Yeah.
I'm still open to the possibility, but it's still uncertain.
If they are arachnids, they are the most basal of arachnids. I'll say that they still have a lot of conditions that that all the other arachnids left behind in the Paleozoic, like all them damn legs, because other arachnids don't have quite as many legs as a horseshoe crab.
It's pretty weird because the like in that study where they placed the horseshoe crabs within the arachnids, they placed it pretty deeply in the arachnid group. Like the closest relatives are the Rhysae nuliae and also the solvigids. So according to them, they are very close.
Wow.
Horseshoe crabs are close to. Of course, I'm skeptical about that. Yeah. Xyphosura, yes, the horseshoe crabs.
And they placed it like as a sister clade, like within the closest related to the solifugis, as we covered in a previous slide.
According to this study, the sister group is called the Rhysae nuliae. It's a very obscure group, and the next closest related group is the solvigids and the Palpicredi, another obscure.
Yeah. So when we were talking about the solifugids being closest related to mites, that's the group, the Reclinui or whatever. Right? I think that's what it was.
The Rhysae nuliae. I don't know how you pronounce it correctly, but it's a very. They are. Oh, the common name is hooded thick spiders. That's the common name. Hooded thick spiders.
Yeah. And they're velvety. Like a
I don't think they are mites. I don't think they are mites.
No, they're closer related to solifugids. Yeah. There's also little tiny arachnids that are closely related to whip-tailed scorpions that are so tiny that are in their own unique clades and look like pseudo scorpions, but are their own thing. Yeah, hit that like, share, and all that good stuff. The claws remind me of scissors a little. Yeah, some of the claws are designed for shearing, and some of them for crushing. Some of them for holding on to things. So it just depends on what they're doing. A good rule of thumb with like a scorpion, though, is that if it has a fat tail and small hands, it's very venomous. If it has big hands and a skinny tail, it's probably going to be all right. If it stings you, you probably won't need to go to the hospital. But in my opinion, you should always go to the hospital because you don't know what kind of allergic reaction you're going to have. But that's just me.
Mm-hmm.
Have you ever been stung by one of these a scorpion or a spider before?
I've never been tagged by an arachnid, only insects.
Yeah, I've been stung by a yellow jacket once.
Mm-hmm.
When I was like about 8 years old, I think, like a very, very long time ago.
I put on a pair of pants once that had a wasp in it, and it was an experience. I'll just say that. The wasp wanted out, and I wanted the wasp out, and I think the wasp thought I wanted him in there, so he kept telling me to let him out by showing me how much he hated being in there, and it was painful. Couldn't get those pants off fast enough, but this was back in the early 90s when my mama had me wearing tight jeans and a freaking belt and stuff.
Did you both survive?
No, I think he actually did not survive.
Well, I'm pretty sure. I think you survived at least. I think.
Yeah, I believe I did, but I could be that we transferred souls. I could be the wasp, and Bree could have died that day.
And that's how your love of insects happened. You became one.
Yep, that venom soaked into my pores.
I do see that, like again, as I mentioned before, the study that put the hooded tick spiders as sister to the horseshoe crabs, but there was a response study that put the hooded tick spiders alongside the harvestmen. So yeah, it's a lot of discussions around exactly where groups belong.
Yeah, this is something we did run into when I was working with Aaron on this stuff too. I was like, a lot of the stuff's up in the air. What is a spider? What is an arachnid? That's all not even clearly defined at this point. So,
I think they're also very, very understudied. Surprisingly, even though spiders are very cool, even within spiders, they are very understudied.
So did you help Aaron with his this section of his phylogeny tree?
Yeah, yep, I sure did. The whole arachnid branch, and if he decides to do a insect one, we'll probably help him with that too. I'm just really excited to be a part of it. Now, I want you all again to, I keep harkening back to this, but I want you all again to look at this body plan and then think of like an aerial shot of a whale, right?
Mm-hmm. They have paddles. They have almost like flippers. Yeah.
Mm-hmm.
Did they use these paddles for power or mostly for steering? These. Do you know?
I think that the depending on the species, but the paddles were the paddles. I guess calling them paddles is fine. They were mobile. Yeah. So they use those for powers and the tail for steering. But I think that some of the later species that might have flip-flopped, but I'd have to look into that to be sure.
I think it would be more efficient to use your tail for power and then the front for mostly for steering. Yeah.
And a more derived one like this for sure. I think that in the way that this body plan corresponds with a whale, I can see it moving its tail up and down as a way of locomotion.
Now, have either of you seen a series on, I forget what it was on, but it was called Animal Armageddon?
Yeah.
Yeah. I remember when these guys were fighting those giant Nordic cord things, cones. for dominance in that series.
Oh, sorry, I'll be right back. Oh,
All right.
So
I would
I
think
just
there
wanted
are
to close
some.
the door.
Mhm. But I would think there are some relationships that are firmly established. Like I think it is fairly certain that spiders are more closely related to the let's see the Ambly PGI than they are to scorpions, right? That's
So,
pretty certain. Yeah.
oh, hold on, I lost my place here. So, where was
Yeah,
it?
I can also see here that you have the tailed or
Had my favorite
the whip
cladogram.
scorpions. The whip scorpions are more closely related to spiders than they are to the scorpions. Yeah. Like those things are certain, but they're like a half dozen obscure, like very obscure arachnid groups that are very understudied. Yeah.
Yeah, there's groups that are close related to spiders that are not around anymore, but they're different. Like how do you say this?
Yeah.
Trigonoturbidia.
I see it here.
You
Yeah.
got
Yeah.
and then you got things like Haptopoda.
I think
So
it's pronounced Triganotarbids. Yeah. Triganotarbids.
Trigonotarbids. I'm not mocking your accent. I'm trying to say it right.
Like at least that's how I would pronounce it, but I don't know the correct pronunciation.
Ooh, are we getting into the embryology now? This is some weird and fun stuff. You can actually see the embryo developing its legs and its breathing parts. This is really cool. So the upper
really
left
weird.
is the early. The upper left is the early stage of a protostome embryological development. The lower left is the development of segment growth. The right shows the segments as they develop. The primary nerve system is that controls the ganglia is shown in red. The blue is the digestive tract. Each segment is developed from precursor cells, also called a blast cell. I think you guys know what a blast cell is, right? Or simply a blast. They are a particularly differentiated cell, usually referred to as an unipotent cell that has lost most of its stem cell properties. Each segment, as it develops, mirrors the previous one. This will include Hox genes mirroring the set before them until they start to specialize. And then I think the next slide should show how some of this stuff specializes. But if you got questions about what we're looking at here, the coolest thing about this is when we watch the embryological development of any arachnid, any arthropod, really at the early stages. The coolest part about it is right after the one on the image on the right. Right after that, you start to see the fusion happen, but early on they all look like little centipedes. They all have a full length of little leg nubs or proto legs that are going to fuse. It's really cool.
Yeah, and a lot of embryological photos they mainly show vertebrates, but we don't show have a lot of embryo footage comparisons for this side of the family tree.
Right. Yeah, you don't get to see a lot of protostome development because we are Deuterostome, so everybody wants to talk about Deuterostomes, but protostomes are really cool in the way that they develop and the way that they segment, and this is why they can do certain things that we can't, like grow a new body underneath their existing body, because they can each segment can produce its own exoskeleton independently from those around it.
Yeah, there's no molting humans.
Right.
Unless you get sunburned, then there is. Because I definitely molted then.
All right, this is where we're talking about the specialization of the legs. Seeing some of the stuff that they switch into and the different functions that they are able to perform after they develop. There's I know it looks pretty bizarre. You got things with like whippy tendrils on them. You got things with spikes and claws. All sorts of functions available for these organisms. Some of these are used to help stir oxygen from the water into those feathery gills that we talked about earlier that existed underneath. They're called book gills. They're underneath the organism. So those are the predecessors to something called book lungs, which will be irreplaceable in the journey onto land for arachnids shortly after all this diversification.
They basically internalize the gills almost, right?
Mm-hmm.
Yeah.
Yep. Yeah. You can see that they're like an early Chelicera. They're all feathery on the outside, and as we move through time, they start to get up underneath, and you see them kind of internalize. It's really cool.
So we got normal lungs, and they got to read while they have their lungs, book lungs. They get to read.
Well, book lungs are the reason they're called book lungs is because they do have like pages in between them. They have to keep them moist, but they can absorb the oxygen and put it into the bloodstream. Or did I say bloodstream? I mean that again, speaking colloquially, it's really a hemolyth
hemolyth. Yeah.
Mm-hmm.
It's basically that their organs are bathed in a fluid that's like it's sloshing around a bit. I think they do have a heart, but it's not like a closed. It's not a closed.
It's also
system. Yeah.
Its functions are multifaceted because hemolyth is also the liquid that they use to pump their hydrostatic skeleton to move. So different pressures, different pressure levels on the hemolyth in different parts of the body is how they move their legs from one position to the other. That's fun stuff, huh? Did you guys know that?
In arachnids, well, in all or in most arthropods, is that okay? So I think.
Yeah, it's hydrostatic. Yeah, almost all arthropods. I don't want to say all because that's a kind of.
I think in the crustaceans there are muscles that attach to the outside exoskeleton, right? Leverage.
Well, within Chelicerata, that's it is hydrostatic because that's why they curl up when they die, right? Because there's no more pressure of the hemolyth. But there is a muscle structure. It's controlled by that ganglia. Each segment has 2 lobes on either side of it, right? And those lobes, the ganglia can send signals to expand or retract those little lobes. And when those lobes expand, it pushes the hemolyth that's around them, the same hemolyth that's carrying the oxygen, pushes it into pressurized chambers in the limb joints that cause them to move forward and backwards. It's very mechanical. It's very very weird. And there's this scientist who actually built a little robot thing with a needle that could tap into that hydraulic structure, and he could make robot spiders out of dead spiders. And it was pretty cool. It like injected this thing through the ganglia so he could control how it moves. I don't think he had it crawling or anything. He just had it grabbing stuff, but still. But yeah, with crustaceans, I'm not as confident at all about them being hydrostatic. I am confident about Mandibulata being derived from hydrostatic organisms, though. Definitely, because they come from like organisms that were like velvet worms, right?
So what are we looking at? What are we looking at here?
So this is how different arthropod groups develop their limb structures. So you see what parts of the organism turn into what for each clade. Starting from the right, you got hexapods, which are insects and crustaceans are next to them. And then we have myriapods. So those are your mandibulates right there. And you can see that they all have somewhat similar structures to how their limbs and things are laid out.
I do have a question.
Uh-huh.
Why is there a cross next to arthropoda? Aren't they still alive? Cross usually mean they're dead.
Where are you seeing that? Are you talking about Artiopoda?
Oh,
Artiopoda is a little different.
Okay.
So it's
Never mind then.
It's a yeah. But the two central ones are our chelicerates that we're looking at, right? So you can see what's developed into what. I like how there's a question mark by the Pycnogonida. It's like what we don't know what this is, but you see the yellow.
They are very weird. These sea spiders, yeah.
Mhm.
And I think it's also still an open question whether they are close to chelicerates or maybe they are even a group outside the mandibulate and chelicerate group.
Yeah, something basal, more basal, and I think Aaron actually found an article that said that they were maybe closer related to Artiopoda, which would be interesting. But yeah, so.
Oh, I actually have to go soon, so I thank you for having me.
No problem.
Will catch you later.
Yeah, thank you so much for being willing to pop in and hang out with us.
Yeah, you can always comment in the comment section later on stuff that we want to talk about. You wanted to talk about.
All right. Bye, guys.
Bye. So the red on here is the Hypistomolabrum complex. The yellow is antenna in the mandibulates, but in the chelicera, it's the chelicera. So that's what you're seeing in yellow there. Then you got the blue, and that is like an appendage. And then in the chelicerates, it's actually the pedipalps. Oh.
So are these like genes are these like genes or what?
Yeah, it's showing which genes are controlling the growth of which limb type or which Hox genes are in control of the development here.
So do we know why these first three bit the dust?
Well, I mean, just didn't survive extinction events. I don't think there's anything inherent about their structure or anything. There was a reason that they didn't make it. Just happenstance of whatever niche they were filling and whatever impact the ecology that caused them to die out. So here we have some artistic interpretations.
Oh, so these aren't photographs?
No, they didn't actually go back and get real photos. But these are artistic interpretations of what early arachnids that first emerged from the sea may have looked like. Mm-hmm.
Would you have these? Would you have any? If you could, would you have these in your aquarium at your house?
I wish. They're pretty big. This is supposed to be Pulmonoscorpius, but I don't think it looks anything like it, according to the description of the image. Doesn't look anything like a scorpion. Let's say a terrestrial Eurypterid. Oh, never mind. It's labeled wrong. Okay, that's supposed to go down here on this next slide. Yeah, there's a giant land scorpion. All right, there's our Pulmonoscorpion, which is the one that I was talking about being the size of a squirrel. And it had long, narrow claws.
Is he hunting these guys down here?
I imagine that's the idea of the artist here. There's also been speculation that these were fishing claws, so that's an idea too. So it's hard to say for sure what they ate, but they had lungs. That's the important thing. And here's the actual fossil of the organism. I wish somebody could find me a real replica of this. I can't find it. It looks like I'm like bone clone and stuff. This, if there's any fossil that I could ever get, it'd be Pulmonoscorpion kirkinsonensis.
Now, is the whole thing the fossil, or just the rock, and the other parts are like artist stuff?
All of this is the fossil that was found.
Okay.
Everything you see, even the parts that are separated from the main fossil, those were just cut out separately from the main rock. Yeah, I would love a replica of this with like maybe a red velvet background to it. That would be amazing.
More family
Okay.
trees now.
Yeah, let's get into it. Let me see. We're looking at, which one are we on? Pantetra pulmonata. I'm able, if I can just type it into my document, I can pull it right up. Okay, let's take a Pantetra. Okay. So this is the group that contains whip scorpions, amblypygids, and Arachnia, which are spiders. They Tetra pulmonata, tetra, like tetrapod. It's talking about its legs. Pulmonata, pulmona is lungs. So legs and lungs are what we're looking at. Now there's two splits to Tetra pulmonata, the Schizotorsata and the Sericodiastida. The Arachnia is in the bottom clade that I'm not going to say again because that was a tongue twister enough, along with the extinct Arachnid. And then the other group, you have Haptopoda, which is extinct, and then you have Pedipalpi, which has a lot of cool extant species, including the whip scorpions and tailless whip scorpions and all the amblypygids and Felifonida. So that's these clades right here. As far as the Trigonotarbida, that's the one me and Ness were talking about earlier. That was very much like a giant mite that filled a niche like a spider, but you know it wasn't.
By the way, if anybody wants to see Bree's notes, they are in the description below.
Yeah.
If you ever want to check up and say, "Oh, that's cool," or "That's wrong."
Yeah, please tell me if I get anything wrong. Yeah, I'm not head in the clouds and everything. I got all this right. I study this stuff for fun. You know.
Yeah, unlike like some people, we can when we're wrong, we can admit it.
Yeah, I make probably lots of mistakes every day. I try to do better. All right. Probably got about 10 minutes more left that I can stick around with you. You want to see how many more slides we can get through? I think that's the same one we were just looking at. Ooh, Chimera arachne. This is the spider that still had a telson that they found in the amber. I believe it was in Myanmar. Let me see. Chimera arachne was found. Yep, Myanmar and Burmese amber or Myanmar amber. It is a I guess you could say it's closely related to spiders, but it sits outside of the all living spider clades. It doesn't belong to any of these extant groups, but it had a very, as you can see, a very unique armored appearance, like what we see in basal spiders, like like the armored trapdoor spiders. Next slide. All right, so here we're looking at some venom discussion. So we have also the. Can you make that any bigger? I'm having a hard time seeing it.
Let me see if this will
slide pulled up.
Uh,
oh yeah, I do. Here, I found my copy of it.
any better?
Yeah. So the ones with the green are the ones that have that do produce venom. So you're talking about the pseudoscorpions, the scorpions, and the arachnia. Everything else on here, all other arachnids, are non-venomous. And as you can see how the clades are divided up, you have your tetrapulmonata, like we talked about a moment ago, with your arachnia, amblypygids, and theliophonida. And then your scorpions are also included in there under arachnopulmonata. And of course, scorpions having their famously venomous sting, and pseudoscorpions having a venomous bite. And then we have the other branch of arachnida, which is Parasitiformes, Solifugida, Ricinulia. That's the clade that he was saying that they showed that horseshoe crabs were closely related to, interestingly enough. Opilions, and then a cariform. Or cariformes.
And the bottom ones are nuclear powered? Is that the
yes. No, they're can't you see that they're toxic? That's not nuclear. Nuclear is like the triangles, right? With the circle in the middle. I hope I didn't get that wrong. That should be biohazard.
Either way, I'm staying away from it.
Yeah, I wouldn't go anywhere near anything that says biohazard on it. All right, here's talking about some scorpion body parts. You have, starting from because it's hard to read, I see. Starting from the top left, you have carapace, and then the right is showing the chelicera. Also, you know what? I'll go down the left and then the right. So on the left is carapace, leg 1, leg 2, leg 3, leg 4. Then a metasoma segment 1, 2, 3, 4, 5, and the telson. And then going down the right side, we have the chelicera and the pedipalp. And then we show the divide between the prosoma and the opithsoma. Then you got the different pterygite segments, the metasomal pterygite 1, metasomal pterygite 2, metasomal pterygite 3, metasomal pterygite 4, metasomal pterygite 5, mesosomal pterygite 6. And then you got the mesosomal pterygite 7, and also the legs 4, 5, 6, 7, 8. Yeah. And so forth. So those are the parts of our scorpion. All right. And here's another example of the development of different mouth parts among these different arthropods. And this one does include some tardigrades, so you can kind of see what's going on. Whereas in the velvet worms on the far left and the tardigrades, the front portion is the head. The second section on the velvet worms is actually the jaws. It's walking legs on tardigrades, and it's nice. Slime glands is the next on the on the list for a velvet worm. Walking legs, more walking legs for tardigrades. Tardigrades love their walking legs. So moving into your arthropoda, we got chelicera, which is chelicerata, which is our topic of the day, showing its head portion. Then it's chelicera with its pinchy little parts, and then we got pedipalps behind that. Myriapoda, you got antenna. Same thing with pancrustacea, which does include insects, and then behind the antenna in pancrustacea, you got antenna too. But in Myriapoda, you got intracalcary segments, which in centipedes, by the way, are forceptuals that have venom glands on them called toxogontophorids, I believe is the proper terminology for them. Anyway, yep.
Next one.
All right, some embryology, some more embryology here. This is a development of the segments of the arachnid developing, and you can see that the legs, they start off with multiple legs, way more than the 8 that you expect from an arachnid before they fuse in development. So every arthropod is a centipede for a little bit. In a way, it's like, what do you call it, recapitulation.
Evo Devo.
Mm-hmm. This is just another one like the one we looked at previously. Just it gives us more details. Now we are looking at mouth parts and antenna of different arthropods. I don't know if this is going to be relevant to what we're looking at here exactly, because chelicera's don't have antenna, so I'm not sure how this slides. Why this slides even in here? Sorry, audience. Hate to disappoint.
The sliding
All right.
thing?
This slide is showing early development of arthropods and what we find in the Burgess Shale. Mm-hmm. More breakdown of the structure of mouth and body parts. These were really important to what we were trying to cover on the topic that we were talking about. But you want to just pop out and do some see if we got any questions from the audience before we wrap up?
Sure. Some of these last slides real fast.
Yeah.
And finally, this.
Yep, there's a nice cladogram for us. How to divide up your arachnids. Right. Spiders are ambush predators. Yes, that's true, Eddie.
Anybody have any questions?
Did you just kick me?
No. Not.
Hi. There I am. Hey, does anybody have any questions? Let's see. Eddie's been dropping some questions or some commentary here. These creatures come in all different sizes, that's for sure. Yeah. Chelicerates are a diverse group, and arachnids are a diverse group within that diverse group. Absolutely. And I find them all quite fascinating. He says spiders are ambush predators. That's absolutely true. Some spiders are pursuit predators, though, so we can't always shoehorn all of them into one category. The majority of spiders are ambush predators.
So how come none of these guys ever decided to become vegetarians?
There is a spider, jumping spider called something Kipling. It's named after Kipling from Jungle Book fame, Rudyard Kipling. But it's a jumping spider that lives off of seeds. So yeah, it's not. It's the only known spider that doesn't eat predatory or have a predatory diet. Now, harvestmen, Opiliones, which Nestle had mentioned earlier, they also will eat like plant matter and stuff. So yeah.
Cool. Well, anything coming up on your channel that you want to advertise for?
Yeah. Tomorrow I got Creation Watch. We're returning to the Black Goo. That's tomorrow afternoon at 2:30. So don't miss it.
And for me, in about 2 weeks, I'll be having my season finale as we talk about the fall, the Roman Republic.
Woo! All right.
See how a republic became an empire, and sadly, it wasn't the same way it happened in Return of the Sith. No lightsaber battles on volcanoes, but it was still interesting.
Yeah.
We do have a question.
Oh, sorry, I didn't even have my screen up. Are there any non-venomous spiders? So all spiders are going to inject some sort of enzyme to break down their food because they don't have the mouth parts to eat solid food. So they have to liquefy whatever they're eating. That's generally the job of what we call venom. However, there are some species that are functionally non-venomous. Some like a hackle or weaver spiders, for instance, that have really good, strong webs. They don't have venom that's going to be too effective against anything. But they just need the digestive enzyme. But there is it's called the crebolate orb weaver or hackled orb weaver that is doesn't have the venom glands. It's lost them secondarily because it's just so good at catching its prey with silk. It doesn't need them. But yeah, it still does the digestive enzymes though, so there's still something happening there as far as having a toxic effect on the biology of its prey.
Cool. Well, I wish we had time to show the videos that you wanted to show, but maybe we can do that in a part 2 in the future.
Yeah, we can revisit that. I was just worried if there was going to be too much silence, but we talked through the whole thing, so that's fine.
Well, thanks everyone for coming. Thanks again for Bree for being on the channel again and showing his knowledge about his passion. Her passion.
All right, yeah. Thank you for having me on.
And as always, never stop learning. Enjoy the randomness. I'll see you next time. Bye.
Bye.
Stand by me.